Welcome to Intellipaat's DevOps Full Course, the ultimate tutorial to master DevOps from scratch in 2025. If you're looking for the best DevOps course that actually makes you industry ready, this is it. This DevOps tutorial isn't just filled with definitions or theory. It's a practical roadmap built on real-world DevOps workflows, what recruiters are hiring for, and the tools top engineers use every day. So what exactly is DevOps and why are companies from fast-growing startups to massive enterprises investing in DevOps engineers like never before? Well, that's because DevOps bridges the gap between developers who write the code and operations who manages the servers and keep everything running smoothly. It helps the teams work together better, release faster, and ship with confidence and automate everything from code to cloud. And in this full course, we will start from basics like what DevOps is, how it works, and what a DevOps engineer actually does. We will also guide you step by step from building your first CI/CD pipeline to automating cloud deployments, and even creating a real-world containerized microservices using Docker and Kubernetes. We'll start by understanding the DevOps lifecycle and provide step-by-step guidance on becoming DevOps engineer in 2025. We will also cover tools like Git, Jenkins CI/CD, Docker, Kubernetes, Terraform, and monitoring tools, all explained in a simple beginner-friendly language. And here's the best part. We will also show you how to automate the GitOps by building your own MCP server for GitHub, so deployments can run on autopilot. So whether you're looking for a job, planning a career switch, or just want to dive into one of the hottest skills in tech, this DevOps tutorial is all you need. So grab your coffee, stay till the end, and let's dive into the most value-packed DevOps course in 2025.
Knight Capital, one of the biggest trading firms on Wall Street back in 2012, deployed new trading software to their production environment. But because of a mistake while updating the software, some old code accidentally got turned on again. Within minutes, their system began executing a series of unintended stock trades. The damage, over $440 million lost in just 45 minutes. One small deployment error and it almost wiped out a billion-dollar firm. But here's the thing, the development team had written the code, the operation team had deployed it. Both did their part, but the lack of coordination between them led to one of the most expensive mistakes in the tech history. This is the kind of chaos that DevOps is designed to prevent. Now let's take a look at the DevOps logo, that infinity loop. It's just not a design, it tells the whole story of how modern software is built, delivered, and continuously improved. On the left side of the loop, you have the development process. This is where teams plan feature, write code, build their projects, and test them thoroughly. On the right side, you have operation, the stage where code is released, deployed to live servers, monitored for performance, and maintained day in and day out. And here's the key part, the process is never ending. Feedback from operation side loop right back into planning and development, making each cycle faster, smoother, and smarter than before. That's the beauty of DevOps. Instead of working in isolation and blaming each other when things go wrong, developers and operation team work together, share the responsibility, and automate as much as they can. This collaborative approach helps deliver better software quicker and within fewer errors. In this video, I am going to take you through a complete roadmap to become a DevOps engineer. We are going to cover all the tools you need to learn, point you free resources, and explain why companies are offering some of the highest salary in tech for these skills. But before we dive into the roadmap, let's quickly cover three basic questions. First, what is DevOps? DevOps is a culture and a set of practices that blends software development and IT operation into one smooth continuous process. Second, who is a DevOps engineer? A DevOps engineer is the person who bridges the gap between writing code and running it live. They build and manage the automated pipelines that keep everything running like clockwork. And third, who should learn DevOps? If you love problem solving, enjoy automative repetitive tasks, or just want to be at the center of how tech systems actually work, then DevOps is definitely for you. Alright, before we move ahead, let's quickly go through what the entire roadmap looks like just to give you a clear picture of the journey. We will start by learning a programming language like Python, then move on to networking basics and Linux, the most foundation of most DevOps system. After then, we dive into Git and version control, followed by cloud platform like AWS or Azure. Next comes Docker for containerization and Kubernetes for orchestration. We then explore service-based tools like AWS Lambda and infrastructure services like Nginx and Redis. Automation is handled through CI/CD tools like Jenkins, and we wrap up with infrastructure as code using Terraform and monitoring tools like Prometheus and Grafana. Step by step, this roadmap builds everything you need to become a DevOps engineer. Now that we have seen how our roadmap will look like, let's see a detailed version of the same. First, start with Python, which will take you around 3 to 4 weeks. To begin your DevOps journey, learn Python. Why? Because Python helps you automate boring and repetitive tasks. Let's say you have 100 servers running and you want to shut down the idle ones. Doing it manually would take forever. But with Python, you can write a small script to check server uses and shut them automatically. It's also useful for writing script that back up files, clean logs, send alerts, or interact with cloud APIs in Python. In Python, learn things like syntax and data structures like Python syntax, list, dictionary, set, tuple. Modules and packages like importing and using libraries, writing and executing Python script, file handling, reading from and writing to files, error handling, and basic web scraping using libraries like Beautiful Soap, Request. To learn Python scripting for DevOps, you can refer to the free Learn Quest course available on Coursera. You can watch all lectures from this course absolutely free. Or if you're frantic of learning from documentation, you can refer to Python's official documentation. Now that you can write script, it's the time to understand where they will run. Most likely on a Linux server. Linux is the operating system used by almost every cloud server. You will need to know how to navigate the file system, change permission, restart services, and check logs. Imagine your app crashes in production. You should be able to jump into the terminal, find the log files, read the error using grep, and restart the service using systemctl. That is where Linux comes in action. In Linux, cover basic command file system hierarchy, then comes your permission command like chmod, and get yourself familiar with shell scripting basics like variable loops. This will take you around 2 to 3 weeks to cover. You can check this Linux tutorial by Intellipaat or these free YouTube channels. Once you're comfortable on a Linux terminal, it's time to learn how computers talk to each other. In DevOps, services are always talking. Your app talks to a database, a user's browser talks to your server, etc. You need to know how to debug it. If your app can't connect to a database, is the database even running? Is the firewall blocking it? Is the DNS wrong? Tools like ping, curl, and traceroute help you figure out this. Grasp IP addressing, IPv4, learn OSI model and protocol, learn protocols like TCP, IP, UDP, DNS resolution, port, NAT, routing, firewalls, and tools like netstat, SS, IP tables, and curl. Know how to debug connectivity issue across services. This will take you around 2 weeks. Now that you can write script and troubleshoot system, it's time to track your work. Git helps you track changes to your code and work with others. Imagine writing a script that accidentally deletes important file. With Git, you can go back to the last working version. GitHub also acts as your online portfolio and a collaboration platform for teams. Learn version control basics like git, init, add, commit, push, pull, branching, checkout, merge, rebase, resolving merge conflicts, working with GitHub repository, pull request, and collaboration. You can learn Git by GitHub Learning Lab or Atlassian Git tutorial, which will take you around 1 week. So far, you have learned to write code, run it on Linux, and share it with Git. But what if your app works on your computer but not on someone else's? Docker solves that. Docker packages your app and everything it needs like Python version, libraries, and environment into one single container. That container runs the same anywhere, your laptop, another person's machine, or a cloud server. For example, you make a Flask web app. You Dockerize it. Now your friend can run the exact same app without installing Python or dependency. Learn about Dockerfiles, images, containers, volume, network, and Docker Compose. Practice containerizing a Python app, exposing port, and linking services. You can learn Docker from Docker's official Get Started guide. Now you need a place to deploy your Dockerized app. That's where the cloud comes in, which will take you around 4 to 6 weeks to complete. AWS lets you rent service, store files, run code or demand, and more. Let's say your Python script should run every night. On AWS, you can set it up with Lambda and CloudWatch and never touch it again. AWS gives you full control without owning any physical hardware. EC2 gives you server, S3 stores your data, and IAM manage access. Begin with IAM permission, EC2 virtual machines, S3 storage, Lambda, serverless, RDS database, CloudWatch logs, and basics of VPC, Route 53, and security group. You can learn AWS from these YouTube tutorials. For this, you can refer to these videos in which topics are explained very simply. Now that your code is on GitHub and you know Docker and AWS, it's time to automate everything. With Jenkins, every time you push code to GitHub, it can automatically build a Docker image, run tests, and deploy the app to AWS. You don't have to do anything manually. This is called continuous integration and continuous deployment, CI/CD. It makes your work faster, more reliable, and scalable. Learn pipeline concepts, freestyle and declarative, setting up Jenkins job, GitHub integration, triggers using Docker in pipelines, and deploying to AWS. So far, you can run your app in a Docker container, but what if your app becomes popular overnight and thousands of users shows up? Kubernetes helps you manage and scale those containers. It restarts them if they crash, spread traffic across them, and even increase the number of containers if traffic spikes. Say for example, you deploy your web app using Kubernetes. Then traffic increases. Kubernetes launches more containers automatically to handle the load. When the traffic drops, it scales them down. So learn about pods, deployment, services, config BAP, secret, namespaces, health check, auto scaling, and Helm chart. Practice running multi-container app using Minikube or Kind. To complete Kubernetes, you will take around 4 to 6 weeks. Now that your app is live and scalable, you need to make it fast and reliable. Nginx serves static files like HTML, CSS, and image, and also works as a reverse proxy to route traffic to your app. HA proxy distribute incoming traffic across multiple servers so none of them get overloaded. Then Redis stores frequently used data in memory, which makes things much faster. If your app keeps requesting the same API data, Redis can cache it. Set up reverse proxy using Nginx, implement load balancing with HA proxy, configure Redis for caching, understand rate limiting, SSL termination, and health check. These tools improve performance and reliability across your infrastructure. You now have many servers and services running, but setting them manually takes time. Ansible helps automate that. Let's say you want to install Docker and copy your code to 20 servers. With Ansible, you write one playbook and run it. And all servers are updated instantly. It uses YAML and builds on your Python and Linux skills. This will take you around 3 to 4 weeks to complete. You have learned to configure server. Now learn to build them from scratch with code. Terraform lets you write code that creates cloud resources like server, databases, and network. Instead of clicking around the AWS console, you write a file that say, I want 2 EC2 instances, a database, and a VPC. And Terraform sets it all up. It connects your Git, AWS, and Ansible knowledge into one repeatable, scalable system. You can learn Terraform from these free tutorials on YouTube. You can complete the whole Terraform concept in 3 to 4 weeks. Finally, you need to know when something breaks before user do. Prometheus collects system metrics like CPU usage, memory, and request arrays. Grafana lets you visualize that data with real-time dashboard. Let's say your app slows down. You check Grafana and see CPU usage spiked. Now you know where to look and what to fix. And this closes the loop from writing code to deploying it to monitoring it in production. You can learn Prometheus and Grafana from Prometheus official doc and from these videos. So this is all for this particular roadmap. You can check out Intellipaat's DevOps course, which covers everything in detail mentioned in this roadmap. In total, this DevOps journey will take you around 10 to 14 months if you study for 3 to 5 hours daily. Stick to this part and you will become a job-ready DevOps engineer.
In any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team and the second team is called the operations team. Right? Now, what is development team and what is operations team? A developer is basically a person who develops the code, right? He would develop the code and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he is sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operation system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system. Please check your code. It is faulty, right? But now the developer was furious, it ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps, right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking, and this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as you saw in lean methodology, where we have eliminated everything, we have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? And then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about Waterfall, Agile, Lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles, and hence releases software in even lesser days than, or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for a year, what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool. It is not a software. It's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities, and if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase, where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now comes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you know, you're operating the software or you release the software for internal employees to see whether you know, the traffic, when is it doing good when it holds when it's getting traffic onto it. Is it doing good when normal people are doing arbitrary tasks on your software? And then you are also continuously monitoring it to see if you know, your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring, again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys, is by automating this life cycle. Basically that means that now the developer does not have to give the code to the ops guy. It'll basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps life cycle actually works, right? So if you were to that infinity sign that we had, it, if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developers side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration, we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment, operation and monitoring, we call it continuous monitoring. Okay, so you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay, so this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system, that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server. Now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that Now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version, and at the same time it also holds on to the previous version, so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN. And continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another, and that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, or it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares on system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system, it is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs. It'll sort it on the basis of error logs. It'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we will get an introduction to all the tools which basically come together to create a DevOps. Right. So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay, so let's go ahead and start discussing these tools with their respective stages. So the first stage that we saw was continuous development. Now continuous development is implemented using version control systems, like I told you guys, and in most of the companies, the most used version control tool is Git. All right. So Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project. Right, so it is great for team collaboration. It is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage. Then we have continuous integration. Now you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment, and continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization, and what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system.
So quick info, guys. Intellipaat, in collaboration with Microsoft, offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor-led sessions along with self-paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI/CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies, real-time labs powered by AWS simulating production level environment, 15 plus in-demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course without a doubt can set your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.
So we are going to start with the concept of what is DevOps, okay? But before moving to DevOps, before telling you what exactly is DevOps, let me tell you a simple concept, how we work in an IT industry or in any what is the main why DevOps what is DevOps and why DevOps? First, let's understand the workflow. Say this is a group of users, okay? Or say for example, this guy has an created an application known as Zomato. Everyone uses Zomato nowadays. You have ordered food. What is this? This is an online food delivery system, right? So when Zomato, they build Zomato before, say for example, these are the set of people like who build Zomato. But before building Zomato, there must be some kind of a, there is a process for that. Let's try to understand that. Somebody first think of any business idea, right? They must have a business idea that let's start a food delivery system. This was just a thought process. After that, what they may have did, like they kind of have gather information, right? They must have gathered information like what is this, who will be our target audience, where we are going to start it, how we are going to run it, whether we are going to purchase server, are we going to run in cloud, all those, like in which language we are going to code it, all those is known as business idea, gathering business idea, right? And after that, what they may have done is like they started coding that particular thought process in an application, right? This coding is basically could be like they have coded in C, Java, Python, we don't know, but this is something known as code, right? When the code is ready and when they are done with all these things, what they might have done is basically they have tested their application, right? They may have released for a small set of people, or internally they have tested it, and when the testing and everything is done, the last thing that we do is basically packaging the application. Okay, when the package is available, what happens, basically they kind of upload this package in some server, like over their server, like say for example this is a Zomato server and they have uploaded this. And what happens after that, people like you and me will start downloading that exe file or the mobile app and will start using it, right? We will connect with this server, we'll download this it and we'll start using it, right? This is basically the process started from here, right? I mean, the process started from here, and they kind of have a thought process to start this business, convert this thought process into a business, right? This is how maybe Zomato, Swiggy, Ola, Uber, any application you may think of, this is something more or less how they started, right? Maybe some may more stages in between, but then overall this is what looks to be. This is basically, I mean, this code, who has written this code, we call this guy as a developer, right? And this guy is basically written a code, and maybe one person or a group of person, that is perfectly fine. Maybe he is a kind of a developer, maybe one person or group of person, that is perfectly fine, but he has written the code, right? Now the question here is, okay, fine, all these things are done, how it is related to DevOps, because we just want to understand the methodology, the workflow. This particular thing, I mean, that's developing a software, testing it, packaging it, and releasing it, there's a name for that, and we call this as a SDLC. Okay, SDLC is what is SDLC stand for? SDLC stand for Software Development Life Cycle. What is the meaning of it? Software Development Life Cycle. Okay, this is known as software development life cycle, where software is being developed. This is the life cycle of what? Development of software. Software is what? Does any software that we are using, like we are using right now, we are connected over WebEx. It's a software, right? We have software like Zomato, Swiggy, and all, right? All those things are software. Microsoft Office is a software, right? Even operating system is a software at the end of the day, right? So this is what we call development of software. What for life cycle of that. Okay, ये software development का life cycle है. That's it, right? So what happens, like, you may have heard this word earlier also. I mean, this is what the software development life cycle, maybe in your college days or maybe anywhere else, maybe in your graduation, whatever. I mean, even if you have not heard, that is perfectly fine, but this is what we call software development life cycle. And there is a very famous diagram for that, and this is what the diagram says. Let me just paste it here. This we call the software development lifecycle diagram. Here you can see we have multiple things, right? And we have multiple phases. We have something known as planning. We have something known as analysis. We have design. Then we have implementation. Then we have testing. Then we have maintenance. But this arrow has, this is something like an arrow, right? I mean, this is maintaining as an arrow. This is also an arrow. Like, it's moving in this direction only. It's moving in this direction, right? This is what this diagram says. This circle is basically like keep rolling, right? Keep moving. This is moving inward. So after, what is the point I'm trying to make? Even after you have tested and implemented it, you have to maintain it. Okay. Now, what is this maintenance and what is the meaning of all these planning, analysis, design, and implementation phase? Let's try to understand this with an example, practical example, so that it will be much more clear to you. Say, let's take an example. Let's take a company here. Okay. Say, for example, these are the people from a bank known as Citibank. Okay. And these are the set of people that are from the other organization that is known as Infosys or Infi. Infosys, which company? Infosys is a software development company. Citibank is a company like, banking. They are good in banking. They do have IT team and all, but they are not core IT people. They are more of a banker, right? Now they want to say, for example, Citibank has of work. They want to develop a car loan app. What is this? Car loan app. Okay. Citibank, what they will do? They will hire these guys. I mean, they will hire Infosys guys and say, we want to develop a car loan app. Okay. They will connect to Infosys guy. Now, how these things are going to start? First of all, Infosys team will meet the Citibank team, maybe over Zoom, or they will visit their office, whatever it is. Okay, they will meet these people over a call or a video conference or whatever it is, but there will be a meeting. Okay, and during their meeting, Citibank will propose their plan, like, this is what we want. First, Infosys team will listen, will try to understand what is the customer requirement. Okay, they will listen, and and maybe they will suggest something here only, small suggestion, like, this is okay, this we have built this kind of application for State Bank, we have built this kind of application for ICICI Bank, we are expert into that. Okay, this is what suggestion and all those things. There will be a lot of communication between these two teams. Okay, this phase is basically known as planning phase and analysis phase, where Citibank team and the Infosys team will meet with each other and have a lot of exchange of thoughts. Okay, this is known as, it may take 1 week of time, it may take 2 week of time, it may take 3 week of time. It all depends upon the complexity of the project, until unless they both are not going to settle down on a common thought, like, a common understanding. And say, for example, what will happen after 1 or 2, 3, 4, 5 meetings? They will agree upon, yes, this is what we want to build, this is what is going to be the feature of this everything. I mean, they will put a lot of documentation, and both will say, yes, this is, we will build something like this for you. They will say, yes, this is what we are looking for it. Okay, this discussion and the planning phase is done when both will agree, yes, this is what we want. After that, what Infosys will do, Infosys will come back and do a lot of design, will start designing this phase. I mean, designing is just on paper. I mean, they will say, this is the size of the server, This is the operating system. This is the language. We are either going to use Java, C, or whatever it is. They will start planning it. We are going to deploy in cloud or whatever it is. Just forget about cloud right now. Okay. But we are going to discuss, we are going to create all those things. They come up with a architecture diagram and a design document. Design document will have all the information about the project. Okay. This is what we are going to do. This is what we are going to in these phases, and they will come up with some high level of architecture diagram. This is something it's going to look like. This is going to be a server. This is going to be a storage, something like, no, I'll show you some of the architecture diagram. So they will come up with some kind of a, but right now till here, nothing is running. Everything is on paper. Okay. The designing phase is on paper. When the design is ready, the Infosys team will show this design to Citibank and say, hey, we want to meet you. Let's connect over Zoom or let's connect over Teams and let's discuss about it. Then what will happen? The Citibank team will go through this plan, whatever they have done. They might suggest some kind of a suggestion like, no, this is what we want. Change this into this server, something like that. Infosys team may take those changes or come up with again a new design document. But in this phase, this particular designing phase, there will be one more document. Okay, this is known as design document. Design document, and Infosys team and Citibank team will agree on this. Yes, this is what we want to build, and this is how we want to build. What we want to build is already discussed in planning and analysis phase. How we want to do is in designing phase. The fourth and the very important step is the implementation step. Here, the real work is going to start by the Infosys team. They will start building it. They will start running it. They will start implementing it, testing it, everything. This implementation and testing integration phase is like real work. Okay, and they will keep a kind of creating all those things, and really they are going to implement it, run the whatever they are building. They will start deploying it, running it, and testing it. When everything looks good, okay, this is what we have done, and in this phase, I mean, this phase will be something like this. Okay, so this is somewhere something is running, implementation phase. Okay, in this implementation phase, something is running somewhere. Okay, in the implementation phase. All right. Then what will happen? There is come maintenance. Maintenance is something like how many of you are getting this message that your Truecaller is new version of Truecaller is available, new version of Zomato is available on your phone, or new version of Android is available, right? Are you going for an upgrade or not? Yes. So these things are available. Okay. This is known as maintenance of your software. Whatever the operating system you are running it now, maybe some patches, some you may get this kind of message, some new update of Windows is available, right? So this is basically known as maintenance. I mean, what is this new version? Maybe fixing of some bug, maybe new feature, anything. Say for example, you have seen this. If you are using, this is Zomato, okay, application, and this is Swiggy application. You may have seen some extra feature on Zomato for some days, right? Maybe they have some extra feature they have implemented. You will see that same feature is available in Swiggy within few days. Have you observed this kind of changes? Swiggy, Zomato, or Ola, Uber, they are competitor of each other, right? So, I mean, this is known as feature enhancement. This feature was not available. Now this feature is available. This is one kind of maintenance. Other maintenance is like there is some kind of bug and we want to fix this bug. So what we do, we fix those bug and release a new version of application. All these things comes under the maintenance. Okay, how my application is performing over the runtime, and is there any bug? If we are fixing those bug, releasing those bug, any kind of feature enhancement, that is also comes under the maintenance. All right, so this phase is known, and maintenance is an ongoing process. Okay, maintenance will never stop till the time your application is not shut down. Your maintenance will keep on. Maintenance will keep going on. Okay. Okay, so this is what we call software development life cycle, SDLC. So what I have done is basically I've written a roadmap for this. Okay, what is actually required and what is how anyone can become a DevOps champion in some, like, I've written a 6-month plan, because this is technology and you have to learn it. At least 6 months is required. So I have written this. Okay, I mean, if you are daily spending 2 to 3, I will go through it maybe when we move ahead, little bit ahead in our course. But because you asked, so that is why I'm telling you, you can just go through it. If you're daily spending 2 to 3 hours in your busy schedule, within how in a 6 month you can go through all these DevOps concept. Okay, whatever we are going to cover. Though the course is not for the 6 month, but you need some more time, right? I mean, you need to do some practice, some labs and all those things. So for that, I mentioned like in 3-6 months how you can do this. So start from like Linux. Okay, bit of Linux is required, like Linux basics commands of Linux. It's like strong system administrator of a Linux, but basics understanding of Linux is required. Okay, basic understanding of programming concept is required. Okay, what is variable, what is data type, how if and else work, what is modules, and all those things. This is what is required. Then DevOps concept, SDLC, this is what we are going to discuss right now. Okay, then we are going to discuss about Git and GitHub and Docker. If somebody is looking for, if your new year resolution is to become a DevOps consultant, DevOps architecture and all, you can follow this as a action plan. Okay, as a reference. This is what, okay, week by week plan I have mentioned here. Week 1, week 2, week 3, week 4, like that I have mentioned here. And don't worry about these tools and all. This is just a plan. Just don't read it one by one, like word by word, but that you will understand after finishing this course. Once you finish this course, this document will start making much more sense to you. Okay, because from your side, lot of hard work is required. Okay, it's not that much easy. So, but is it impossible? No, it's not at all. Okay, but what is required? It's required only discipline. It's require planning and discipline. If you are okay to spend 2 to 3 hours daily, okay, you can very easily achieve all those things. Whether you are from non-IT background or IT background, it doesn't matter. And this question, most of the time people ask from non-IT background also. Okay, so this is what for them I have written. Okay, so just go through it. And even if you are from non-IT background, Ram, if an IT guy is putting 2 to 3 hours daily, for a non-IT guy has to put 4 to 5 hours daily. You have to work little bit hard initially. And you are not the first guy who is coming from non-IT background into an IT. Okay, people has already done this, and those people are some of them are really very successful. Okay, so first of all, don't come with that mindset that I am from non-IT background, how can I learn these things? So always be in a learning mode instead of complaining mode. If you are in learning mode, you will learn all those things. But if you start finding excuse, how can I not learn this thing, you'll always get 100 of excuse. But if you are really want to learn those things, there will be no excuse. Okay. Okay, so yeah, we were discussing about this software development life cycle. Okay, now this software development life cycle has couple of, we understood what is software development life cycle. This software development life cycle has couple of model. Okay, SDLC has couple of models. Okay, one of the model is known as waterfall model. Okay, this is known as waterfall model. Why the name is waterfall model? Waterfall model, the name is very simple because water flows in one direction, right? Water flows in one direction. Wherever the slope is, water follow the slope, right? In waterfall model is basically, you can see we have requirement, we have system design, we have implementation, we have testing, we have development, we have maintenance, right? And it goes like this direction. So what is the meaning of this? I mean, it doesn't go in the backward direction at any point of time. What is the backward direction means? Feedback. There is no feedback mechanism in the waterfall model, right? Say for example, in this case, in our case, when we were discussing about this SDLC model, in this particular case, if Infosys team and the Citibank team, okay, they started working. Infosys team coming with first meeting, they done with they are done with their meeting. They understand the requirement. Infosys team has designed something. During this design, Infosys team is not taking the feedback from the Citibank team. They are not taking the feedback. Okay, after the designing, they will go to the implementation phase and they will start running something. Okay, still they are not taking any feedback from the Citibank team. Then what they have done, they have kind of ready to release this thing. At this point of time, if they go back and ask the Citibank team, this is what it is running. Now let's go and release this product. What do you think Citibank team will do? Because here you have not shown what you have done. Here you have not shown what you have done. You are at the final release of the product. You are coming back to us and telling us, and these guys are the real customer. They want to release the car. People will come to the Citibank app and take a car loan, right? This is something not good. If you are going at very end for releasing at the time of release, or you're not taking a regular feedback from the team, that is something not good in today's scenario. Okay, this is what waterfall model. I mean, you can see it works only in one direction: requirements, system analysis, designing, implementation, testing. But there is no backward mechanism to go and take the feedback. This was working good 15 years, 20 years back. Okay, but in today's scenario, this is not at all going to work, because people will like to see the feedback. I mean, you just try to understand, when you go and purchase anything on Amazon or Flipkart, you go and read the feedback, right? How this phone is performing. Even you buy a pen nowadays, people will read a feedback. Okay, how these things. So this is something, it's not suited for today's scenario. This is where this model actually fails. Okay, this is not suited for today's scenario. This was good for 15 years, 20 years back when we were working like this, but in today's scenario, this is not going to work. Okay, now once this is done, right now, once this is done, now people start realizing, okay, this waterfall model has this much. These are the issues of the waterfall model. Now how can we fix this? Then they come up with something known as Agile methodology. What is this Agile methodology? In Agile, what we do basically, in Agile, just in order to explain you this concept, okay, I'll take some hypothetical assumptions so that you can understand the concept first. Say the same thing, I mean, the Infosys and the Citibank, and we want to build a car loan app. So what Infosys will do, I mean, they will say, okay, say for example, this project, Infosys has realized that this project is going to take 4 weeks. Okay, total it will require 4 weeks to build this project. So you know what they will do? They will break down this project into multiple modules. Okay, they will break down this project into multiple modules. Say for example, they will say this is going to be module number 1. Similarly, this is going to be module number 2, module number 3, and module number 4. Okay, module number 2, module number 3, and module number 4. I'm just going to explain you the concept, how it works. So please pay some attention. In real world things, maybe you may say like how it is possible to take each module as a 1 week. This is what the assumption is. Okay, just to explain the concept. So what will happen? I mean, they will start with module number 1. Okay, in 1 week they will finish the module number 1, and they will start on the very next week. I mean, they will start on the module number 2, but at the end of the 1 week, they will take the feedback of the module number 1. They will check with the Citibank, is this whatever we have developed so far, is this okay? They are taking the feedback here. Citibank may provide some inputs from their side, or they may not provide some input from their side, or whatever it is. Maybe there is a small modification in M1. So the next week, I mean, second week, they will come up with the modified version of module number 1. Okay, this will become M1, I will say dash, something like this. Okay, this is little bit modified version. And during the same time, they will finish the module number 2 and they will take the feedback from the module over the module number 2. Next week, what will happen? They will come with the modified version of M2. Okay, and similarly over this week, they will start parallelly working on module number 3 and they will finish the module number 3 here. Very next week, what will happen? They come with a change version of module number 3. Okay, and they will also start working parallelly on over the module number 4. So, and very next week, module number 4 will get modified with the whatever the suggestion given by the customer. What will happen here at the end of this week? Everything is getting modified as per the customer requirement and everything is ready. Do they have taken the regular feedback from the customer? Yes, they do have taken the regular feedback from the customer and the product is ready. At this point, both Infosys team plus Citibank team, they both are in sync and they both agree this is what we want to develop. Okay, there's no complaint from anybody because we have taken, I mean, we as a Infosys team has taken a regular feedback from the Citibank team and they are now in mutual agreement. This is what we want and this is what the final product. But it doesn't mean that nothing is going to change from now. Anything can change at any point of time. But the point here is this is how Agile works. Agile, the literal meaning of Agile is what? You are ready to change. You are ready for acceptance of changes, right? So this is what the meaning of this Agile methodology. Okay, there is a regular feedback that people will take. Okay, and the regular feedback is taken whenever you made a significant development, you can take a feedback from your customer. Okay, this is how Agile model works. In Waterfall model, what is happening? We were developing the product here and at the end we are going back to the customer. This is what we have developed. Can you go and check it? But in Agile model, we are taking feedback here. At every model, at every stage, we are taking a regular feedback from the customer. Okay, this is the main difference. All right. This is what the Agile methodology is. Okay, but this Agile methodology is basically looks very good on paper. Okay, what I'm trying to say, this Agile methodology why I'm trying to what is the meaning of this? It's work only on paper. I mean, the concept wise it works very good, but practically it has a lot of challenge. What do you mean by practically it has a lot of challenge? Say for example, okay, let's consider a company Airtel. Okay, Airtel has a lot of servers and all, right? I mean, they have say for example, this is their prepaid billing server. Okay, what is the server? Prepaid billing server. Prepaid billing server, when you recharge your AWS account, your recharge is going to happen from over from this server. Okay, if this server, suppose if this server goes down, okay, what will happen? It's a high impact for them. It's a or it's a normal thing for AWS. I mean, what do you think? If the server goes down, it's a big thing for them or high? Big, right? Why? Because their revenue will stop, right? Nobody is able to recharge their prepaid mobile on Airtel. They will lose business, they will lose money, they will, right? It's a big thing for them. If this is a big thing, what generally happen in the big thing? There will be a bridge will get open, and people from different teams will start joining it. Here, for example, people from team like will join somebody from database team, somebody from the application team. Everyone will start joining this team. Okay, somebody from the application team, everyone will start joining this team, this particular bridge. Somebody from the system admin team, they will start joining the team. Say for example, this is the apps team, the application team. Okay, and they also join. They are from the apps team. Okay, they are from the DBAs, they are DBA. Okay, they are system admin. All right, and say for example, these guys are from the networking team. Okay, now the bridge is open and everybody is like, and when the bridge will open, like, everybody will be so attentive, so responsive over the call, because it's a SEV1, it's a severity 1. It's a very high severity for them if the server is down. I will tell you the actual severity, because at some point of time I was closely associated with Airtel in their Noida office. Earlier they were office in Okhla. I mean, they moved to Noida. If somebody from North Delhi might be knowing it, what I'm trying to say, it's a two different location in Delhi, and Noida, they migrated everything in Noida and they created a data center there. So I was part of that migration, like server migration and all. So I'm talking about somewhere in 2006, 7, I think. At that time there was no cloud. Okay, everything is in-house data center. Every organization has its own data center. There was no concept of cloud. Okay, so yeah, man, this is as critical. If this server is down for half an hour, Bharti Mittal will join the call. You know who is Bharti Mittal? Bharti Mittal is owner of Airtel. Okay, he will join the call. This is as much as critical. So when this bridge will open, these people will be super attentive, because they know the criticality. In half an hour, if something is not done, at least we have not identified the problem, why the server goes down, what was the issue, and how it will come up. If they have not identified the problem in next 15-20 minutes, the big boss will join, right? So that's a very, very big thing. Again, it's very difficult to answer over the call, like what is gone and what happened, why it went gone down and all those things. So say for example, so they will be like super critical for them. Now after, say for example, after 10 minutes, everyone agrees that the issue with the application team, I mean, they have recently made some changes and issue is with the application team. The application team is responsible for this, and even application team agrees that yes, this is because of us, because we made some changes and because of something happened and the server application is down. You know what will happen after 10 minutes with these guys? The system admin, the DBAs and the network team, they will sit relax. They will put their phone over speaker and they will just relax. Apna kya jata hai? I mean, this is not our fault. I mean, I'm not saying that they will leave the call or something like that, but they will they have very relaxed mood now, because this is not their issue. And these guys sitting over the time bomb. I mean, they need to fix this particular thing ASAP. They need to fix it. They need to come up with an RCA and they need to write so many documents. What happened? Why happened? How in future we can protect all those things. A lot of things they have to do. So what I'm trying to mention here is this is how we work. We are human and we work like this only. Until unless something is not critical on my part, I am okay. It's nothing to worry. But if something is critical on my part, I'll be very productive, I'll be like super responsible, and I'll start working and I'll fix it and all those things, right? This is how we work. So this is what it's human nature. Now let's come back to our agile methodology. So in agile methodology, there are two teams. Okay. First team is a team of developer. These guys are developer. These developers will write the module. Okay. They will say, I am going to write this module number 1. And I have to release this module in the next week because I have these are the developer from which company? These are the developer also from Infosys. Okay, and they will write this module, they will codify this module, and they want to run this module over a server. I mean, whatever the program they have written, they want to test it over a server. But this server is not maintained by this developer. The server is maintained by something known as operation team. Operation team means what? Operation team means system admin, storage admin, network admin, database admin. I mean, this is the operation, and they are also from the Infosys. Okay. So these are the developers who are from Infosys. They will write this model. Remember this model number 1, when we have to finish it in the time frame of 1 week. Module number 1, we have to finish it in the 1 week. Okay, who will write this module? Apna developer, right? Developer will write this module and say, I want to test this module over this server. But who maintains this server? This system admin, the operation team. I mean, are they operation team from the different company? No, they are from the same company, Infosys. Developer will have a different manager, right? Developer will have a different manager, and they are reporting to this guy. These people are reporting to this guy, right? And similarly, system admin or the operation team will have a different manager. They are reporting to different manager. Now, what will happen when the moment this guy will say, I want to run this model because I'm so much hurry, I need to release this in next week. I have a customer meeting, Citibank meeting with Citibank. They will say, wait. Why you are running all these model on my server? Have you raised the change request? Have you taken the approval? Blah, blah, blah. They will ask. What will happen? The model is not going to release in the next week. If they go and raise a change request and all those things, follow the process and everything, it's very difficult because this is something they won't able to run it. They won't able to allow to install this thing on their server. So what will happen here? There will be a delay. Instead of 1 week, you are going to come back with the model number 2 on the second week, end of the second week here. Citibank will say, hey, you guys told me that at the end of the module week 1, you are going to show me module number 1. Where is this? So there is what is happening here? There are these two teams are same company, same everything, but they are working in different team and different org structure maybe. So what is happening here? There is a lot of miscommunication. Okay, there is a lot of miscommunication happening here. Okay, what are those issues? First is miscommunication. What is miscommunication? The developer, the operation team is not aware of all these, like there is a meeting going on and all those things. They don't know because they're part of different team. Okay, they work different, they report different manager, these guys report to different manager and so on and so forth. So what is the next issue? Conflict of interest. Developer want to deploy everything as soon as possible, test everything as soon as possible. On the other hand, the operation team is responsible for the stability of the project. Are they doing anything wrong? No, they are not doing anything wrong. They are a process. I mean, if say for example, if this module get deployed here and something goes wrong with this server, then this guy will under the observation, like a manager will ask 100 questions. Why are you folks allowed to deploy this module and all those things? So conflict of interest. This guy wants quick deployment, this guy wants stability. Okay, and another thing that you have observed here, like a lot of things we are doing it manually. If you perform anything manually, first of all, it will be time consuming and there are chances of human error. Okay. So apart from that, there are so many other factors, but what happened to this agile methodology? Agile methodology is like, on paper it looks very good, right? After 1 week we will release this model. Next week we'll come with the changes and parallelly start working on the model number 2. On paper it looks awesome, good, very good. But practically when we are going to implement it, we have a lot of repercussions, right? I mean, we have a lot of other challenges that we have not seen, that we have not think of, right? So this whole thing is gone for a toss, right? I mean, this is not possible. If this is the case, I'm not able to, Infosys is not going to release this project at the end of 4 week or 5 week. Then what Citibank will say, it's better to hire TCS rather than Infosys. Let's check with TCS, let's check with HCL, let's check with Cognizant. Are they going to build this project or not? So Infosys is losing the business, right? So this is how the things work and the challenges are there. And what is the for that? How can we solve this problem? We can definitely, people start thinking in this direction and they say, okay, fine, let's solve this problem. Let's do one thing. Let's take somebody from the developer team, okay, take somebody from the operation team, okay, and build a new team that is from developer plus operation, okay, and we call this team as a DevOps team, okay. Instead of these two people reporting to different manager, let's hire a guy who will be DevOps manager. Now there is no chances of miscommunication. What is happening inside the team, everybody is aware. The beauty of this team is like people from the developer background, right? They are having developer background. Somebody can code, somebody can write a code and write an application, and somebody from managing the operation, like somebody who can install server, so somebody who can install application, somebody good in operating system and operation part, networking and storage part, somebody good in coding part. Let's marry these two people and create a new team. That team is to be called as a DevOps. Okay, so DevOps is basically is the team who is basically found off from the operation as well as from the developer team. Okay, now the question here is, so this is about a DevOps, but what actually is DevOps? If you have to define like what actually is DevOps, I mean, I will say DevOps is basically delivery of high quality product quickly. This is what DevOps is. You have to deliver the product, high quality product. High quality means there is no compromise with the quality of there is no compromise in the modules delivery. Okay, all are like everything, whatever the feature and everything will be there. But apart from that, we will also deliver the things quickly. Whenever the things comes like quickly, if you want to do anything fast, what is the best way of doing? You have to use some tool, right? You have to use some in our day-to-day activity. If we want to do something fast, we put like, let's create some machine or maybe something like that. Instead of manual, we start with the help of tools. Okay, good. So this is about like, DevOps thing. So first of all, DevOps is a culture. Okay, culture means it is not a technology. I mean, DevOps is something like Java is a technology, right? C, Python, all these are a kind of a technology. You can say it's a kind of technology. But DevOps is not a technology. DevOps is a culture. DevOps is a method. Okay, method of delivering high quality product quickly. Now the question comes like, if you want to deliver anything quickly, means if you want to deliver anything quickly, how can you deliver it? You can automate automation. And for automation, we are going to study number of tools. we require tools. All right, so this is more. This is what this is what we do in DevOps. And if you have seen this, like the logo of DevOps, I mean, whenever you have seen this is the picture of. Have you seen this logo of DevOps? This is this is sign of. This is sign of. This sign it. This, right. This is a sign of infinity basically. And this is the logo of DevOps. I mean, DevOps we represent with this. Why? Because in DevOps is a continuous process. I mean, infinity means what? It will never die. It's infinite. It's continuous. Okay, it's quite. So that is what the logical meaning of this diagram. If you see here, there is something planning, coding, building, testing, release, deploy, operations, monitor, again plan, again code, build, test, release, deploy. All these things, it's a continuous process. Okay. For every of these stages, we are going to till my project is alive. Okay. Say for example, the Zomato application that we started. Till the application is going up and running, we will follow this process. Okay, we will follow this process of planning, coding, building, release, blah blah blah. Everything will keep going on till this application is up and running. It's people are using it. Okay, so this is what we say, like this is what the DevOps is. So in DevOps, basically we are going to study number of tools here. Okay, we are going to study number of tools here. Why we are going to study number of tools? Because we are going to study these tools for automation. Automation of what? Automation of planning, automation of coding, automation of build, automation of test, automation of release, deploy, operation, monitor, everything we are going to automate. Okay, so this is what we are going to study in the terms of tools to automate all these stages of DevOps. All right, so this is now what are the tools that we are going to study in this particular course. Okay, in this particular course we are going to study number of tools. Okay, first tool that we are going to study is known as VCS or version control system. Version control system. In this we are going to study two tools. First one is Git, that is a local version control system. Okay, and the second tool that we are going to study is account. So that is also we are going to study known as GitHub central version control system. Okay, so Git and GitHub as a version control system. This is the first tool that we are going to study. We are also going to CI/CD pipeline. Continuous. What is CI? What is CD? Don't worry about it because this is what we are going to study. Okay, in CI/CD pipeline or tool, we are going to study Jenkins. Okay, we will discuss about Jenkins. Then we are going to discuss something known as container. Okay, container where we'll discuss about Docker and a container orchestration tool, that is Kubernetes. All right. Then we are going to study about Terraform, that is for the deployment of infrastructure as a code, that we are going to discuss in detail about Terraform. Okay. After that, we will study config management tool, and under this tool we are going to discuss Ansible. Okay, this is in, and at the end we are going to discuss about monitoring, and the monitoring part we are going to discuss about EFK stack. All right, so these are the tools that we are going to study here. Okay, So these many tools that we are going to cover in this particular course curriculum. But till here, summarize it so that you can understand the whole context, because we need to understand first of all what is DevOps, why DevOps, and what we are going to study in DevOps. For that, I just connected everything from scratch. Like, we started something like what is the software development life cycle. Okay, what happens in software development life cycle? We are running analysis, planning, designing, implementing, testing, and maintenance. We took an example of Citibank Infosys to explain this particular diagram. What is waterfall model? What is the challenges of waterfall model we discuss? In order to solve this, there is something known as agile methodology. Agile, basically we break down the project into small sprints and we work over there. At the end we combine everything to deliver the final product. What could be the challenges with agile methodology in a real world? That we discuss. Then we discuss what could be the solution for that. The solution is what is known as DevOps. I mean, is agile and DevOps are different? No, I mean, they are not actually different. In order to implement agile perfectly, DevOps is one of the methodology. Okay, in order to handle the challenges of the agile method in a real world, DevOps is one of the things that we use to solve it. All right, so this is what the agile and and what we can say the DevOps, how they are related, because people will get confused. Okay, we know we are not going to follow agile, we are following DevOps. No, DevOps is one methodology to implement everything smoothly following agile method. Okay, this is what we can say. So DevOps itself is not any technology. DevOps itself is a culture. Culture of what? Culture of following, delivering a high quality product quickly. If you want to deliver anything with a high, there's no quickly, you may think like there may be some compromise with the quality. If you want to do it fast, then definitely there must be some compromise with the quality. So it's not like it's not with DevOps, because when we are doing anything quickly, we are going to build automation for that. We are going to use some tools for that. We are not going to do most of the things. We are not going to do manually. Manually means we are not going to deploy or everything. We will create an automation. What kind of automation? We will learn all those things, and in order to deliver all those things, we have to implement so many tools in DevOps. So Git, GitHub, Jenkins, Docker, Kubernetes, Terraform, Ansible, and EFK stack. These are the only tools available in DevOps? No, there are so many other tools available in DevOps, and there are many tools available in one. Say for example, if I talk about Docker and maintaining container, there are so many container types are available. We are going to study about Docker. Why we are studying about Docker? Why we are studying about Jenkins, not any other tools? Because these tools are very quite very famous, and they capture the market in a very large extent. So, and what is the advantage? I mean, if you learn these tools, other tools you can easily learn pretty easily. Okay, but this is what we are going to discuss in this particular course. Okay, so let's start with version control system. But before moving ahead with the version control system, let's try to understand what is version control system. Okay, and then we'll discuss about types of version control system, then architecture of version control system, and then we'll start going deep in one of the version control system, that is Git. Okay, so say for example, this is a developer. Okay, and he is writing the code. All right, he is writing the code in his machine. Say he started writing the code. He came to office at 9:30 and 9 a.m. and he started writing the code. All right, till say for example, this is the code at 9 a.m. and when he is writing the code, basically after some time, till 1 p.m. he has written a lot of lines, like a lot of code, and till at 1 p.m. he was able to complete almost say 70% of the work. Okay, and he is like very happy, like today He has done a lot of hard work. Now at 1 p.m. he took a break and he again started working at 2 p.m. and at 4 p.m. When he was working, and he made a lot of other changes for 4 p.m. But at this particular point at that 4 p.m. okay, till here 70% of the code is working, but at this particular point he from here to here he made a lot of changes and he goofed up. I mean, he made some mistakes or something, and here nothing is working. Okay, at this point of the time, nothing is working. Even he was not able to revert back here. Okay, because he makes a lot of changes and he is very frustrated now because the code was working like 70% of thing was done, but now nothing is working. And he was not able to troubleshoot. So this is very, and this happens. Okay, I mean, when you're writing any code and you're making some changes, this happens most of the, I won't say most of the time, but often it happens. Like whenever you make changes and something will again stop working, and it's very difficult to troubleshoot and revert back. So this is where the scenario that developer face this kind of issue. What is another challenge here? Could be another challenge. Whatever the code he is writing, okay, whatever the code he is writing on his desktop, on this laptop, right? Everything is all the files and everything is getting stored here, right? This is getting stored here. What happens if this, say for example, everything is working, but this machine crashed next morning, this machine crashed, then what will happen? If this machine crashed, then all the things that are stored here, there are high probability that we may lose all the code, right? So that is another problem. What could be the third challenge? In general, when we work over any project or something, we are not the only person who work here. There will be some other developer in my team who is also working on the same project, right? Say for example, here in the first example of Zomato, okay, this particular code is not only contributed or written by one developer. There may be a team of developer, 4 developer, 5 developer, or like that. So if everything is getting stored here, how the other developer, let's say for example, this is developer 1 and this is developer 2, how developer 2 will get an access? And what this guy can do then? This guy can say, okay, let me share my password with you and you can access this machine. Is this a good option, sharing your password? Not at all, right? We don't share the password of our machine to give access to somebody else, right? So there are a couple of challenges here, right? First of all, when anything goes wrong in the code and we made a substantial progress and after that something goes wrong, how to revert back? Okay, if that machine itself got crashed, then what will happen with the code? Okay, third thing is, now if I'm storing this file here and I want to give access to other developer, how can I give access, right? So that this is where the problem gets started. Now let me ask you one question. Okay, say for example, this is very important file for you. Okay, this is very important file. Now, would you like to store this file on your laptop or would you like to store this file on Google Drive? Which one is a better option? Forget about database right now. Database is a different altogether. Google Drive. Why Google Drive? There are a couple of advantages with Google Drive, right? First of all, you have never seen anything like, you upload any file in Google Drive and you lost that file, right? That maintains the very high availability because this is a kind of an object storage. Okay. So if you have seen ever, like, let me see if I have a login here. I just want to give you one. I just want to share with you one thing that what is, I mean, have you folks already heard about AWS S3, right? What is the durability of AWS S3? I have written here something for storage. So the durability of S3 is, they say 11 nines of durability, 99.99999, like 11 nines of durability. If you do this math, okay, I have done this math, okay, and what is the summary here? With 11 nines of durability, the chances of data loss in Amazon S3 is extremely low. Okay, the math shows that if you store a billion object, 1 billion object, the likelihood of losing a single object over 1 year is one object in every 100 years. Okay, so that is the level of durability. Okay, similar, I mean, Google Drive is similar kind of storage like Amazon S3. Okay, so that these are very highly durable. The point I'm trying to make, they are very highly durable. That is why you all says I will store the file in Google Drive rather than my local desktop. Right? Second thing is, can I share this file with some of you if I want without sharing my password? Can I give access to this file? Say for example, I want to give access one of my file to Sankar. Is it possible? Yes, it is possible. I can ask Sankar what is your Gmail ID, and I can give either contributor or reader permission to this file, right? Similarly, if I want to share this file, with Pushkar or Srividya, anyone, I mean, I can share this file. So these two problems we have solved. Like what? First, let's list down the problem. The first problem was like reverting back to working file, right? Working solution. That is, that is a problem number one. Second problem was data loss when system crash, right? What was the third problem? Giving access to my colleagues, right? Sharing access to the file. That was the third problem. Second and third problem is solved if we have something like Google Drive kind of stuff. Yes or no? I mean, there is chances of losing data is very, very less. I just showed you how much durable these storages are. Second thing is, I can share the file? Yes, you can share the file without sharing your password. You can give access. You can directly give access to the file without sharing the password. That is possible. What about reverting back? Let's take this example again. Okay, let's take this example again. If I have some mechanism, whenever I'm making some changes in a file, what it should do, say for example at 9 a.m., 1 p.m. or 4 p.m. If I'm making some changes, first it will make a backup copy of it, okay, and then it will make the changes. Here I'm making some changes, what will happen? It will make a backup copy of it, okay, and then it will make, then it will allow to make some changes. So at if I'm making any substantial progress, it should make a backup copy of it. Okay. In this scenario, at any point of time, if something goes wrong with my code, is it possible for me to revert back at this backup or this backup? Is it possible for me if some this kind of mechanism is like, if I have something that will help me to take regular backup, whenever I make some progress, it will take a backup. Is it possible for me to revert back? It's very simple, right? I mean, if I'm making, say for example, I'm making some changes, it will take a backup, then it will allow me to make changes. Yes, backup will, like, whenever I want to make sure that I want to take a backup, it will it will just take a backup. Whenever I'm making any changes, it will take backup, and then again I'll make some changes, it will take a backup. Again I'll make some changes, it will take a backup. Make changes, backup. Okay. So it is possible for me to revert back to this backup or this backup or this backup or this backup. These are all different file. Okay, independent file, different file. Okay. So this is known as versioning. This concept is known as versioning of a system. Okay. Versioning is basically allow you, whenever you make some changes, whenever, say for example, in your local machine desktop, what we do when we create any file, we give the name of the file new text file, right? New file.txt, right? This is what the name we give, new file.txt. When we make some changes, we say new file 1.txt, right? I mean, this is how we take some back, right? Then we do 1, 2, 3. Then we say, okay, we start putting some dates. So, but what are these? These are some independent files. This is the this is the first version, this is the second version, this is the third version of my file. But content here, it will have latest content, this will have n-1, this is n-2 content, right? Like this. We also take manual backup of our file most of the time while working, right? If anything goes wrong here, what we can do, we can revert back to this file and start working here. So what we are maintaining here? We are maintaining different version of our file. This concept is known as versioning. Okay. And the tool that we are going to learn is version control system that will maintain the different version of our file. But version control system doesn't only offer the versioning of your files. It also prevents you from data loss. It also helps you to share the file, among different colleague or team. Like this is also possible. So version control system, this is what the version control system. Okay, just give me a second. Let me open your notepad. All right, so let me also define, we are discussing about, let's say, what is version control system. If you define the version control system, it says the version control system is a tool that helps you track and manage the changes to the code, documents, and other collection of information over the time. Okay, that is the first point. Second point, it enables developer to collaborate. That is like share the information, collaborate on projects, maintain a history of changes, and revert to the previous version as and when necessary. Okay, VCS plays an important role in software development, ensuring that teams can work together without overwriting each other work. That is also very, very important. Okay, and we will see how these things work and what are the importance of all those things. We'll see. So what are the feature of version control system? The version control system basically helps to tracking the changes. Okay, collaboration, that is another feature of version control system. All right, and something known as backup and recovery, that is also we will see. And we will see, like, branching and merging. What is branching, what is merging, don't worry about it, we will cover in detail. I'm just mentioning here some feature. And it also maintains audit and history. Okay, so this is, even if you understand 40% of it, I'm okay with this, because when we will do lab, all these things will become crystal clear. Okay, so don't worry about it. Even if you are getting half of it, some portion of it, that is perfectly fine. Okay, so this is something you should understand. Now we understood about, say for example, we'll discuss about the types of version control system, okay, or the architecture of the version control system. Okay, so first let's discuss about this we understood about what is version control system. Here so far we have explored like what is VCS, right? Now we'll discuss about the types of VCS. Types of VCS, like what are the tools that are available. There are different types of version control systems available. First one is, that is very famous, is known as Git. Okay, Git is one of the version control system. The second version control system we call is SVN. Okay, that is from Apache. This is also quite famous. Okay, we have Mercurial. Third one is, okay, we have another lot of other tools as well. We have something like CVS, we have Perforce, we have Bazaar, we have, okay, Bitbucket. Okay, there are so many version control system. Okay, I mean, the examples are so many. You can say Bitbucket. Okay, there are so many version control system. But out of these version control system, we will be focusing on Git. Okay, why Git? Because the reason is, I can say it is kind of a very widely used version control system. It is adopted by most of the project in this world. And the most important reason we will understand when we discuss more about Git while doing lab. And second thing is, it is open source. You don't need to pay anything for Git. Okay. And third thing is, like, community support. I mean, whenever you face any issue in Git, you can just go and ask the question in community, you will definitely get answer. Either the answer is already available or you will definitely get answer very quickly. So these things make Git quite popular. Okay. So we are going to discuss about Git. Now, before I can moving ahead, we'll discuss about the architecture of version control system. Okay, so there are a couple of architecture that we are going to discuss. First, we call as a local version control system. Okay, and the second we call centralized version control system. And third we call distributed version control system. Alright, architecture local, central, distributed. What is the meaning of all these things? Meaning of all these things is basically local version control system is local to you. Like say for example, anything if I'm installing at my computer, okay, this is my computer, and if I'm installing a version control system here on this laptop, okay, if I'm installing Git here, this, okay, then this will become what? Local version control system. It's on my local desktop. Okay, we will first learn locally the Git, how to manage Git locally. Second version control system could be something like GitHub. Okay, like we can install like on some server. Okay, and this is accessible over the network or internet. Like people like you and me, just like just something like your Google Drive. Okay, you can access it centrally. It's available here. Okay, it's available here. Say for example this one, the GitHub. You can access my Git repository, right? I'm creating the repository here, and you can access it. You can come here and you can access all these repositories. So this particular thing, okay, this particular thing is known as central version control system. You can access this repository, you can access this repository, you can access this, you can access this, right? So this is basically available to you. Okay, so this is known as central version control system. Are you folks getting it? Because over the network you can connect to this. So the moment you click on this GitHub link, you will be able to access it, right? So this is what the central version control system, because it's a GitHub is a central version control system. Now the question comes, what is distributed version control system is? Distributed version control system is like when you connect our central, local to central. Say for example, from my desktop, I have installed local version control system here on my desktop, and I have also connected to my GitHub repository from my desktop. Okay, this is my GitHub repository. Okay, here if I've connected these two things, okay, from my laptop, if I'm connecting to this from local version control system to this is known as distributed, because I have local plus central is known as distributed. Okay, this is if I'm connecting this via internet or something like directly to this, okay, without installing anything over the internet. This is known as central version control system. Okay, but if from my local VCS I'm connecting to this, is known as distributed version control system. Don't worry about these architecture. It's very simple. You will able to understand when we'll start doing the lab. All these concepts will become more clear when we'll start doing lab. This is just an explanation, okay, so that whatever we are going to do, it will start making some sense to you. All right, so first of all, we need to understand what is the final takeaway. What is the takeaway from here? I mean, the takeaway is what is version control system. You should understand what is version control system and why we need something like version control system. What is the use? Why we need? Without version control system, can't we survive? No, you can definitely survive, but your life will be very challenging as a developer. Why? Because these things will always become a challenge for you. Okay, if anything goes wrong, just imagine you work for a project from last 6 months and one fine day the system got crashed and you have not taken the backup anywhere else. You have just taken the backup locally. How bad it is, right? So that is where the version control system comes into the picture, where what we do, whatever the changes we make here, we kind of push those changes to this one. Even this guy crashes. Okay, even this guy crashes. Okay, this guy crashes. No problem. My codes are here. It is like, my files are uploaded in Google Drive. If my system crashes, that's not a problem. I can access it. If in this model, this is the model we are going to work. Okay, on this, first we will understand local version control system, then we'll understand central version control system, then we will combine these two things. Okay, we'll create this path also. Okay, this is what we are going to do. But the point I'm trying to make, if this model is ready, even tomorrow, if I want to share my file with the Mera, if I want to share my file with Debodeep, can I share the file? I'm already sharing it, right? I'm already sharing my content to you. So this is what am I giving my GitHub user ID and password to you? No. But are you able to access my files? Yes. Right? So this is the way we start. This is what I'm trying to mention here. The collaboration. We can work also. I can give access to the access, not only read, I can give access to contribute also. So you can also start contributing. Say for example, tomorrow you and me started working on a project. Okay, and I will say, okay, let's this part of the project, let's you finish it, this part of the project I'll finish it, let's start collaborating. So you can also start contributing. I can give you the role of backup and contributor as well. Okay, so what is this branching, merging, backup, recovery? We will see when we'll do the labs. But first, let's understand what is local version control system. So let's move ahead with the first local version control system. Local version control system, we will see first installation of Git. Installation of Git, we can install Git on Windows, on your local machine. We can install Git on Mac. If somebody is using Mac, we can install Git on Linux. That is my favorite. All right. My favorite doesn't mean that it should be your favorite also, but depending upon the use case, you can install Git here. First option is the best, the easiest and the best option is install something known as Git Bash. Okay, even if you're running on Windows, Linux, or whatever it is, install Git Bash. Installation of Git Bash is very simple. You go to Google, type Git Bash installation. You'll get this link. So here you can see I have a couple of options like Windows, Mac, Linux. For Windows, I have already installed it. Okay, so you can see this icon here, right? This icon here. This is Git Bash. Okay, I mean it's very simple. You can just download the exe file and install it. The moment you install it, this kind of a terminal will get open. This is, can you see the name, the terminal here? This is the command prompt you'll get. This is Git Bash. The moment you install it, you will get this terminal. Okay, say for example cd for you can see I'm running command like Linux, right? So it's basically Git Bash will give you a Linux terminal at your Windows machine, Mac machine, or Linux already has a terminal. So that is quite easy to manage. Okay, and how to install it? It's very simple. Go to Windows, select the operating system type. You must have, nowadays everybody must have 64-bit. Okay, just even if you want to use portable version, that is also possible. Otherwise, you can just right click here or you can just click here. It will start downloading. You can see it is downloading for me. The moment it is get downloaded, you can just start running it. Okay, you will get, I think everybody knows how to install a software, right? I mean, this is something you just need to choose, and I'm not going to reinstall it because I've already installed it. Okay, but you need to do next and select all the default option. Are you folks able to see it? I think everybody can, it's not require any guidance, right? I mean, everybody knows how to install an exe file. Right? Just select all the default option. Later you will see that it get installed. When it get installed, you can pin it here at your toolbar, or you can, it's your choice. And then when you open this, you will see something. This will be your username, this will be your machine name, and this will be your directory name. Similarly, you can install over Mac. Okay, so installation, yeah, I know, because the installation, it's not that much difficult. Everybody knows. Now, the second part I'm going to tell you is like, how to install just not Git Bash. How to install Git. Git Bash is one of the form of local. Okay, this is Git Bash is a software. Okay, what is Git Bash? Okay, so Git Bash is a software for Git. Okay, Git Bash is a software for Git. If you want to install Git, you can install Git Bash. It will give you a command. It will basically give you a terminal, okay, where you can run all Git commands. Okay, and another thing, it is a local version control system. All right, so this is important. Okay, now question comes, how to install Git, not Git Bash. Git Bash is a software that contains Git. If you install Git Bash, it means Git is already installed. Okay, Git Bash is a software that contains Git itself. That will give you a Git terminal. Okay, so no need to install Git again when you install Git Bash. Okay, but how to install Git on Linux? Okay, so for that, what I have done, I have like Ubuntu machine. Okay, is running somewhere, maybe on AWS or Azure or Google, it doesn't matter, or even on local machine, that doesn't matter, a Ubuntu machine, where I will show you to install Git. First, what we'll do, we'll install Git. If you have already installed Git Bash, no need to install Git if you have installed Git Bash. Okay, please remember this line. This is a Linux machine that I'm having here. This is my machine is power off. EKS is down. Okay, leave this machine. I think I have another machine running. Yes, this is running. Let me change setting here. Okay, so this is a Ubuntu machine. All right, and I'm going to install Git here. How to install Git on a Ubuntu machine? This is what I'm trying to show you. Okay, can I install Git Bash here? Yes, I can install Git Bash here. Okay, but if I want to install just Git here, how can I install Git here? This is what I'm going to show you. So first of all, what we will do, we will install Git on a Linux machine. In order to install Git, the command is very simple. You need to run these two commands. Install apt-get. What is apt? So apt is a command line, I mean the package manager for Ubuntu. And I have given my GitHub also, right? For Linux, I think I shared this one. You can go here, basic understanding of command and package management. Here I have discussed about Yum is a package manager for Red Hat. Okay. Similarly, I may have discussed about apt here for Ubuntu, how to install any package. apt install package name. Okay, so we are installing Git. First thing what we should generally do, we should update the apt update. That will basically update the machine. If anything required to update, it will update it. It is like something like Windows update. We are just doing the Windows update. So it says done, 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 nothing to be updated here. It's okay. Second thing is we need to install Git. What is the command? So what is the syntax? Syntax says if you want to install anything, you need to do apt update package name. Okay, so this is what. So we'll follow the same thing. The command is here. Apt. You can just mention Git here. No need to mention Git all because Git all will install a lot of other stuff. We'll just install Git. Let's say apt -get install Git. It says Git is already installed here, so nothing to do. I mean, if it is already installed, most of the time nowadays Git is already installed in a lot of Linux version. If it is not installed, it will install it for you. If Git is installed, how to make sure that it got installed? You can just run git-version command. This is the version. This command no need to run on Git Bash. Okay. So we have installed Git here. Okay. Now, second thing is you have to configure Git. Okay. This command you can also run. Configuration of Git is basically configure Git. Basically, you need to run this command. Okay. Git config -- global username. You can mention your name. Say for example, I will run with a name. I'll say, come on. Okay. Config user email ID. You can mention your email ID. I'll say gmail.com. Editor. What editor you are going to use? In Windows, you can mention Notepad. Okay. Notepad is a editor, you can use it. If you want to use any specific editor like Notepad++ or VI, I mean that whatever the editor, if you're not very sure, you can use Notepad. Okay. In Linux, if I have to run this command because it doesn't have Notepad, okay, so I will run in Linux the same command. I will run like this. I'll say I'm going to use a VI editor. VI is the editor in Linux. Okay. So let's configure Git. So I'll say Git. Why we are configuring it? What is the use of this configuration? Don't worry about it. I will explain you this as well. Why we need to do all these things. You will get this. This will become clear after the lab. So this is what it got configured. So that is first thing that we have done here. So far what we did, we understood about Git, version control system, local version control system, and central version control system, distributed version control system, what is version control system, why we need version control system, and the installation part. Okay. We are going to understand about the working of Git, how Git works. So let me start with this thing where we understand how Git works. Okay. So what we have done so far, we have a Linux machine, right? This is our Linux machine. I can say this is my computer. It could be a Linux machine. It could be, you can say, it could be, say, for example, a server or whatever it is. It's a laptop, desktop, whatever it is. This is my machine, right? Over this machine, what we have done, I mean, in this machine, we have installed, over this machine, we have done a couple of things. We have installed Git, right? Okay. Installation of Git is one thing. After that, when Git is what? A version control system. We have installed a version control system. Now, okay. So we have installed Git here. Whenever we start working on a project, say for example, one of you got one project, okay, in your company. So what we do first thing what we do, we create a directory of project name. Say for example, I'll say my project name is project A. So I'll create a directory project underscore A. Okay. Why we do so? I mean, is it necessary to create a directory? I mean, it is not mandatory step, but it's good to follow these best practices, because even in your desktop also, you create separate folders, right? You create folders for songs, you create folders for movies, you create folders for my documents, right? And you keep that kind of file in this folder. Similarly, when we are working on multiple projects, what we do, we create a folder. So directory in Linux is like a folder. And what is the command? mkdir, make directory. Mk for make, dir for directory. So mkdir project A. Then project A directory will get created. Okay. So let's do the same stuff. What we will do, we'll go mkdir. I'll say project underscore A. So project, if you do ls here, you can see project underscore A is created, right? So if you cd to that, cd means I'm going inside that directory. So right now I am here, okay? I am inside the project A. Same thing you can do it Git Bash also, okay? Let me also do the same stuff in Git. This is my Git Bash, okay? This is my Git Bash. I'll say cd colon, I'll say mkdir, I'll say project underscore A, I'll cd to project underscore A. You can see I'm at R partition, and R partition I have created a directory project A using same Linux command. Okay, so this is what the beauty of your Git Bash. Okay, same thing you can do at Git Bash. Okay, so don't worry about. Okay, so I'm using Linux, you can use Git Bash. Okay, that's not a problem. Now I'm at project A. If you do ls-la, the file, the project is the directory is empty. Okay, the directory is empty. There is no file, no directory, nothing is there. This dot and dot is like for Linux parent and current folder. Just ignore this one. Now, first thing first, when you create any directory, okay, when you create any folder, okay, how Git is going to work, let's try to understand. Please pay some attention here. This is our project underscore A. This is our directory. This is what we have created. This directory is right now blank. Okay, so we have a project directory. This is a project directory. First thing, when you create a project directory and you want this project to be under the control of Git, you should run a command that is known as git init. Okay, let me open this. Here, when we install Git, okay, we have configured Git till here we have done, right? So before that, let me also control C, have not run this command. Just run Git here. Okay, you will get a lot of commands like this. Okay, options like this. You can just copy these thing from here. Okay, till here. These are the some action of Git, that commands of Git that you can take. Okay, so how a Git command? What is the syntax of a Git command? The syntax of a Git command is something like this: Git plus some verb. Okay, what is verb? What could be the verb? Your command always start with Git, but it will have some verb. What is verb? Verb is like push, pull, fetch, branch, commit, merge, rebase. All those things are verbs. Bisect, diff, add, mv, rm, clone, init. All these are verbs. If you see init, what init says? If you run git init, it will create an empty Git repository. It will create a Git repository or reinitialize an existing one. So what happens basically, the first time what we did mkdir my underscore or project A, right? Project underscore A. Once you create this, next thing we did cd to that project A. We go inside it. When you go inside it, first thing first you have to initialize Git repo or create a Git repo. If you want this folder to manage by Git, you have to create a Git repo inside it. What is the command to create a Git repo? Git init. What is the meaning of Git? Yes, let's try to understand. First, let's create a command Git init. Okay, so let's go here and run a command Git init. What it says, initialize an empty Git repository, something like this. You got a message. The moment you run a command, you will get this message. I think I have not configured it. Let me also configure it. Kumar, this one. I think yesterday I didn't configure it. So let me configure username, user email ID, and the editor. And let me see Git config list. Yes, it's there. Now I'll go here and I'll reinitialize the repository. If you have already configured it, don't reinitialize it. Yeah, so you should get this kind of message. Okay, after configuration, you should the warning that I have got it is give me a message that it is not configured. Okay, so it's better to configure it and then run the git init command. You can run git init command at any point of time, but even if you run it, you can run it second time, third time, it is not going to make any difference. But you must have to run it. Okay, so this is the command that we have run it here, git init, and we got this message. Reinitialize the existing directory because a directory was already there. So I have first it's initialize it. When I run it again, that is why it says reinitialize it. So this is what this command is saying. Create an empty direct repository or reinitialize an existing one. But what is this repository meaning? Now, let me go here. I'm at the same folder. If I do ls-la, LA means A for all. Okay, ls is a command to list your directory. A is for even the hidden directory, hidden file or directory. Here you can see I have a folder .git got created. If this folder was not there earlier. Okay, any folder in Linux that start with a dot is a hidden folder or hidden file. In Linux, if anything gets start with a dot, it's a hidden folder or hidden directory. How could I know that it's a folder or directory? If it is a D here, initial, D means directory. It means it's a folder or directory. Are you guys getting it? Okay. So it's a folder, it's a hidden folder that got created. So whenever you create a git init command, the moment you run git init command, git init, this will create a folder here, a hidden folder of .git name. This is known as Git repository. What is this repository? This will keep track of all your changes and everything. It will get created in your project folder like this. Who will create it? Git init. Are you folks with me so far? So what is the first step? Install Git, configure Git, create your project directory, go inside your project directory and initialize a Git repository there. So this is how Git works. First we understood install Git. That is step number one. We know how to install. Either you have Git Bash, no need to install it. Second step is configure Git. Third step is create your project directory. Okay. What is the fifth step? Fourth step is cd to project directory and then initialize your the git rep. All right, this is what we have done so far. What this will do, this will create a .git folder. .git folder. What this .git folder contain? It contain all the information that Git requires. Okay? If you cd to .git, you'll see yes, it has head, branches, hooks, and all objects, reference. What are these meaning of it? All these things we will see later. Right. So we are right now at this folder, and we have a .git folder got created. Now we'll create some files. Say for example, I want to create a file. So how to create a file in Linux? What are the commands to create a file in Linux? There are many ways we can create command: vi, touch, nano, echo, cat. There are a lot of ways we can create command in a file. Let me create with touch. Okay, touch is very simple. Touch and the file name. I'll say file1.txt. Okay, so file got created. Let's see. Yes, the file got created. I can see, I can list the file. In order to see whether Git is managing that file or not, what is the status? The command is git status. Okay, what is the command? Let me increase the font size so that you folks can see it easily. Appearance change. Let me make 22. Okay, apply. Okay, so what is a, I can see my file. Yes, the file is here, file1.txt. If I do git status, it will tell me, it will give me this message. Okay, what is this message? Read it. We have created a file first. Okay, we have created a file. Once we created a file, we got this message when we run it on branch master. What is branch? Don't worry, we will see it. It gives me a message, says that untracked file. Which file is untracked? File1.txt is untracked and nothing added to commit, but untracked file is present. And it is giving me also use git add to track. So what happens basically, when you create any file, this is a git.git folder. I will just mention like this here, and like this small git folder, git init has created it. When you create a file, okay, when you create a, this is a file we have created. That is a file1.txt. By default, initially when you create a file, file is only in the control of operating system. Git is not going to track it. Even you have installed Git here, right? You have installed Git, you have configured Git, you have created the project directory, you have initialized the Git repository inside this project directory. Even though Git is not going to track that file, your file is in an Git call this area as an untracked area. Git says your file, when you create a file first, it is in untracked area. This is the message we are getting, right? It says untracked. Okay, untracked area. Untracked area ka, like what is the meaning here? The untracked area is basically the file is only in the control of operating system. It's a two-step process if you want any file to track by Git. First, you need to move this file from untracked area to another area that is known as staging area. Okay, this is, first you have to stage the file, staging area. Okay, first you have to stage that file, staging area. So how to move the add the file to the staging area? Git itself suggests that you can use git add to track it. Okay, so what is the next command? The next command that you have to run is git add and the file name. Git add. What is the file name? File color is right now red. Just put it here. We have run this command git add and the file name. All right. Okay, fine. We ran this command. Now let's see what is the status now. How to check the status? Again, the git status command. Okay, we again got some message, but there is a green color. So red, definitely you can see the green is like the situations are in control now. So let's read this message. It says that on branch master, same on the branch master, no commit yet, changes to be committed. Okay, so and still, I mean, this is, as I mentioned, it's a two-step process. First step is from move the file from untracked area to the staging area. Third step is you have to basically add this, you have to commit the changes. Okay, you have to confirm the changes. And for that, the command, the moment you commit it, okay, this is known as git repo. Okay, this is basically staging area. This is known as git repo. File will be here. How can you do this? You need to commit it. And how can we commit it? The command is git commit -m. You need to give some message. You can say added a new file. All right, enter. Now you got some message here. Okay, git commit some message here. You can see git commit added a new file. It's got root, commit ID, something created and all, some number here, 90CCC1C, some number we got it. All right, now let's see what is the git status message right now. If I run git status again, I got this message. On branch master, nothing to commit, your working tree is clean. On branch master, nothing to commit, working tree is clean. If you get this message, it means that whatever the files and directory inside the Git, it is basically managed by Git. It's now, the situation is now in control. Okay, control means, it doesn't mean that, control doesn't mean like anything burning here, but the point here I'm trying to make, whenever you want Git to start tracking your file, it's a two-step process. It's a two-step process. Okay, what is the first step out of two-step process? 1.1 is whenever you create a file, first you have to stage your file or changes. Okay, that is the first thing. Once you stage, how to stage is like git add and the file name. That is the command to stage it. Second step is basically 1.2 is, or I'll say 2.1 is, you have, once you stage it, you have to commit the changes. How can you commit the changes? You can commit the changes with git commit -m and some message you have to give. This is the two-step process for if you want any file to be tracked by Git. From here to here, you can run git add command. Okay. From here, you have to run git commit -m command. Okay, you may ask like why it's a two-step process. This is how Git has been designed, and you will get this answer also why it's a two-step process. As we move ahead, you will understand this one. But as of now, just remember, when you create a file, by default in which area the file will be under the control of Git or only the control of operating system. When you create a file will be only in the control of operating system. Untracked area means it's only in the control of operating system. Once you run git add, Git put that file into the staging area, but Git also want a second level. It's a kind of a second level of confirmation that are you really want me to track this file? Then you say, yes, I want you to track this file using git commit -m. So for step number 1, step number 2. All right. So this is how, and everything will get recorded here in the Git repository. Whatever you are doing, whatever the changes is happening, everything how Git tracks, Git keep everything, all the records in .git folder. All right. Staging area means Git will start monitoring this file. It will keep an eye, like, whenever you make some changes or something, like, this one, version control system that we discussed, right? It will versioning of that file, everything will start monitoring this. Okay. Let's create one more. Right now, how many files I'm having? I'm having file 1.txt. Let me create one more file 2.txt. I have two files now, file 1 and file 2. If I run git status, can you see that I'm getting this message again, but only for file 2, not for file 1. Untracked file 2, because file 2 is newly added file and it is not going to be tracked by Git by default. You need to tell Git I want this to be tracked. So for that, what we'll do git add and file 2.txt. Again, when you run the git status command, it will tell you that it is not committed. So what you have to do, you have to again add git commit -m and the name of the and some message. You can say added second file. All right, so it's now committed. If I again run ls command, I can see two files. If I do git status, my working tree is clean. So okay, so for every file you have to do this. And now let me also tell you what is the meaning of this configuration that we did configure, right? Git username, email ID and all. There is a command that is known as git log. Okay, the moment you run this command, you can see that, remember this was the first commit 90cc1c. This was the same number 90cc1, right? Some initial of that number will be here. Okay, so this is a hash. What is the hash meaning and all, I will tell you later. But this commit, who made this commit? This guy made this commit. When the commit was made, at this point of time the commit was made. What was the comment? Added a new file. Okay, this is the second commit for file 2. This is the commit ID. Who made this? This guy made it. What was the time? This was the time. What was the message? This was the message. So because we have configured Git like this, who is making all those changes, who is our admin and all, that we have mentioned here, right? So everything is getting tracked. Who made these changes? What was the time? What was the Git message? Everything is getting mentioned here. If you don't configure it, it's very difficult to track who made these changes. All right. So it's better always to configure it. That is why we configure Git, so that in the message it should make some sense who made it. If I want to say, for example, you are working this system from last 6 months, 1 year, you will have so many messages. Okay, you will have so many messages. I will show you one of the example. Okay, let me go to my GitHub. Whatever I am doing, just ignore it for a second. Let me go to CD. Just ignore this clone command for 1 second. Okay, I will tell you this command. Spelling is wrong. So I have a Git repository where I'm working from last 1 year. CD to my Ansible. Okay, here I have a lot of folders, lot of files created. If I run git log here, you'll see that these many messages, like these many messages, you can see. Can you see that? So these messages, whenever we commit it, these messages and timelines sometimes very important to troubleshoot. Okay. So when this message will make sense when you will have start working on Git and working for quite long, then you're able to understand what is the meaning of all. Let's go to CD to project A. All right, so this is first thing that we need to know. Second thing, let's make some changes here on any file. We have two files, okay? Both the files are blank, right? If you do cat is to read the file. This output is no output, it's a blank. If you do cat again file 2.txt is blank. Let me put some content here on. I'll say this is my code. I'm putting this content to file1.txt. If I do cat of file1.txt, you can see I am getting the output. This is my code. All right, this is my code. So the file1 got modified or not? The previous status of the file was blank. Now I have added some content. Is the file got modified? Obviously yes. मैंने कुछ file में change कर दिया, right? I mean file got changed. So change means what? It got modified. Right? Now let's run the git status. Git status. It says that git changes not stage to be committed. So what happens? Just let me first explain it. This is the normal scenario. Okay, this is the normal scenario whenever you have Git works like this. So whenever you have a file, your file will be available in all the three areas. Okay, when the git status is clean, Okay, what is the status? It is when it is a Git status is clean, your file will be here, your file will be here, and your file will be here. And all these three stages are in sync with each other. Whatever the content here, the content is also same. Okay, all these three locations are in sync with each other. Okay, it is sync here, it is sync here, like this. It will be in sync. Now we modified the file. Okay, we modified the file at the operating system level, right? Because we use the operating system command and we modify the file. So what Git does, it says whenever you modify a file, there will be one more area. I mean, its area is not like an area, just conceptually I am explaining you. Okay, that will be something like this. That Git this is called, this is a modified area. You can see modified. Okay, this is modified. Okay, and your modified file is available here. Again, what you have to do if you want this modified changes to be committed, you have to again run git add and git commit command. Okay, so what here it says modified, right? So what we'll do, we'll say git add and the file name, file1.txt. And if you run git status again, it will ask you for commit. It will say it is not changes to be committed. So what you should do, git commit -m, and you say edit a new line. Okay, and just press enter. And again, if you run git status, it will give you working page is clean. Are you folks getting it? So two things you need to remember. Okay, this is the complete, this is how Git works. Okay, there are, when you create a file, I'm just summarizing everything. Okay, when you create a file, the file is in control of operating system only. That area get called as an untracked area. If you want Git to track your file, start keeping an eye over the file, you need to stage it and commit it. This is a two-step process. Okay. Once the Git start tracking any file, and if after that you modify that file, Git will put this file into the modified area. Okay, Git will treat this as a modified area, and Git wants you, are you sure that this modification you want me to track? It will ask, because whatever the changes you made, say for example you made 10 lines of modification in your code, but Git doesn't know that whether you want to go with this 10 lines in your production or not, whether you want to release this code or not. Git doesn't know that. You need to tell Git always, yes, this new 10 line that I have added because of which my file got modified, or the any line that I have deleted because of which my file got modified, I want to move this file as a final version. So it will say git add and git commit again. Okay, you may ask, oh, Git should automatically track it. What is the point of having version control system? No, version control system gives you the facility to keep all the version of your files, but it is not going to take decision on your behalf. It is your decision. Just try to understand, you are the owner of this code, you are the owner of this file. What version you want to finalize, you should know. Git is just a tool. Okay, Git is just giving you the facility to use this thing. Whether you really want to go with this version or this version, it's your choice. Git is not going to tell you that use this portion of the code or that portion of the code. That is, you need to decide as a developer, or you are the owner of that file. All right, let me make these changes one more time. So we have two files. Okay, out of this we have modified the file 1.txt. Now let's modify the file 2.txt. Right now the file 2.txt is this. Okay, and if I to file 2.txt and I'll open like some content here, I'll say this is my second line code. Alright, so if I do cat of file 2.txt, I can see the content got added. But if the content got added, if I run git status, the file also got modified. Yes, it got modified. It's a modified area. How to commit these changes? Again, we have to do git commit and sorry, git add. First, you need to do git add and the file name, and then git commit. And I'll say added new line add file 2. Okay, whatever, some message. Okay, so I have committed it. Now, if I do git status, I can say it's clean. If I do git log, you can see how many commits I'm having 1, 2, 3, 4, all those changes, and first, second, third, fourth, every commit is getting recorded by the user, time, everything is getting recorded. Okay. Let's modify both the files. Unless it says, I'll say echo, let's say add one more line. Okay, and I'm adding to the file 1.txt. Okay, and the same thing I'm adding to the file 2.txt. Both the files got modified. If I do git status, I can see that both the files are modified. Okay, all right. And what is the how to fix this? I can run git add command. Git add, and I will run git add for both the files. I can run for multiple files also. I'll say add file 1.txt and file 2.txt. And git commit, I will commit the same thing. I'll say added second line over both the files. All right. And if I run git status, my working tree is clean. So we have covered so many stuff. I mean, this is version control system we started with. And this is, we discuss about the version control system. It's very important concept that we have discussed. So we started with a concept with that there are a couple of how Git works, right? How Git works. Whenever you create a file, by default, it will be in an untracked area. Untracked means it's in control of operating system. Okay, from untracked area, you can move this file to staging area. And from staging area, not move, I mean, you can put the file in staging area and then you can commit those changes. The moment you did all these two things, your file is getting tracked inside Git repository .git folder. Git will start tracking your file. That is what the repository meaning is here. All right. Once you are done with this, okay, what is the two-step process? Stage your file and commit your file. After that, even if you modify your file, Git will again put your file in an area known as modified area. What you have to do in modified area? Modified area, basically, you need to do Git. Again, you need to stage your file and commit your file. You need to confirm Git, yes, I want to make those changes. Okay, then Git will start tracking all your file. So whether it's a new file or it's a modified file, it is always going to be the two-step process. Okay. Now we are going to understand some of the commands. Okay, and we are going to discuss about something known as branching in Git. Okay, branching. And this is the most important concept of Git, known as branching. Okay, so what is basically branching means? You have seen this message, right? ls my project A, where is my project A? CD to my project A. If I do ls file 1, file 2, if I do git status, I can see on branch master, nothing to commit, working tree is clean. Alright, so what is the meaning of branching here? Okay, so this is what we are going to discuss. What is the meaning of, it says on branch master? What do you mean by on branch master? Okay, so whenever you create a Git, okay, I mean, Git has a concept of branching. Branching means like something like, it's a very powerful feature that basically allow you to diverge from main development and do a different work or feature or fixes. Say for example, I am working on, this is our project. Okay. This is our project. Okay. Here we are working. Okay, and this is our directory and this is our code. Just imagine this is any famous application. This is, say for example, any app that you're using on your mobile. Okay, say it's a Truecaller, it's any food delivery system like Zomato, Swiggy, whatever it is. It is an application that you're using. So there is a team behind it, right? I mean, who developed this particular application? There is a team behind it who developed this particular application. They are working over this application and they are making git commit git like this, and at the end when the product is ready, you and me started downloading it and started using it, right? This is something like, this is the product that we are downloading at our laptop desktop and we are using it, and application is very fine. But you may also have seen that whenever you use any product, there you may also have seen like a new version of this is available. Would you like to upgrade? Right? You have seen it on your phone, on your laptop, whatever software that you are using. You will get a pop-up that new version of Truecaller is available. So from where this new version is coming? So whenever this team has to, because this is the first version of application or nth version of that application. We are going to upgrade our application. Why? Because we are adding more feature on our application. Whatever the feature that is not available, we are adding those feature. Okay, and we are maybe the feature addition, or sometimes that application that user is using, maybe that application has some bug. It has some bug and it has a known issue now. And what we generally do, if we have to develop any feature or any bug, we don't work on this branch. This is my release branch, that is my production branch. What we do, we create another branch out of it. Okay, we create another branch out of it, and here we do all the R&D and all the fixes and everything, because this is not going to be exposed to the customer. This is kind of our test lab kind of thing, where we are doing all the changes, all the R&D and all. And here another set of people may be working. Okay, they are doing all the fixes, all the upgrade and everything. When we create a branch, all the content of the branch will be available here, but we are not going to disturb this main branch. All the content will be here. We'll make some, say for example, we'll make some changes here. Okay, we'll make some modification of the file and blah blah blah, lot of things. And when we realize that okay, the changes are stable, the fix are good, now what we will do, we will merge these changes to the new branch, I mean the master branch. First step is, what is this step? This step number 1 is to create branch. Why to create branch? Create branch. We want to create branch because we want to enhance the feature. That could be one of the reason. We want to fix the bug. That could be also one of the reason. Can't we enhance the feature and can't we fix the bug in the main production branch or the master branch? No. Why? Because it may disturb the stable product that is already other lot of our customers are using, right? It may disturb, because you have downloaded a Truecaller, tomorrow somebody else will download the Truecaller or maybe another app. So in that case, if I'm doing the changes here only in this branch, it may make this product unstable, and nobody will, it will give it, customer will get a very wrong message that that product is not stable. So instead of not disturbing the main branch, thus the release branch or the master branch, we call this as a master, okay, or main. Okay, this is our master or main branch. Okay, so what we do, first we create a branch. This is step number 1. Step number 2, apply fixes or enhance the feature, or we can say upgrade, whatever, fix or upgrade, whatever you want to do, it's your, depending upon the use case and issue, you'll do that. And when you are happy, like it may take, say, for example, 1 day, 2 day, 1 month, 1 year, I don't know. I mean, it will take some time. Okay. It may be 1 hour job, it may be 1 day job, it may be 1 week job, it may be 1 month job. We don't know. But this is what we will do. When after that we realize that now this is the more stable version, we have tested it, we have applied all the changes, everything is working fine. Now I want, say for example, this is my 10th version of my application, 10th version. Here we developed the 11th version of my application and we have tested it everything. Now I want my customer to use this 11th version. I cannot give it from here. Okay. Product will always get released from the master branch. So what I will do, step number 3 will be merge the branch. Merge with master. So that whenever you merge it, okay, merge with master. So when you merge with master, what will happen? When you merge with master, whatever the changes that you have made, it is now available over here. And you and the end user will get a pop-up, new version of XYZ software is available. Would you like to upgrade? The moment you say yes, it will get downloaded and then your application or app will automatically get updated. Okay. So couple of things that we need to remember here. What is branching? Branching is a concept. It's a very powerful concept. What it give us, like what feature, what facility it give us? It allow you to diverge from the main development line, work on your different fixes, different features. Okay, and it allow you to work in collaboration. Some member of your team, this is the same Infosys team, this is the same Infosys team, this is the car loan, this is the car loan 10th version, this is the car loan 11th version with some new feature we have released. Some features, some member of your team will work on the main branch, they will cater the customer request or anything or something like that. Some member of your team dedicatedly work on those fixes, those bugs, or those upgrade or those features to make a new version. All right. So we are discussing Git branching. Okay, so what is Git branching? Git branching is a powerful concept. What is this concept that we have discussed? In Git branching is a powerful concept that allows you to diverge from the development line and work on a different feature concurrently. It enables to collaboration among different blah blah blah. But whatever we have discussed, the same thing. Okay, just as a notes for you. Now we are going to discuss about merging. Okay, let me first explain with the help of diagram. Okay, so what happens? This concept is clear. Now we are going to discuss about merging. There are two types of merging. Okay, just try to understand. First scenario number 1. In this scenario, say for example, I am creating a branch. This is my master branch. I have initialized a repository. This is my master branch. Okay, if you pay attention, you will understand in the first go. It's very simple. If you don't complicate your mind, you will understand in first go. This is my master branch. At master branch, at some point of time, I have created a feature branch. Okay, I have created a feature. Say for example, I have created a feature branch at 8 a.m. Okay, at 8 a.m. I have created a feature master branch. This is the feature branch that I have created from the master branch. Okay, what is the name of this branch? I can give any name. I can give, say for example, feature branch. Okay, when I'm creating a branch from master feature branch from the master branch, whatever the files and content that is available at 8 a.m. at master branch, everything will be available it will get copied here. Okay, what is the statement I'm making? Whatever the files, whatever the content, whatever the version of file, whatever the status of the master branch at 8 a.m., the same status, same way, same thing will get created in the feature branch. After that, I am started working on some fixes, some feature, and I work for 1 hour, say for example, till 9 a.m. Okay. At 9 a.m. I realized that whatever I have done, I made some changes. Okay. This file, one second. I made some changes. Okay. And at 9 a.m. I found that now I am ready to push these changes, merge these changes with the master branch. And what I did, I just merged this change with the master branch. Here at 9 a.m. I did what? Merging. How this thing will happen, how to create a branch, how to merge, everything we will show practically. But try to understand the concept first. But from 8 a.m. to 9 a.m. there were no changes done at the master branch. During this time, during this interval, there were no changes made at master. I mean, there were no new commit. Changes means what? No new commit happened at the master branch. Which interval? From 8 a.m. to 9 a.m. The moment I created the branch till the moment I merged the branch, there were no changes done during this interval. When this kind of scenario will happen, the Git is basically does merging known as fast forward merge. Okay, this is known as fast forward merge. Why it is named fast forward merge? If you see clearly, I mean, if you see, just imagine, even if you don't create this branch, isn't it the same thing is a linear approach we are doing? Can I put something like this here? If I say the same thing, like whatever the changes you made it here, okay, can I say that is the same straightforward change here? I mean, I can do the same thing in the branching because there were no commit happened during the same interval. Whatever we did it here, isn't it same look like this straight line? I have created a branch. After that, I made some changes, but during this interval, there were no new commit happened at the master branch. If this is the case, the Git says it's a fast forward merge. Isn't it look like same? If I'm making the changes here at the master branch, instead of I'm making these changes, it's almost similar like this, right? Same straight line. This kind of changes Git says it's a fast forward merge. Okay, when there is a new commit happen during that interval, then Git says it's a fast forward merge. Let me create it, and then it will become more clear. Okay, with the lab right now where we are at Git status. We have on branch master, nothing is, I mean, everything is clean. So this is our status, right? If I do git log, I can see this is my latest log. This is my latest message, right? Git log is this. This is the latest one. Okay. Right now, what is the time? 7:37, and at 7:37, this is the status. At my laptop, IST time zone, it's 7:37, and this is the status. Okay. Right now, let's create a branch. How to create a branch? The command is git branch. Okay, if right now, let me see how many branches I'm having. The command, if you just run command git branch, you will see that, sorry, not branches, spelling is wrong. So I have only master branch and star is here. Star means wherever you are, the star will be there. Okay, if you create another branch and you switch to that branch, the star will move to there, and that will also become bold. So this git branch is saying me that I have right now at 7:37, I have only one branch, that is master. All right. Now let's create a branch. How to create a branch? The command is git branch. Okay, and the name of the branch. Say for example, I'll say feature branch. Okay, and from master. Okay, so I'll create a branch and so this is the branch that I have. Let me first run git branch again. Can you see that I have two branches now? Earlier it was master only. Now I have a feature branch. How I have created? Git branch, name of the branch, from which branch I want to create? Feature branch. Same way, if you want to create another branch from feature branch, what you have to do? Git branch, new branch, feature branch. So this is the syntax that you need to remember. Okay, so we have created a branch at 7:37. We have created a branch. I'm just making that right now the time is freeze. Okay, so this is what we have done at 7:37 and we have a new branch created. But right now where we are at the master branch because the star is at the master branch and even the master is in bold or something, right? So that is why. Now if you do ls here, we have two files, file1 and file2.txt. So we have this master branch. Okay, we have this master branch. Master branch has two files, file1 and file2. File1 and file2. Two files are here. From this master branch, we have created another branch, that is feature branch, like this. And this is our feature branch at 7:37. When we created this branch, okay, everything will get copied. This is what I'm trying to say. Everything will get copied. Now, if you want to verify it, what you can do, you can switch to the feature branch. How to switch? Git checkout. Git checkout feature branch. What is the message we got? Switch to the branch, feature branch. All right, so let's see. Let me copy this one. We are now at the feature branch. If you want to verify, just run git branch. Can you see that I'm at feature branch and it turns green, bold, and star is at the feature branch? Yes, we are at the feature branch. All right, we are at the feature branch. Now let me do ls here. Can I see both the files, file1.txt and file2.txt also at the feature branch as well? This till here everything is clear. At 7:37 we have created a branch. Whatever the from the this is my master branch and this is my feature branch. All right. Now what we will do, we will make some changes at the feature branch. I mean, I'm working on some fixes, on some upgrade, I don't know, but let's make some changes here. So we'll create a file, we'll say touch new file feature.txt. I'm creating a file here. Where I'm creating a file? At the feature branch. So this is my file, new file txt. Okay, I have created another file here. If I go to the diagram, I have created another file. I can say this file as f_new.txt. Okay, f_ no. Just imagine this is full name because I cannot write full name here. It's a very small area here. So whatever the file name, feature new feature txt. Okay, this file is this. Okay, this is the new file. Sorry, this one. Okay, now what is the next thing? If you run git status, you will again get untracked. You will see on branch, feature branch, not master, untracked file. So you have to follow the same process, git add and git commit. So I'll say git add, which file to add? New feature file.txt, git commit, git commit -m. I'll say add it, new file. All right, enter. And we'll copy this message. Okay, what we will do, we'll copy from where we have created. No, let me go to my text file. Okay, we just created the branch. From there we have to copy everything. So till here to here. Okay, from here to here we will copy. So this is the commit message. So can I copy this commit message and say this was the commit, latest commit message when we committed the third file. And what was the latest commit message at the feature master branch? The latest commit message at the master branch was this. Right, I'm copying some initial of it. It's a okay. So this was the latest commit message here. All right, this is our status. Now I want to merge it. For merging, what we need to do, we have to first check out to the master branch. We have to go to the master branch. Okay. Git commit. This is something is there. We have created it. Now I need to switch to the master branch. So how to switch to the master branch? So right now if I do git branch, I can see I'm still at feature branch. So let's switch to the how to switch git checkout, the same command. Git checkout, but the name of the branch will be master because I want to switch from feature to master. So it says you switch to the master branch, and if I run git branch again, and you can see I'm at the master. So we switch back to the master. Okay. We made some changes, we made some configuration, we made some fixes, and after that we switch back to the master branch. Alright, now if I do ls here, can you see that the third file is not available at master? The third file we have created, new feature.txt, it is available only at feature branch. But this is my latest version of code. This is my Truecaller ka new version. I want this to be used by end user. So what I need to do, I need to merge it. Okay. So first I move to the destination branch. There I will do merging, and I will say, what is the command for merging? The command for merging is same. I mean, git merge and the branch name. Let me go here. Okay. We'll say git merge and feature branch. I want to merge feature branch to main master branch. Okay, I want to merge feature branch. So first I am at the master branch. Here I'm running a command git merge and the branch name. Now let's copy this message, and this is what I want to tell you. We have merged feature branch and we got updating 09 to 56. What is 09 to 56? 09, the latest commit of the feature branch, I mean the master branch, when we created the branch with 865df. What is this? This is 86, the commit of the latest commit of the feature branch. So these two commits are getting merged with each other. These two commits are the latest commit of the master branch and the latest commit of the feature branch are getting merged. The type of merge is basically fast forward merge. Fast forward merge, why it is a fast forward merge? Because when we created the branch from the master branch at 737, where is that? I have mentioned somewhere, right? 737. I have mentioned where? Here, right? At 737 IST. Okay. At 737, we performed this exercise. We created the branch, we created new branch, and we made some activity. Now we came back at around 748. Okay. Just keep it a round number. Let's say 750. Okay. Just 750. We came back at 750 and we merged this branch, feature branch, with the master branch. When we did merging, okay, at this point, from 737 to 750, okay, have we made any changes in the feature in the master branch from this time to this time? Is there was any new commit happened at the master branch, or the status of the master branch is exactly same when the feature branch created and when the feature branch get coming for merging? The status is exactly same. During this interval, no one from our team did any commit any changes at the master branch. When this will be the status, when the master branch there is no change till the time you created the branch and you are merging the branch, this is known as fast forward merge. And what happens basically, if you see these two numbers, okay, if you see these two numbers, merging this and this. Now if you see git log, now let me first do ls also. I am at master, now new feature txt file is available. Before merging it was not there, right? Where I am right now, git branch, I am at the master branch. The file we have created at the feature branch is now available at the master branch. And if I do git log, I am getting say number 865 something, and this is the same number. If you see, this is the same commit number of the feature branch. So what Git does, Git is a very smart guy. He sees, he is not, Git is not seeing like the way we are looking at it. Git is looking like it a little differently. Git says that, okay, at this point you have just master branch, and you created a feature branch and you make all these changes, and now you are coming back to merging it, but here till here to here there were no new commit happen at the master branch. So isn't it the same way? If the way the things work, I mean, instead of making the changes like here to here and coming back here, isn't it the same straight line? Because this is what I was copying here. Okay, this is what I was copying here. Isn't it look like same? This, because you didn't make any changes at the master branch at this during this interval. So Git will see like this, and it says that okay, instead of what I can do, I mean, even if you perform the same stuff here, you will get a new commit ID here. You will get a new commit here. So what I'll do, I'll give the same commit here, and this is what your latest point. That kind of merging is known as fast forward merging, and that generally in production or in a very busy environment, it's not like the case, because we have multiple branches and something will merge. But this I just want to explain you what is fast forward merging. So instead of this commit here, it's something like the same commit, we can refer it to our latest changes. So that is why Git says it's a fast forward merge. Okay, fast forward merge, because Git realizes it very quickly and it says, okay, let me give you like this. So when the fast forward merge will happen, when you create a feature branch and when you are merging it, till that time, if there is no new commit happen at the master branch, Git will do fast forward merge. For it, first let's see another type of merging, that is known as three-way merge. Now, if this till here you are with me, what would be the second scenario? So first scenario you discussed that in the merging, the scenario number 1 that we have discussed here. Here what happened? In this scenario, there won't be any changes at master branch till the time of merging. And this was the scenario. There won't be any changes at the master. Changes means commit. There won't be any new commit at the master branch till the time of merging. What would be the second scenario? Just opposite of it, right? Second scenario will be scenario number 2. What could be? There will be some commit. There not won't be there. There will be some commit. Some changes, or we can say more appropriate word is commit. Commit at master branch till the time you are merging. What is the meaning? What I'm trying to say here is, in this scenario, when you create all those things, say, let me copy the same stuff. Okay. Okay, this is the scenario. You created everything at 7:37 IST. Okay, you are making some changes here. Parallelly, what is happening? Parallelly, during the same interval, when here to 7:50, there were some changes also happening at the master. Okay, we are creating file number 4, and we did some commit. Okay, we did some commit. The commit number here, you got some new number, something like some new number like this. You have committed, and you also made the changes at the feature branch during this interval. You also made some changes at the master branch. Now you want to merge it. In this case, you have to merge. You want to merge these two things. These two commit you want to merge, right? This is not the same commit as at 7:37. It's different commit, and you also made some new commit at the feature branch. Now you want to merge it. This is known as three-way merge. Okay, three-way merge. What is three-way merge? Why it is a three-way merge? This is commit number 1, commit number 2. What Git will do, I will tell you, and then I'll show you. Git will create a new commit, a totally new commit. And this new commit will point to these two commit. It's a kind of a soft link. Okay, it will link to this commit and this commit. Because it's 1, 2, and 3 commit, that is why it's called three-way merge. Okay, let's do it practically. Then you will be able to understand more. I hope it is making sense to you. This scenario is clear. At least this may happen, right? When till the time you are making, say for example, it will take 1 month. What could be the possibility? Maybe I have another feature branch. Maybe I have one more feature branch. This guy is making some changes till the time they have committed something. So the commit will change. Now they made some commit. I also want to commit. So there will be multiple of branches. There will be multiple of branches. But anything get released from where? Anything and everything will get released from the master. How? Whatever you have done, you need to merge it. Whatever you have done, you have to merge it. Okay. So the chances of fast forward merge in a practical scenario are very, very, very less. Okay. Fast forward merge in a practical scenario is very less. If your project is small, you're making small changes, that is fine. Something like you are running something like Zomato, you are running something like Swiggy, you are running something like a very pop Netflix. So probably fast forward merge is not going to happen because people are making a lot of changes. There are a lot of features, a lot of teams are working parallelly and they are committing their changes to the main product. Okay. So this is going to be the real scenario. Most of the time you'll face this thing. Do we have to do anything differently as a user? No. Git will automatically take care of it, is even if it is a three-way merge or fast forward merge, the commands are exactly going to be the same. Okay, sometimes this fast forward merge we also call recursive merge. Okay, so let me do one thing. We'll go here. Let's do it from scratch. So what we will do, where I'm right now, let's let me create a directory. We'll say mkdir git three-way merge demo. We'll cd to that. We'll do git init. Oh, sorry, I didn't edit it. So where is that command? Okay, so we have initialized it. All right, so now let's create a file. We'll say hello example.txt. I've created a file. This is a file, right? Now, what is the next thing? We have to add it and commit it because Git will give us some message. Not commit yet. So untracked files. So we'll say git add and git commit. All right. When we did git commit, we got this as a commit ID. Okay, so we'll copy this commit ID here. Okay, this is the commit ID in our diagram. Okay, and we have just one file, not this file. We have example.txt file. Okay, all these things I'm removing. Okay, and just removing all these things so that we'll go exactly. We have not yet created this branch. Just imagine the time is 7:37, okay? And this is the status. Now what we will do, we'll create a feature branch. So there is a two-way. I mean, you can create a feature branch and you can check it out. Like yes, last time we created a branch and then we checked out, right? In the two-step process. What is the another way? I mean, you can first create a branch and then check it out, right? The two-step process. The another process is in the same single command. Right now you can say git branch. You'll see master. What I'll do, I'll say git checkout -b. It will also create the branch, feature branch, and also I'll check it out. So let's see. You can see here I also got switched to that branch. If I do git branch now, I'm at feature branch. So it's your wish whether you want to use one single command or a two-step process. It's your wish. All right. So we are here. Let me also make a note of it, or from here to here. Everything will be get copied to your notepad. All right, so we are here now. What we will do, we will make changes here. Okay, let's say for example, we will go here, and if I do ls, I can see example.txt. All right. Let me create another file. Let's say I will create echo. Let's say this is feature branch. Okay. And I'll create a file feature.txt. Okay. Let me see. I have two files. What I'll do, I will git add and the feature.txt. Then I'll do git commit. I'll say feature branch commit. Alright, this is the commit ID. I got it. Let me copy this commit ID, and also let me copy the whole example so that we can repeat it later. But anyway, all the labs are already available in my GitHub. Okay, step-by-step documents are there. Even if you're missing something here, it's fine. You can get it. So this is example.txt. That is a file that get copied when we created the branch. After that, we created another file that is feature branch fd.txt. All right. So looks okay. Now what we'll do, we'll go to the master branch here. Okay. Master branch. This is that. This was a commit ID. This is the commit ID here. Okay. Now we'll go to the master branch. How to go to the master branch? Git checkout master. We'll go here. Git checkout master. Switch to master. There's no fb.txt. We'll create another file. We'll say echo. We'll say master. And we'll say master.txt. Master.txt. Alright, so we have another file here, master. Till that time, somebody making some changes, assume that same thing is happening parallelly, but even if it is not happening parallelly, that's perfectly fine. What we'll do, we'll say git add master.txt. Okay, and then we'll say git commit -m. We'll say what was the message for text we have filled? Commit message. What was that message? FB commit. Okay, so we'll say master commit. All right. So this is the new commit. This is the new file. So this is the new commit here. Okay. Now I want to merge this feature branch with the master branch. I want to do merging. I want to merge this feature branch with this guy. This thing I want to merge. Something like that. And this guy has a new, this is not the previous commit at the time of creation. The commit got changed. It has new changes. So what is the merging? Again, we are here. We are where? We are at the master branch. If you see git branch. What is that? What is that? It's master. Now how to merge it? Again, git merge. What is the name of the branch? Feature branch. So here Git will open a text file for you. This is a message. Remember, every time when you do git merge, whenever we run this command git merge, listen it people carefully. It's not nothing new is happening. When you do git merge, you have to type a message. Okay. In this message, you are telling Git whatever the message you want to type. That just like here we type git merge, master commit, feature commit, whatever we have typed. But here there is a change. I mean, Git is now opening a text file for you, and Git says, this I am going to merge. Do you want to put some message? Because this is a special case here, because there are two things that are different. That is not the same. So that this is where your third line of your configuration, where you specify the editor vi or notepad or something, you will use that editor to open the file. Because I have specified vi, so file got opened. Git says, do you like this message to go and commit it, or you want anything else? If you just save it, Git will give you this message, merge branch with merge branch, feature branch. If you don't like this one, I can say I said I don't like this one. I'll put something else. So I'll say for example, oh, and what I'll do, I'll delete it and I'll put the message. I'll say this is merging of feature branch with master after new commit happen at master. I mean, no need to write this much long message, but I'm just making sure that you must see it. Okay, and then I will save it. So what is the message I got when I merge it? I got merge made by ORT strategy. This is ORT is a three-way merge. Okay, earlier they were printing three-way merge. Now they are printing ORT strategy, the latest version of Git. So you can also say this is an ORT strategy. What is ORT strategy? That is nothing but a three-way merge. Okay, you can just copy it. Anything special happened here in the command? No, nothing special. Git is taking care of it, but Git wants your confirmation that yes, this is going to happen. Can you confirm it? For that, it is open the file. It just opened the file for new merge to be happen, to new commit to happen. So let me paste it here. So now if you look at Git status, the Git log, just read this Git log carefully. It created a new commit for something something. This is this new commit. A new commit got created. Okay, for something something. But if you read the next line, for something something is pointing to 893. What is 893? 893 is this guy. And it is also pointing to 42EA. What is this 42EA? This commit. So what actually Git does, I mean, what happened? I mean, if you read the log carefully, you will understand what actually Git is doing. And nobody explain all those things. I mean, this is the problem. I mean, if you see, this is the new commit. For every commit, you have to type message, yes or no. Every commit, you have to type a message. Yes. For message, in order to type message, Git has opened a file for you and asked type some Git message, Git commit message, and it also showed a default message. If you are happy with that, you can go with this. Otherwise, you can erase this one and you can type your message. So this, because of that message, the file got opened because Git is creating a new commit. Why Git is creating a new commit? Because Git says, okay, there are some different changes. Let me do one thing. Let me create a new commit and I will point this commit to these two commit. Okay. And because this is, in this case, the changes are not like a straight line. The changes are not like a straight line. What do you mean by straight line? It is not like this time. It is not like this time because there were different commit happened. The master branch has changed. For this, Git handles it very effectively. It's create a new commit and pointed this commit to these two commits. All right. If you have n number of branches, then there will be one more new commit. It will point to like this. It will create a tree structure that we'll talk tomorrow. What is this tree structure and all? But I hope you folks are getting it. Three-way merge, ORT merge, recursive merge, all the things are same. Okay. So, but from our side, there is no change in the command. Same command, everything. In the three-way merge, Git will create one more new commit. For that, you have to give some message. In order to type the message, because you are not running the Git commit command, you are running a Git merge command, right? You are running this command. For this, in order to type the message, commit message, it opens a file. In which editor it will open a file, whatever editor you have mentioned in your configuration part. If you are doing the same stuff in Git Bash, and if you have mentioned Notepad here, it will open the file in Notepad. If you mention Notepad++, it will open the file in Notepad++. All right. Let's discuss about the conflict and what do you mean by conflict. Let's see. We'll take a fresh example here. Let me create a directory. I'll say mkdir conflict example. Will you cd do that? Conflict. Here you'll see the file is blank. Let me first configure it. Okay, and if I do a git list, I should see my configuration. Yes, that is fine. Now what we'll do, we'll initialize git. We'll say git init. Why we are getting this message? Okay, let me rerun it. Not sure, maybe this command didn't got run or something, but it got set, right? I mean, I can able to see it. Let me go and run it, initialize it again, git init. All right, anyway. So this is fine. I mean, this we have done many times. Now, what is the meaning of conflict? I will tell you while running the example itself. So let's create a file. We'll say text file. We have created a text file. We can do git add, and then we can commit it. We'll say git commit. We'll say initial commit, and the number is 8. This is the initial commit. We are going to discuss about, we are discussing basically the merge conflict. So this is the merge conflict right now. Now we are going to create a new branch and we'll switch to that. Okay, say git checkout branch, and we are switched to this branch. Now we are having example.txt file here as well in the feature branch. If I do git branch, I will see I'm at the feature branch and I'm having example.txt. If I do git status, my branch is clean, working is clean, everything is good. Now, if I do cat of example.txt, I can see hello world. That is the first line of entry that we made here in the master branch. All right. Now what we'll do, we'll make some more entry. We'll say echo, and I'm appending that entry. Okay, I'm using double quote arrow. So here you can see if I cat of example.txt, this line got added. That is the meaning of this append. If you're just using one arrow, it will override this one. So we are appending it, and this is why we are able to see it. Yeah, now because the status got changed. If you don't get status, it will say modified. So what we'll do again, we'll do git add and git commit. All right. Let's say git commit. So here you can see from what till what point I have copied till this point. Okay. So let me go and copy it from here till here. All right, so we made some changes, and we made some changes at the file number, same file, line number 2. We added one more line. Now we'll go back to the main branch. Right now, what is the status? If I do ls cat of that example file, I can see there are 2 lines, hello world and changes from the feature branch. Now let me check out to the master branch or the main branch. We'll say git checkout master. I'm at the master branch. Here, if I do ls and if I do cat of example.txt, I will see only one line. Yes, it's one line. Now let's, when the conflict will happen, the conflict will happen when there is a file. Okay, some line number 1, line number 2, line number 3, line number 4. Somebody from one branch making the same file, same place, something else. Somebody making the same file, same change, something else on the same location. Here the line number 2 is this is from the feature branch. Okay, now let's change this line number 2 in the master branch, add something else, and then try to merge it. Okay, this is the output of the feature branch. Okay, this is feature branch output. Now let's see how it happens. So we have a file. Okay, This is the file. Can you see this file? This is output, but this is output on which branch? Feature branch, right? So the feature branch has two lines, line number 1 and line number 2. The master branch, we have only one line. Okay. Now I am going to add a line number 2 at the master branch, but a different content. Then there will be conflict. So let's do it. I'll say echo, I'll say this. I made this change. Now if I say cat example.txt, this is a, so what is happening here? Let me copy these two things. This is feature, change from the feature branch, and this is master. Same file, same location, different entry. Okay, this is FB, not Facebook, it's a feature branch. It is master. All right, so what we will do, we'll add and commit these changes at the feature master branch as well, because we have just made the changes, it's modified. We'll say git add and git commit. Okay, so we will copy this content till here and paste it here. Okay, we checked out to the master branch. Here what happened on master. Okay, we checked out at the master branch, and this is what we do. Right now, let's try to merge it. Okay, just understand at the feature branch, file is same, but the content is different at the line number 2. At master branch, file is same, but the content is different at the line number 2. Now, if you want to merge it, we already at the master branch, we will do just merge. Git merge feature branch. Where right now, let me do press Control C. I have not run this command. It's Control C. Let me show you. Git branch. I am at the master. I want to merge a feature branch. Okay, so let's run this. Okay, it says automatic merging example.txt, conflict content, merge conflict example.txt, automatic merge fail, fix conflict, then commit the result. Okay, so what happens basically, it giving me a message. It should open a file. I don't know why it not open a file. It should open a file, and I should get this message in the file. If I do status. Okay, so it's basically says both modified example.txt. So it's giving me that there is a conflict. Okay, so conflict is basically something that we need to make sure that now if you open the file vi example.txt, you will get this message. You have to open the file. I mean, what Git is telling you? Git is telling you there is a conflict. Is Git is resolving your conflict? No. Git will never resolve your conflict because Git is not sure which part of the code you would like to go for. Git whether this code you want to go with this with your project or this code you want to go with your project. Git doesn't know. It's your decision. But what Git will tell, there is a conflict. There is a conflict. What you need to do, you have to open the file and fix it. You have to open this file and fix it. What it will just open this file and says in this line there is a problem. If you see this, if you read this file, you can see here. It is telling you the location where is a conflict. It tells you this is a change from main branch, this is a change from the feature branch. This is the line which has a conflict. It is telling you exactly the same line, isn't it? It is telling you like this line and this line has a conflict. It start head and this is the feature branch. Now it is your decision whether you want to keep this one, you want to keep this one, or you want to delete both of the thing and keep something else. It is your decision. Git is not going to tell you how to code. You should know how to code, what to put what should be the content of your file. It's your decision. But Git will tell you where is the conflict. It will just point you. So now as a human or a project lead or a developer, what I will do, I'll say, okay, fine, let me do one thing. Let me remove all these things. I will go with this code. I'll say, this is my new line code. I will go with this and I will save this content. Okay. And again, if I do git status, you will say modify. What is the thing? Next thing we have to do? Git add and git commit. Git add. Okay. I'll say example.txt and git commit. -m. I'll say fix conflict. Alright, now if I do git status, my working tree is clean. If I do git log, you will see the same thing. There's a new commit. This is the new commit ID that got created, and it is pointing to just like a three-way merge only. It is pointing to both of them. Alright, so this is how Git resolve the conflict. I mean, Git actually not resolve the conflict. Git will tell you there is a conflict, and it is our responsibility to fix the conflict, because with what modification I want to move ahead, it's our decision, because it's our product. Okay, Git will just help you. Yes, there is a conflict. This file, this particular line, there are two different changes. What you want to go with it? You want to keep the feature A change, you want to keep the master change, you want to keep feature B change, whatever it's your, or you want to put something else. It is your decision. Who is this guy? So this guy is Linus. Yeah. So actually, he created Linux kernel. Okay. I mean, he is kind of a Bill Gates. Okay. But Bill Gates is a big shot, big name, big fame, big money. But this guy is a different philosophy. He loves open source. Okay. And these folks were using for development of, you know, how the philosophy of Linux kernel, you can also contribute to the Linux. It's open source. You can write something and you can contribute to the community. And if that is good, it will be added into the Linux kernel feature. Okay, they were working using a version control system known as Bitbucket. Okay, this Bitbucket they were using, and Bitbucket realized that these folks are using my VCS system and they are not paying a single rupee, single penny. So what they did, they put a licensing cost here. They said, okay, if you have to use, you have to pay for license. Okay. And this guy who made Linux kernel and made it open source free, he didn't like this. He said, no, I don't like this licensing culture and all. So what he did, okay, says, okay, fine, let me do one thing. I will create my own version control system. And he created Git, that is what we are using right now. Okay, this is created by this guy. And this becomes popular in no time. I mean, it's one of the best version control system. But why I'm telling you all this thing? Because there is a link between Git and Linux. Right? So we'll start from here, from this guy. What happens, how it is, why Git is different from all these version control system, why Git is better, not different, it's better also from all the different version control system. What is the reason for that? We'll try to understand that one. Okay.
Just a quick info, guys. Intellipaat, in collaboration with Microsoft, offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor-led sessions along with self-paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI/CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies, real-time labs powered by AWS simulating production level environment, 15 plus in-demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course without a doubt can set your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.
Alright, so first we are going to discuss about connecting your local repository to the GitHub. That is important. Once we cover that one, we'll discuss about the Git repository some internals of Git and some commands and some practices that we can follow for with Git. So we'll start with the connection of Git with GitHub. That is what we are going to do it. Okay, so if you don't have GitHub account, what you can do, you can just log into github.com. And once you log into github.com, there are a couple of options here. Okay, say this one is sign in and this one is sign up. If you have already account, you have to do sign in. If you want to create a new account, you have to sign up. Okay, this is for new account. If you want to create a new account, you have to sign up and you have to provide your some user ID and password. Then we can go ahead and discuss about this, how to connect it. So if you have GitHub account, please sign in. If you don't have account, you can create a new account. It will take hardly 5 minutes. Okay, so you can create, if you click on sign up, it will ask your email ID and username, continue, and you have to go and confirm your email, and after that your account will be get created. Once your account is created, you can again come back to this page and sign in. Okay, so let me sign in, just give me a second. Okay, so once you sign in, your account will be like this. Okay, you will see something like this. Now here we are going to create a new repository. Okay, so whatever action we are doing right now, we are basically creating everything on internet. This is my local machine. Okay, let me do it like this. We are going to create a repository. Okay, we are going to create a repository. Where we are going to create a repository? We are going to create a repository at GitHub. Okay, we are creating a repository at GitHub. Later what we will do, we will connect with our computer. Here we have local repository. Okay, this repository, that's a local repository. Okay, here that is nothing but our Git Bash. Okay, we will connect this repository with the repository available at the GitHub over internet. Okay, so first of all, what we have to do, we have to create this repository, this one, the GitHub repository. Okay, for that, what is required? GitHub account. Okay, that you have created, that is sign up. If you have not already account, you have to do sign up. Okay, if you have already an account, you need to do sign in. That's it. Once your account is there, the second thing what you have to do, you have to create Git repo. Okay, that is what we are going to see. How to create a GitHub repo? There are many ways we can create GitHub repo. Here you can see this is something known as new. You can click here new, it will create a GitHub repo. Okay, otherwise even if you click on your profile picture here, okay, there is a profile picture here. Here also you can click on your repository. Okay, this your repository. If you click on your repository also, a page will get opened. Here also you will get an option of new. Okay, the same thing, either you can click new there, or here you will land to the same page and you will create the repository. So you will create a new. Here you need to give a repository name in this page, or else let me explain it here. It's very simple. I mean, everybody can do it here. You can just type some name here, name of the repository, some description of the repository. Okay, your repository could be either public. Public means anyone over the internet can see your repository. Okay, you cannot modify it, but can see your repository. Private, on the other hand, it's your repository that only you can see. No one else can see this repository. What is the content, what you have written, it's nothing visible. No one able to see it. So depending upon the use case, most of the time we create private repository because that's our project specific content and all, right? We don't make it public. But anything that you want to share, just like I am sharing a lot of content with you folks, right? So all my directories are public. That is why you are able to see it. If it is not public, you won't able to see it. Okay, I've shared my Git commands repository, some other repository, Linux repository. So all you are able to see it because that those repositories are public repositories. Okay, once you are done with that, there is an option called add readme. Okay, if you want to create add readme, you can create add readme directly here, or later also you can create it. That's not a problem. Git ignore and all, you can just leave the option blank. Okay, I mean default, just leave it. License and all, just leave it. And after that, you need to click on create repository. Okay, so this is very simple. Say for example, I'm going to create repository today in Jan 2025. Okay, this repository name I can give whatever I want. I'll say this is a demo repository. All right, I have chosen an option public. Okay, all right, so after that, once everything is done, you can just click on create repository. Okay, so once you click on create repository, you'll get this page. Once you have here, what we can do, you can copy these things, whatever mentioned here, just copy this because this is useful. Okay, and you can mention this content here. So here you can say, it says echo create this like as a readme, initialize git init, git add readme command. Okay, and git commit, that we know, git branch, make it as a main, and after that this is the command, like git remote add origin, and some URL is there. Okay, and after that it says git push -u origin main. All right, what is the meaning of all these things? Now if you go ahead and read it again here, you can say to create a new repository on command line, this is the option. Okay, your repository, your repository is basically the path of your repository is this. Okay, you have created repository named 10th January 2025, and if you see, this is your path, github.com/your username /your repository name, right? This is actually the path of your repository, the URL of your repository. Okay, what is the URL? https github.com username /repository name. Okay, and the same thing, it says git remote add. So actually, let's go to first git bash here. Okay, over the git bash here, you can see that we have just created a repository, right? This is a empty repository. We have not even initialized the repository. It's just a empty repository. So what we can do here is we can initialize it here. Okay. So first let's initialize the repository and also initialize all these commands. So what we will do here, we'll say, because we'll say git config user.name, so we'll paste the user. Okay, then we can paste this email, git config user.email. We'll paste the email here, and then in the editor I'm giving notepad. Okay, so this is configured. Now I'll initialize the git init. So it says initialize the repository here. If I do ls-la, I can see .git folder got initialized here. Okay, so we have initialized a local repository. So here what we have done, this local repository, we have created a folder. Okay, that is 25th of Jan, name like 25th of Jan. After that we have initialized the git init. So this is something got initialized, right? The .git folder got initialized here, right? Now we have not yet connected it, but we are going to connect it. Everything is right now running on our desktop here. Okay, this folder, everything is on our desktop in our Git Bash. Now we want to connect this one. For that, what you need to do, you need to add the remote repository. This is remote for this local. How to add a remote repository? The command we have already taken it from the Git. Here you can see, if you want to add this remote repository, you have to do git remote add. The command is git remote add. You want to add a remote repository. Plus there is a name origin, and this is the path of your Git repository, right? This is the exactly path of your Git repository. So how to add it? The syntax is git remote add, okay, some local name, and then you have to give the path of the remote repository. Alright, so this is something we have to add it like this. If you want to add a remote repository so that your local and remote get connected, this is the syntax. But what is this origin? Origin is just the local name. Okay, the whole this name origin is basically equal to this. Can I give any other name? Yes, you can give any name. Like I can give my DevOps project. I can give any name here. Origin is just a word here. I mean, you can replace it with whatever you want. Okay, so we have created a remote repository. We have created the local repository. Now it's time to connect these two things. So let's first connect it. So we'll go here. Okay, this is our local repository. We have just initialized the repository. Nothing is here, right? So we can say echo, we'll say this is my readme file. Okay, and we will paste this content to readme. Okay, we'll add this, create a readme file. We have created it. The file got created. If any file got created, if you do git status, you will get this as an untracked file. What the next thing we do? We do git add and the file name. Okay, so we have added it. The same thing how we initialize the git repository, git init. How to initialize the repository? We have discussed this thing like multiple times, right? Git init will create a .git folder. Same thing is happening here also. Nothing new, right? So this is, we have created, let's go to Git Bash. So we have created a repository, we have added it. Now the time is to commit. So git commit -m, I'll say added readme. Okay, it's fine. If you do git status here, you will see that on branch master is everything is clean. But here, one thing, if you have observed, you have commit and everything, it says git branch -m as main. Okay, so what is this? If I let me clear the screen and let me show you. If I just do git branch here, so branch name is master here, but GitHub suggesting me to make the branch as main. Okay, so how to rename it? You can use -M. So you can just run a command git branch -M main. And if you run the git branch again, the master is renamed as a main. Why? Because in GitHub, early and later, later, like, nowadays they call master as a main. So it should match, otherwise it will like, branch to branch name should match, otherwise you will get some conflict. You won't be able to connect it. So it's better to change it to main if GitHub is suggesting. So this command is just to rename the master to main, creating a main branch. Okay, now it's time to add the remote repository, and you just no need to do anything special. You just need to run this command. What is the command? Git remote add, give some local name of the remote repository, and this is the remote path. So origin is basically representing this at my local machine. Okay, it's something like a small name, a user-friendly name of this URL. Okay, this is what I have created the local repository also, Leslie. I have run git init, right? First, this command I have run it, right? Git init. First, I added the user config and everything. I have created a file directory first, mkdir. Let me run history here so that you folks understand. So here, I have created this directory first. Okay, let me copy from here so that there should not be any confusion. What are the commands? These are the commands that I have run. First, I have created a directory, mkdir directory name. Okay, forget about this. This is just to change the prompt. Okay, that is fine. Then I cd to that. When we did ls, we didn't find any files or something. Then I configure my username, global email ID, global notepad. And then I initialize the empty git repository. Git init will initialize the repository. Then we have seen the .git folder here. Okay. After that, what we did, we created a file named as readme, and this file got created. Once this file got created, we have seen that git status is showing that it is untracked. Okay. When it is untracked, after that, what we did, we added to git readme, git add, and git commit. Right. This is what we have done many times, right? And then git status. The new thing that we have done here is this thing. Git branch, rename the branch master as a main. How to rename it? -M main. Your main branch will become main. Master will become main. That's it. Okay. Origin, we have not yet created the origin. Origin is equal to something like nickname. Origin is equal to this guy. What is this? This HTTPS. This is the path of my remote repository. Origin is a nickname of this. The whole thing will get replaced locally by this. Okay. So what is the syntax to add a repository? Git remote add local name and remote path. Local name can be origin. You can give my project repository, whatever you want. Okay. Let me first do it. You will be able to understand. Then add the local, we have not yet added the remote repository, by the way. We have just created the local repository and we have initialized it. We have created a readme file. We have done git add and git commit. Then we have renamed the name of the branch as a main. That's it. Apart from that, nothing new we have done. We have done these things 100 times almost. Many times, not even 100 times, but many times, right? The remote repository added here. We want to see the remote repository. In remote repository, we'll say git remote -v to display the remote repository in verbose mode. Means more detailed way. Type this one, there is no remote repository added here. Git remote v is giving me no remote repository added here. All right. So if let's go here. Where is my notepad? This. Okay. So there is no remote repository added. I want to add a remote repository, and the syntax is git remote add I want to keep the nickname as an origin. I'll say origin. If you want to keep the nickname as something, say for example, because you folks are getting confused with origin, let's say DevOps project. Okay, can I give this name? Let's try DevOps underscore project. And I want to add my remote repository. What is the path of my remote repository? The path of my remote repository is, let's go and open, is this is given by Git. This is the path. And here also you can see HTTPS GitHub discover DevOps username repository name.git. You can just copy this one, path of the remote repository. Okay, and put it here. So what is the syntax? Git remote add is just the command, local name and the report repository path. Path means if you want to access something over the internet, it will be HTTP, right? So that is what it is. So just copy this command and go back to your terminal of Git Bash, paste it here and run it. So it says git remote add -v. Now let's list down the command remote repository. Yes, we have the remote repository added. When we ran this command, this remote repository got added here. Okay, but there are two things here. When we run this command, we got these things. Okay, git remote add, and after that when we do remote -v, it give me yes DevOps underscore project as this for fetch, and this is for push. What is fetch and push we will see, don't worry about this. But if you see the URL https github.com username repository name.git, this is the same thing. So we have a remote repository added. Okay, so we have a remote repository added here. Okay, now when the remote repository added, we want to upload this file to the remote repository. So what happened in our diagram? This connection got established. Okay, this connection is established here. It's like this we have established. Let me put like this. Okay, this connection got established. We have this connectivity. Now I have a file here. Okay, I have a file that is available at remote local repository with the name readme. Okay, the readme file is here. I want to upload this file from here to remote repository. What I want to do? File is at my local computer right now. I want to upload this file to this. For that, Git says if you want to upload anything from local to your remote to here, like if you want to upload anything from here to here, the command that you have to run is git push. You have to push the changes, and git push will upload file from source to destination. I mean local to remote repository. Okay, and syntax for git push is just git push. If you want to see what is the push, if you read our document here that we have downloaded here, what is push says? Push line number 97. Update remote reference along with associated object. Update remote references along with. It means that it will make sure that your local and remote should get updated with the local. Okay, so what we will do, we will run git push command. How to run git push? Even the syntax is also given here. It says git push -u means upload, origin, and what is origin? This is source. What is definition? Main is basically you want to upload in the remote repository of main branch. Okay, so if you copy this command git push -u origin and paste it here. Oh, origin is not there, right? We have what is the name we have given? We have changed the origin name, right? What is the name? Discover project something, right? No. Origin is equal. We have not taken the origin name, right? We have taken DevOps underscore project. So it's uploaded the file. Okay, it did something. It uploaded the file. It says counting object blah 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 new branch. Now if I go here, okay, if I go to my branch here, and if I click on 10th June, you'll see that this repository created and the readme file is also, this is my readme file. This is my readme file and this is the content, right? This is the repository. Okay, so those two files are in sync. Let me repeat this process one more time, then you'll able to understand. We have this local repository. If I do git status, I am good. Your branch is up to date. Main, nothing to commit. Working tree is clean. Okay, everything looks okay. So now what we will do, we'll create some more files. We'll say echo. I'll say this is my second file. Okay, and I'll create this file. I'll say my code.txt. Okay, the file is here. Yes, the file is here. If I do git status, I'll say that it is untracked. Okay, so what we will do, we will do git add my code.txt. Okay, git commit -m will say added a new code file. All right, it's got committed. Now if I go back to my remote repository, this file is not available here. So what we need to do again, git push. I will say git push Let's see what happens here. If I go here and kind of refresh this, can I see that my code.txt is available now? And if I click here, this is my second file. This is what we have mentioned in the echo. Okay. And if I go back again here, the commit message, can you see that? Added new code file, the commit message also. When it got added just now it got added, almost 1 minute back. Okay. Now let me do it one more time. Let me create a couple of files here. I'll say, okay, I am creating a file like, there is a command in Linux is called man. Okay, and if you do ls, it will display man is, this is not a Linux symbol, sorry. Say for example, let me put some content, some big file. How to create a big file? Let's go to our internet. And what I'll do, I'll say Python program to add number. I'll get a Python program to add two numbers. Okay, this is, I think, a Python program. I'll copy this Python program. It got copied. Okay, I'll go and create this file here. I'll say vi. Okay, I'll go to vi and I'll say my program .py. Okay, and I'll put the content here and I'll save the content. File is here. Yes, file is here, my program.py. If I cat that file, my program.py, yes, I can see the content. I need to do git add my program.py, git commit -m. I'll say added a Python program. Right? All right, good. I have three files here: readme, my code, my program. If I go back to GitHub, I have only two files. Even if I refresh the page, I have only two files: readme and my code, because we have not pushed the content so far. So what we'll do? We'll do git push. So it got pushed. Now if you go here and see the content, let's go here and refresh it. Can you see that my program py is here? If you want to read the content, just click it. Yes, this is the same program, right? So we have git push is like, once you add the file, you have to do git push. Okay, you have to do git push here. Okay, git push will push your content. Now we have 3 files here. Okay, 1, 2, and 3. These 3 files we have pushed programs and everything. Everything is also here. Okay, everything, all the 3 files are also here, because what we have done is basically we have pushed all these files like this: file number 1, file number 2, and the file number readme file, that is the first file that we have pushed, right? So all the 3 files is here. When these 3 files are like, when the content of this file and this report repository and local repository are exactly same, then how we can verify that they are same or not? In that case, the command is basically, if you want to sync, you want just to check, you can run a command git fetch here. If you go here and just run a command git fetch, when you run a command git fetch and the output is blank, it means that you are in sync. Now let me show you one more thing. We are in sync. What I will do, I will create a file here at the remote repository. How to create a file here? It's very simple. You can click on add file here. Okay, this is your username, this is your repository, this is where you need to click add a file. You have to be on your repository root and click on add file. Okay, click add file. You want to upload a file, you want to create a file. I'll say I want to create a file. You can say, let's take any other Python program. I will add something else. I'll come to W3 school. And let's say while Python while loop, something like that. And I want to copy this program. And I'll say paste. Okay, this is done. Name of the file you need to give, and say while loop dot py. Okay, I've created a program while loop dot py. And what next? Once you create anything in Git, you need to add it. The addition is already going on. Here you need to commit it also. Okay, the same thing we are committing. You need to commit these changes. Yes, I want these changes. So what you have to do? You have to just click commit here and give some commit message. If you want to give some message here, that you can do. You can say added while Python program. Okay, and commit the changes. So you can see my Python program, my while loop program got added here. This guy has 4 files, right? 1, 2, 3, 4, and this guy has only 3 files. ls. Yes. Now if you run git fetch, it will tell you some difference. Okay, there is a file that is this in the main branch, and you are not in sync. If you are getting this kind of output, it means that you are not in sync with this repository. Now you want to download this file. Okay, for that the command is git. Okay, so the command is git pull. You have to run git pull command. Okay, so git push from here to here is git push, and from here to here it's git pull. You're pulling the changes. Okay, so let me show you. Go here and run git pull. It says something. If we do ls, you can see my while loop program is here. If we cat it, yes, it's here. All right, so this all is fine. It's okay. We are getting everything. But say for example, somebody made some changes over the program. Okay, if someone made some changes over the program, like if you go to the while.py program or here, I will edit this file. How to edit it, how I reach here, let me show you. First, you have to go to your repository. Okay, select the file, whatever the file you want to modify. Say for example, I want to modify this program and I want to modify, I modify directly on GitHub this program. So what we need to do, click on that. Okay, if you click here, you can see there is a pencil icon here, that is an edit icon. Okay, this pencil icon. So what you need to do, click pencil here, edit this file. This file is now open in edit mode. Now you can make some changes. Let me put some changes, more changes here. I will say what we have copied. Let me copy some Python arrays concept. I'll copy this, paste it here. I'll say commit changes and I'll say modify Python program. Commit the changes. Changes got stored. Okay, now your file has committed. If you open while one, you'll see there are some more characters here. But if you open your Git Bash, if you do ls, and if you open Git cat while, you will see that it doesn't have those lines added, right? Then again, we'll do git fetch. If you want to make sure that Avion is sync or not, you just run git fetch. Git fetch will give you some output like this. You should understand there is some mismatch, and if you read it, it will also tell you which file. So what we will do, we will do again git pull. Okay, it added something on while loop. Some plus means addition, some lines got added. If I do cat of while loop, I can see these characters are here. And moreover, if I do git log, I can say that somebody modified Python program, add new program, all those things. I can see all those commit messages and everything. All right. Now, one more thing. So what are the things that we have learned so far? Let me quickly recap. First of all, when you create a remote repository, there are two things. Okay, your local repository is one repository, remote repository is another repository. With local repository, you can attach your remote repository and you make those things as sync, or you can whatever you. But the point here is, try to understand the logic here. Why we need all those things? What is the use case of all these things? You are working on your project. Remember, we started with this concept, right? Business idea, gather and people will work. You may not be the only coder, or you may not be the only developer in your team, right? There are some other folks as well. And when we started the concept of VCS, we started how you are going to share your code, right? This is the problem. Difficult to track, access issue, right? Access issue. How you are going to here? I said you have to give your laptop's user ID and password. Now this you won't have to do. This time this is your laptop, right? What we have done is basically on your laptop, you will create a local repository. On your laptop, you will create a local repository. Like my project or something, like using what? Maybe Git Bash. Okay, you will use Git Bash. So you will create a local repository. But someone in your team also, has a laptop. He will also create a local repository using Git Bash. Okay. someone else in your team, like, sitting in different region of the world, maybe, say, for example, this is somewhere in Australia, this is somewhere in India, this is somewhere in US. Like that, people are like, we are following follow the sun model, right? I mean, we are 24/7, something is going on. So how these people can contribute to the same project? That's the main problem. If I am storing everything here on my laptop, you are storing everything on your laptop, and I am storing everything on here, either I can share this file over an email to you. That is not possible. Sometimes it's not a feasible solution, right? Email and all. It's sometimes the size of the file is big. Sometimes I forgot to send an email. So what is the best practice? The best practice says, okay, fine. Let's create even the remote repository, something like GitHub. Okay. This repository, what everyone will do, they will connect to this GitHub repository. Okay. They will connect their central local repository to this. This guy will also connect this repository. Okay. To this guy will also connect like this: git remote add, git remote add, git remote add. Now whatever I am doing, like say for example I started, say for example this guy is from Australia, like he will like woke up early, right? Like ahead of us, and so he will start working. So what he will do, he'll start from 9 a.m. He will start making some changes and everything on his local desktop. Okay, whatever you have studied so far, git add, git commit, git branch, git merging, everything he will do locally first. And once he feel that yeah, this change now I can share with my friends or my colleagues, he will do git push. So now the changes are available here at the end of his day, maybe 5 p.m. or whatever the time. Then this guy will came over the shift or his timing, he will start his day. He will say, let me see what this guy has done. I will start from here. So what he will do git the changes. He will make the things here. Okay. Now after that, when he will make the changes, everything, he will do the git push again. This guy will start the day with git pull, and then he will make the changes. He will again do a git push. So there will be always some new. If I'm starting my day and I want to know that whether I'm synced with this guy or not, I will just simply run git fetch command. And if fetch is showing me some output, it means that I'm not in sync. So first download everything, git pull, and start working on it. So whatever here we are not our code. First of all, the problem here. I mean the problem that we have identified. Right? What were the problems? System failure, access issue, difficult to track the changes. All right. So everything is solved here, right? Even somebody's system failed. Okay, somebody's system failed, but no worries. You can turn on your laptop again, fix everything. Codes are here. Once you are done back, add the repository, everything. Even fail means crashes. He will get a new laptop. He will configure everything here. He will install Git Bash here, add Git remote and Git pull. All the codes are here, right? So system failure is solved. Any access issue? There is no access issue. I mean, same repository, everyone is accessing from their laptop. And who is doing what? That is also visible in Git log. This guy is Mr. M, Mr. N, and Mr. O. Okay, whatever these guys are doing here, everything is getting recorded in the Git log because they have to configure it. Okay, we'll discuss some of the concept of Git. There are a couple of important things, like first was basically we called reset command. Okay, if you want to reset anything. So what is a reset? We'll see Git reset. What is the literal meaning of reset? You are reverting back, right? I mean, you're going back, you're resetting it, right? So there are a couple of kind of reset available in Git. Okay. So when you have to reset, like, first of all, okay, I need to tell you also this, right? This guy concept. Okay, so what happens, we started the discussion of this. So we discuss about like this guy has created a Git. Okay, if you have ever seen the Linux operating system, okay, the operating system here, okay, the Linux operating system, or file system, you will see like, if you see the image, this is the Linux file system, right? This is the Linux file system, something like this, right? So what we call this guy, I mean, this file system, we call it as an inverted tree structure. What is this? Inverted tree structure. It's an inverted tree structure. What is the meaning of inverted tree structure? It looks like a tree, but it's inverted, right? I mean, it's an inverted, right? Its root is up, and then we have branches and these things, like. So in Linux file system, there are two things important, okay? There are a couple of things. First, we have the concept of directory. Okay, directory is something like folder. Okay, a directory can contain another directory. Directory can also contain a file. Okay, and this directory may contain a directory, and this can contain also a file. Something like this. If you keep drawing this one, this directory may have another directory. Okay, this directory may have file, directory, like this. So this structure basically becomes an inverted tree structure. The main directory we call it the root directory. So from where the things get started, and this structure basically forms as a inverted tree structure, right? Now, similar kind of a concept available. I mean, if you look at the Git here, okay, in Git we have three important things. Okay, first we call them as a Git objects. Okay, if you see here, it will be Git objects. There are a couple of types of Git object. First we call tree in tree. Second we call blob. And third object we call commit. Tree is something like directory. Concept is directory. What is the meaning that tree can contain another tree or a file? And file is in Linux, in Git we call blob. It is similar to like file. What file contains? The content, right? Commit. What is commit? Commit is an object that contains information about the author and the message. When we commit it, this guy contains information about the author and the message. Remember, when we commit anything, we give the author name, I mean, who did it and what is the message. That information stores about in the commit. Okay, but if you have seen, like, any commit is like, if I go here and see the git log here. Okay, this is a commit ID. This is a huge number, right? This is I think 48-bit if I'm not wrong. So why the number get generated? How this number is getting generated? There is another concept known as hashing. Okay, what is hashing? Hashing is a very simple concept. If you go here and do something like, this is MD5 hash generator. So what happens in hashing, basically, if you write any text, say for example, I'll write, we are learning Git. Okay, we are learning Git. This is a simple text, right? If you generate a hash out of it, it generate this random character. So what happens basically, this simple text get converted into this hash character. What is the length of this character? That depends upon what type of algorithm you are using. There are so many algorithms. There are, I think, 10 to 15 algorithms. Hash SHA-1, hash SHA-2, MD5, MD6, like there are so many algorithms. How many bit of character it will generate, it depends upon this one. Git uses SHA-1 hash internally. Okay, Git, so I think it's 48 bit character if I'm not wrong. You have to read the document here. But the point here is it is get converted into hash. This is what hashing. Plain text get converted into hash. When you type your password on any website, the password doesn't get stored in the same text. It get converted into hash so that nobody can make sense out of this number. We mentioned we are learning it. This is a plain text. Anybody can read it. But what is this? Nobody will able to understand, right? What is the information you are passing? That concept is known as hashing. What Git does, it also do hashing, okay? And it uses SHA-1 hash. So moment you commit everything, it convert into an hash. Okay, for Git will understand the hash because it will convert everything to a hash. Now the question comes here, like why I am telling you all this and what is the reason for that, right? It is something, if you understood this is perfectly fine. Even if you don't understand, I mean, if you didn't get it, all these concepts, that is also perfectly fine because we are not going to use in our daily life. These are some internals of Git that may help you in interview if somebody asks, or it's for your own knowledge purpose. How internally Git works, that is what I'm trying to tell you. If you understand, that is fine. If you are not getting it, is perfectly fine. It's leave it. It's not that much important concept. It is important based upon your interest. Okay. So what you need to do is basically, if you go here, okay, and say for example, I want to understand about this, okay, this one. So what I can do here is I can say, okay, there's a command known as git cat -file-t and paste it. So if you read this, what command we have run, git cat file and this hash, it says that it is a tree. You can see it is a tree and it has a parent. This, what is this parent? This parent is this guy 78 something, this one. Okay, and it has a this guy is the author. Okay, and this guy has commit message and all those things is giving you the information and the message and everything. Similarly, if you read the parent, say for example, if you do ls here, you can see we have some files, my program files and all these things. If you do git log -1 line, it will just display the message here, all the commits here. Now let's read all these commits. If I do git cat -file-p, no need to worry about it. If you are getting it, is perfectly fine. I'm mentioning it again and again. So it says that this guy is a tree. What is this? This is a tree. This particular commit has a tree inside it. If you cat that tree, let's cat that tree here. Okay, if you git cat -file-p tree. So this tree has couple of blocks. Are you getting it? This diagram. Tree can contain, is like a directory. Tree can contain tree. Tree can also contain block. Okay, tree can another tree can contain another tree. This tree can contain another tree. This tree can contain another blob, like that. This can be a blob, and this can also be a tree. Are we not drawing something like this? Same inverted tree structure, like a Linux file system. If you read this one, if you just cat this one, git cat -file-p and read it. Can you see that this is showing the content of the file? This is our readme file, and this is blob. What a file contains? File contains the content. If you create a file, you put some content there, right? So all these are blob. So what is the point I am trying to make it? Because why Git is different? Because Git is a mini operating system within it. Git works like an operating system, but that operating system has it's not a full operating system like Linux or something, but the concept is same. So that is how Git is basically tracking your file and everything. Git uses these numbers to track your file and where all this information gets stored. If you clear your thing. If you ls and if you just ls-la or ls-a, we'll say .git folder. Now if you go to cd to .git, okay, and if you see here, you'll see a lot of here you can go to git object. This is what I'm trying to tell you. cd to git objects. If you do ls here, you can see 0, 2, 0, all those things. If you can go to any of directory 0, 2. If you see here, okay, sorry, ls. Can you see that 80? This is the commit ID. Okay. If you do ls-l here, you will get this is a file, and you want to, if you want to read this, what is this? You can just do git cat -file -p and some initial of it. Not a valid object, yeah, because we forgot to paste 02 here, because 02 is a parent. So you can see this is a tree. Okay, this object is a tree and this has a parent. So you can get all those relate. You can get is how internally tracking everything. Making some sense. I mean, if it is not making sense, it's perfectly fine. I tried. I was trying to help you like how internally Git works. This is sometimes important to keep you, perform outstand you in interview or something. You can explain this concept like how Git internally works. Okay. Now let's discuss about something known as Git Reset. Okay, so just remember, like if somebody asks like what are Git object, tree, blob, and commit are the Git object, how they are related. Tree is something like a directory that can contain another tree or a blob. Blob is something like a file that can contain the content of your, like if you're creating a file touch. So you are creating a file touch at operating system. How Git is going to track it? Using creating a blob. Git will treat it as a blob. Tree is like a directory that can contain another tree or something like. Commit is like what is your commit message and what is that hash, that is here. And there is another concept that is known as head. Head will tell you where you are, what is your current location. Head will tell you your location. If you go here and run here like a command, git log, you will see that head is here. It means that you are right now at this commit. Okay. If you make any other commit, say for example, I'll create a file touch test123. I'm creating a file. What I'll do git add test123. And what else I can do? Where I am right now? Okay, I'm at 02, that is why. So let me go here. cd dot one directory back dot 2. Yes, I'm here. So let me create here. So we'll create touch test123, git add test123, git commit -m. I'll say added test file. All right, now if I go and see git log, can you see that my position got changed? My head is right now on this commit. Earlier I was at this commit. Head is right now here. So it will always tell me where I am. Okay, head is going to tell my current location. All right, first let me discuss about the important concept. Here is a reset. Okay, so there is something known as Git Reset. Okay, Git Reset is a little dangerous command. Okay, so you have to be little careful. Reset is basically what it is going to do is, it can be used to reset the head position. Okay, it will reset your head position where you want to put the reset. So there are couple of types of Git Reset. First one is known as soft. Okay, second one is known as hard, and the third one is known as mixed. So couple of types of reset. Let's try to understand with an example directly, because you will understand very clearly with an example rather than if I'm explaining you the concept. Okay, so we'll go here and we'll create a repository first. We'll say for example mkdir Let me do cd first, so that cd dot dot where I am right now. I'm at dot. Let's create a repository here. We'll say mkdir git reset demo. We'll cd to that. Okay, and then we'll do git init. Initialize the repository. All right. We'll create a file. Okay. Okay, this file got created here, example.txt. If you, what we'll do, we'll add here git add. Okay, and git commit. We'll say initial commit. Paste it. Okay, so if I see here, if I can see here, if I do git log, I can see that yes, this is my head position. I am right now here, and this is a change made by this guy at this particular time. Message is this. Everything looks okay. Now let me add some more content to this file. I can add echo some more content. File got modified. Again, what we can do git add and git commit, right? I'll say git add and git commit. So I'll say added some more content here, and it's there. Now if I go and see the git log, I can say I have two commit. My head is right now at this commit, and this was my previous commit. We have added one more content. This was the initial commit. This everything is fine. Okay. Now git reset has couple of modes. Okay. So if you add this thing, say for example, anything, if you want to reset your head position, and if you are doing with the help of soft, say for example, here, if I run a command git reset, okay, hyphen soft, okay, and head tilde 1. What is this head tilde 1? I mean, I'm trying to move head position just one position back. If you run this command, okay, git reset hyphen soft head tilde 1, and if you run a git status command, okay, status, it will, where I am right now, it is giving me an option that file got modified. Remember, I mean, it is giving me an option. I'm going to staging area. I mean, I'm going to one position back. If I do git log here, you can see my head position is right now here, A27. Earlier my head position was here. I am here at this position. Now git is with hyphen soft option. Git is giving me one more chance to think whether you want to go with modification stage or you want to revert it back. If you want to go with that, what you need to do, again you need to do git add and git commit. You will again reach to this particular commit. But if you have decided no, I want to revert back, so you can unchange those modified thing and you can again revert back. Okay, so soft is helpful if you want to edit the previous commit. Okay, if you have make anything wrong in the commit and you want to edit the previous commit, so what happens here, if I do ls here, I can see cat example.txt. I have some new content. Now I want to modify this thing. I can say, okay, let me vi this file and say example.txt. I'll say I don't want to add some new content. I want to add some new content plus more content. I want to add this thing. So soft is giving me that option. If I want to go back, save it, and I'll do what? Git add example.txt and git commit -m. I'll say final modification. All right, final modification of the file. All right, so this is something I can do it. All right, are you getting it? Now if I do git log, I got another commit, and this is final modification, and the cat example.txt is this, right? So soft is giving me n-1. I mean, it will give you one more chance to modify the things. All right, now let me show you one more thing. If I am here right now, okay, if I do git mixed, okay, I mean, let me add some more content to git. I'll say echo, I'll say more content to example.txt, and I'll do git add, paste it here, and git commit. So it's got modified. Now if I do git reset, if I do add example.txt, it's there, more content. If I do git log, I can see I have new commit that is just for more content. If I do git reset hyphen mixed, okay, git reset hyphen mixed, and I'll say add -1, add -1. Okay, so if I do this, so it says now if I is this, so here you can see, if you run git status now, git status, it is telling me the file got modified. Okay, so mixed is basically is useful when you want to keep changes in your working directory but decided not to stage or commit them. Okay, I mean, it is just before the staging thing. Okay, it is just before the staging. I mean, it got modified. If you do cat example.txt, you will say that new content is not there. It is just like before the staging area. It is, your changes are there, but it is not yet staged. What you can do, you can again go do a git add and git commit, and you can save it. Okay, so what was the difference between soft and here? Soft is helpful if you want to edit the previous commit. It is like kind of you are at the same commit, but if you want to modify, that is what it is giving. Here it is going 1 - 1. I mean, staging area. It is something like, if I go and explain you with this diagram, soft is basically you are modifying here only. Mix is you are going one step back, staging area. Here you are here, and now if you want to go back, it is your wish. If you want to commit it and reset it, you can do it. Okay, so here you can see it is now, it's a modified area, and what you need to do, again you need to do git add and example.txt, and again you have to do git commit -m, and you need to give some message. I can say last change. All right, now if you do git status is clean, and if you do git log, you will able to see this one. The dangerous is git hard reset. Okay, it's very dangerous. What is right now, we are here, right? 29C4 is the last one. Now let me do a git hard reset, or okay, if I do git reset, hyphen hard add -1. Okay, this is the reset I am doing. If I do it like this, head is now this. Okay, head is right now CE45, CE something. If you do git log, you are here, CE, this is the git log, you are here. And even if you do git status, everything is clean. It will not give you a chance to rethink. It will directly move you back. If you are 100% sure I don't want any chance to rethink, I will go back. What is the difference here? The difference here is git soft will allow here, it is something like, git soft is basically moving kind of you here. Again, you are staging it and coming back. Git mix is moving you in the staging area, and then you have to just commit it and you will be here. But git hard is just pushing back. It is not giving you any second thought that if you want to consider your changes or not. So whenever you are running git reset, by default is mixed, without any option is mixed. But if you are doing git reset -hard, make sure that git will not allow, everything is vanished. Whatever you have done is gone. Okay, but reset and soft will also give you one more chance to think. Okay, so make sure that what you are running. Similarly, there is something known as Git Restore. Let me also give it to you. Let me go one directory back. Yes, okay. So what we'll do, I'll show you one more example of, we have understand reset. We are going to discuss a restore. Okay, this is, I'm creating a directory. I'm going into that. This thing we have done many times, creation directory initialization. So I'm going a little bit fast because we have done many times. This we are good. Now let me create a directory, example.txt. I'm creating a file. Hello git example.txt. What is the next thing? We have to do git add and git commit. We have added the file. We have committed. Okay. Now if I do git status, everything is okay. If I do git log, everything is okay. Right. Now let's make some more changes to here. If you make more changes here, we have added one more file. If I cat example.txt, that I have added a new line. Now, if I do git status here, okay, git status, it says the file got modified. If you want to go back, you can do git restore and the file. If you do git restore here, okay, it will revert back your changes. Let me show you. What is the next thing? Say for example, why we do restore? Say for example, I made these changes and I realized that, oh no, this change is not correct. Let me revert back. Otherwise, what I can do, if I'm okay that yes, these changes are okay, I can do git add and git commit. I'll commit these changes. If I want to revert back right now, which area I'm in, it is just modified area. I'm here. Okay, I'm in this area. And I decided, okay, this modification is not good. I want to go back. So what is the status? Well, how can I do this? We just need to run git restore and example.txt. If you run it and if you cat your example.txt, you'll see this hello git. That's the first line. Second line, the new line is disappear. It's not there. And if you run git status here, you'll see that working tree is clean. Okay, so you can restore, discard the changes. You can discard unstaged changes in the working directory. Okay, and say for example, you have added the file, okay, and you made it and you stage it. Say for example, here we have not even staged it, right? Let me show you. ls file is this. If I add one more content here, okay, add another line. Okay, if I do git cat example.txt, I can say I have added another line. If I do git status, it will say modified. Let me stage it. How to stage it? Git add. Okay, git add command, paste it here. Now if I do git status, I'll say it's the file is in staging area because it's giving me option to commit it. Now at this time I have decided no, I want to revert back. I don't want to commit, I want to go back. So what is the option? Here is the option given, git restore minus stage. So you have to run this command, git restore minus stage. You will go back to your staging area. Now if you run git status, you will say commit, you are again back to the staging area. From here, if you want to go back, again you need to do git restore and your file name. Okay, now if you do git status, everything is clean. The new line is also disappear. Okay, so from staging area, if you want to go back, just git restore. From if you have not staged it, you have just modified it and you want to revert back. So what you need to do? Git restore. From staging area, if you want to revert back, git restore hyphen staged. You have to type it. All right. And reset, you got it. If you want to go back to any of the previous commit, you can go to the git reset command. After commit, you have to do reset. When the file get committed, I just showed you reset, right? Soft, mixed and all. That is a reset. Okay. Container, and we found like what is the main purpose, like this is what happens in software or any IT industry or company, like somebody is writing a code. Okay, this is the code and that code we want to be running. Okay, if you take any example, this code sometimes becomes an application, an app, or any website or anything, like it is running, whether it's Facebook, whether it's Insta, whether it's Zomato, Swiggy, Zerodha, whatever it is at the end of the day, it's a program, a code that is running. When it is running, people like end user like you and me access it, okay, and company has some mechanism and they generate revenue out of it. This is what more or less happens with any software development. Point here is how we are going to run this code. There are a couple of ways we can run this code. First is like, we have this hardware where we'll have dedicated hardware. On this hardware, we have some amount of RAM and some amount of CPU, and we have operating system running on top of it. All right. Now, here there are, if I'm running an application on this particular setup, and my application is consuming 2 GB of a RAM and 2 CPU, my operating system is also consuming 2 GB of a RAM and 2 CPU. This setup, we said that it's not a good deployment, it's not a good architecture, because we are wasting our resources, right? We are over provisioned, right? We are paying for 10 GB and we are hardly utilizing 40% of it, right? So that's something, waste of money, waste of resource. So this is not a good architecture. What can be further done to improve? Like what could be the better way? Better way is like, on the same hardware, okay, and same operating system, instead of running one application, run multiple application, right? That is one of the better way, because here we are at least utilizing 80% of the resource, right? Out of 10 GB, we are utilizing 6 GB on application, 2 GB on for operating system. So almost 80% utilization. That is much better way of utilizing the resource. Yes, no doubt this is a better way of utilizing the resource, but there are some challenges with this. What are the challenges? Challenges of security and resource allocation, right? I mean, some application which is someone who belongs to the application A, someone who belongs to the application B, both will get operating system access from the application. Yes, these folks can now access each other application. Is it possible? Yes, it is possible, quite possible. And this is one of the challenge. Another challenge is, say for example, application A is kind of a malfunctioning, and it is consuming 8 GB of RAM and 8 CPU alone. What about other application? So there is no capping or restriction out of the box that we can put, like, one application can get this much of maximum RAM, this much of maximum CPU, this much of maximum disk space, this much of maximum network IO. There's no such capping, right? I mean, there is no control here. So this is another problem. So first the problem is of security, right? First is the problem is security. Okay. Second issue is basically is resource allocation. Okay. And the third issue is like application dependencies, like apps dependency. What do you mean by apps dependencies? Say for example, whatever is required to run application A, this is not required to run application B. That may cause another issue, right? So that could be an issue. I'm not saying 100%, but that could be also an issue. So if we want to utilize our application in much better way, we can see that. So this could be a challenge. Okay. So we try to utilize the hardware in much better way, more efficient way, but we encounter some other challenges that is not going to solve our purpose of better utilizing the hardware or allocation. I mean, fully utilizing the hardware, underlying hardware. Okay, well, then people started thinking, okay, let's do something else. And somewhere in 2007ish, 6, close to that era, people come with a solution of virtualization. Okay, this we called virtualization. In virtualization, what happened? In virtualization, we have same hardware. Okay, we have the hardware, we have the operating system. There is a tiny layer of another piece of software on top of this that we called hypervisor. Okay, this we called hypervisor. And applications are coming along with, like, when you want to run your application, the application is coming along with their operating system, app plus operating system, app plus operating system. These machines we call virtual machine, like an EC2 instance. It's a virtual machine. This is also a virtual machine, right? Application and operating system. But here is the important thing, like, you can say, then what about security and the resource allocation? Yes, security and resource allocation we can solve. This virtual machine will get only this portion of hardware. Means he will get dedicated portion of CPU, RAM, hard disk, everything. This folk will get dedicated portion of hardware, only this portion of hardware, and this for so on and so forth. But who is allocating dedicated portion? It is hypervisor who is allocating this machine, this portion of hardware, this machine, this portion of hardware, this machine, this portion of hardware. Okay. And one more thing, it is, if this portion of hardware is accessible to this application team, anyone coming to application A and can access this hardware, but he cannot access this portion of hardware. This is completely isolated. You can't go there. And who does all those things? It's hypervisor. Okay. And the most interesting thing is, this machine will assume that I am the only machine and this is the full hardware and I am getting the full hardware. They will assume like this. Okay, this is the total hardware and I am getting all the hardware. Similarly, this virtual machine will assume that, okay, I am the only virtual machine that is running and this is the full hardware and I am getting the full hardware. So on and so forth. They even don't know that other virtual machine is running. One EC2 doesn't know that another EC2 is running on the same hardware. They don't know. For them, it's an independent machine. I mean, if they want to talk to each other, they cannot talk like this. Okay, they need to talk to like over the network. They need to connect to the router, switches, network, and they can talk like this, like in two different machine. Okay, they cannot connect like internally. It's not possible. Okay, just like one hardware connect with another hardware. Okay, same way they will connect. All right, this is the concept of virtual machine. Now, this is the best way of deploying the application? I mean, it is not the best way, but it is little, I mean, I will say it's much better way of deploying the application as instead of like this, right? Because here we don't have any isolation mechanism. Here we have isolation mechanism. But what would be the challenges can I see here? I can see only few challenges here. First is like, we have now multiple operating system, right? Here, how many operating system we have? Only one operating system, right? Here, how many operating system? 1, 2, 3, 4 operating system. And if we increase the virtual machine, there will be operating system will increase. So in order to manage these many operating system, we need to hire more system admin. Okay. So we need to apply more patches, security patches, licenses, blah, 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 so many things. So my operational cost increase, like my operational cost is higher, right? That is the challenge that I can see with this particular architecture. Okay, okay. Now we after that we thought of, okay, fine, let's try to understand what actually we want to do, from where we started. We started from here, right? We have a code or application that we want to run somewhere. That's it. Now, for this, we took an analogy. We try to understand, okay, fine. Let me know if I want to run only Zoom on this my laptop. This is my system. This is my desktop, laptop, whatever you want to say. This is my system. Okay. Over this system, I want to run only Zoom. No other software. Zoom, everybody knows, like WebEx, we have Zoom software or any software for that. In order to run Zoom, do we need Teams running on this machine? Teams require? Do we need Teams to be running if we want to run Zoom? No, right? Do we need MS Office to be running if you want to run Zoom here? No, not at all. Do we need printer driver to be running on this machine if you want to run Zoom? No. Similarly, do we need any other software like Adobe or something? No, not at all. It's not required. So what actually required to run Zoom? In order to run Zoom on any machine, it requires Zoom, the exe file plus dependency, right? That's it. Whatever the, say for example, Zoom requires some Java version. Just imagine, I'm just hypothetically am I telling you? Then what is this? This is basically those binaries and libraries, those dependencies. Apart from that, nothing else is required to run zone, right? Similarly, if we come back here, this guy, what this guy want to run? This guy just want to run its app, its code. In order to run this code, what is required? Just if my whole sole aim is to just run this code, if I just want to run this code, what is required? Code plus dependency. Okay, and this is what is container. Container will give you, what is container? Container is equal to code plus dependency. Okay, nothing more than that, nothing less than that. Whatever is required, that only and only those things. Nothing, not a single software, not a single package more than this. I don't require printer driver, but in my laptop right now, the laptop you're seeing right now, it has so many package drivers and software that I never use. Almost 60% of package I never use in my machine, right? So it happens. There's so many things. When you start your machine, a lot of things will start, and we don't use all those things, but it is running. Okay, that makes my machine bulky, that makes my machine slow, that makes my, that they consume my RAM, they consume my CPU, they consume my disk space, they consume my network, everything they consume, but they are running. In container, this is not the case. You will only run that is required. That will make your machine light, that will make your machine more efficient utilization of hardware, right? So this is why if we have this concept, instead of running 3 virtual machine on the same 10 GB of a RAM and 10 CPU, because this virtual machine will consume more amount of CPU and RAM as compared to this container. Why? Because this contains the full operating system. The full operating system will contain n number of other software and packages that is not at all required to for this app, right? So those will consume more memory and CPU. So that is why we can run more container on the same piece of hardware as compared to virtual machine or as compared to this guy. So no doubt this is more efficient way, more better way of running the application, proper utilization of hardware. Now the question comes, okay, this concept looks good on paper, this concept looks good, but what about these 3 things? How you are going to solve this, right? How you are going to solve security, how you are going to solve other these 3 things. What about these? So this is what we are going to understand, how container offers security, how container offer resource allocation, how container offer apps dependency, everything. All right. We are going to understand this, how container offer security, how container offer resource allocation, and how container offer apps dependency. So in container, the architect, this is not actually the architecture. We will discuss architecture in detail in a minute. We have something known as hardware, we have operating system, and there is a run C. What is this run C? This is nothing but a container software. Like if you want to install Docker, we have to install Docker D. Okay, Docker D. What is Docker D? Let me explain you. Okay, so this is kind of an overview of container. Okay, now let's try to understand types of container. There are multiple types of container. The one that very famous is Docker. Okay, Docker is invented by a company known as Docker D. Okay, Docker Incorporation, sorry. Okay, Docker Inc. Docker, their container product name is also Docker, company name is also Docker. Okay, so don't get confused. Sometimes it's little confusing because company name is also Docker, product name is also Docker, but this is container. And 90% of the time, whenever we are saying Docker, we are talking about container. Okay, there are a few other types of container, like there is something known as cryo. Okay, there is something known as container D. All right, there is something known as Rocket. And there are few others, okay. But we will be focusing on Docker because that kind of captured almost 80 to 90% of market, and it's most widely. Docker is kind of a synonym, of container. The real product is container, okay. These are the types of container, but People say, whenever you say container, people say Docker. So it's like that much popular. I'm going to first install Docker. Let's first try to understand how to install Docker. Okay. Docker installation. So we can install Docker many ways. Okay, we can install Docker on Linux. Okay, we can install Docker on Windows. We can install Docker on Mac. That is perfectly fine. Okay, and the document that we are going to follow is docs.docker.com. Okay, document is docs.docker.com. This is the place that we should start. Okay, make a bookmark this page. This is the place where we'll come every now and then for anything and everything in Docker. And here we'll have like getting started. This is like from what is Docker. Okay, what is Docker? You can just have start reading it. Introduction. Okay, some Docker concept. All these things are important. I mean, you can just go slowly. Okay, just go slowly with this with these documentation. Okay, and what is Docker? I mean, this is really important. They have a YouTube channel also. You can follow that channel. Okay, follow the official channel. Please don't follow anyone's channel like some, because nowadays everyone is creating a lot of stuff, content, but what is the authenticity of those content? Nobody knows. Okay, so it's better always to follow some official channel. Okay, so this is, they will explain you about all these concepts, and this is what we are going to discuss in a minute. And they will also tell you how to install step-by-step document and what is image registry. This is what we are going to cover in a minute. But you can also follow along the official document. This will give you some more confidence, some more content, right? Well-written content. And another thing is you can also try something known as Docker desktop. Okay, and there is something known as a website. Okay, play hyphen with hyphen Docker. This is a website that you can use to run Docker. Okay, what is how to log in here? Play hyphen with Docker. Without, if you don't want to install Docker and you want to learn Docker, this website is going to help you. Okay, you can run all the Docker command here. But how to log in here, I will tell you in a minute. Okay, there is a version of Docker that you can install that is known as Docker desktop. Okay, where is that? Yeah, this one. So you can see here, this is Docker desktop. Okay, that you can install on your machine. If you're just like Git Bash, it's good for Windows. Okay, you can install Docker desktop on your machine and install Docker desktop Mac, Windows or Linux. You can install anywhere. This is good, but again, I mean, I generally don't install all these things, because if I keep installing all these things, there will be a lot of software, and I realize that it makes my machine, my desktop, little slow. Okay, but if you are learning, you can install it, because I prefer everything on Linux. Okay, there is a Linux machine, I'll do everything here. But for your practice purpose, for your day-to-day activity, you should go definitely install this. This is simple installation. You can just go here for Windows, you click here. It will give you step-by-step documentation to install Docker desktop on your Windows. Okay, Docker desktop for Windows. Okay, because you will miss some concept and you will focus only on installation. It's very simple, just like in exe file. You can see it's given step-by-step documentation. You can just install it, and after that you can install it like this. Even from the go to Windows CMD, and you can install like this also. That will install your Docker. And how to install Docker desktop? A startup is, you can go to desktop, and a Docker desktop will see here just like an icon, and you can just start accessing it. Okay, so now what we are going to do is I'm going to show you the more important, like more professional way of installing Docker, generally what we do in organization. So we'll say install Docker. So install Docker is this is the install Docker. What is the difference? That is a desktop version. That is more. This is a community edition. Okay, that we can install. And there is one more edition that is known as professional edition. That is for that Docker charges. Docker incorporation company will charge some money for that. But we are not going to pay for this. We will use a community edition, and community edition has all the feature. So here you can see. If you want, I can give it right now, but I generally don't give it because people get diverted. Yeah. So what I was telling, like, when what is the what is your operating system? Say, for example, Ubuntu, Debian, Red Hat, Fedora, CentOS, whatever this, you can select any of your operating system version from here and you can install. Say, for example, for Ubuntu, if you click on Ubuntu, it will take you like how to install Ubuntu. Okay. These are the steps. Okay. Run the following command to uninstall config packages. If you have any config packages, it will uninstall any previous version of Docker from your machine. That is your choice. If you want to run it, you can just copy this command. I'll just prepare a doc. Okay. Docker installation steps. Okay. So what we'll do, we'll say this is step number 1. Just run it. And the second step is like installation method. It says like setting up the Docker repository. First, you need to add the this is basically what we can say. This is step number 0, right? This is prerequisite. Okay. What is the step number 1? Step number 1 is install setup Docker apt repository. You just click here, everything will get copied. No need to select and copy. Just click here, it will get copied. Paste it here. So what it is doing, it is updating, it is adding some certificate, it is adding the keys, and it is adding the all those things, and it is basically here it is adding the repository, the Docker repository. Okay. So that repository will get connected. Once it will get connected, okay, next thing is install. This is the main command to install Docker. This is going to be step number 3 for us, right? 2 for us. This is going to be step number 2 to actually install the Docker package. And the command is like, you can just click here. You will see like this. Okay. This is the command to install Docker. This is more official way, more professional way of installing Docker. Okay. But if you want to install, if you want to learn, if you're learning Docker and you are doing it first time, you feel like this is very complex. What you can do here is on the same Ubuntu machine, you can just type Docker and press enter. You'll see that Docker is not installed. So this is the command also you can run to install Docker. Docker apt install docker.io. That's it. With single command also you can install Docker, or you can install like this. Then you will say, what is the difference between this and this? This will only install Docker. This is installing so many other things. Okay. That is sometimes not required for us. But if you want, you can install the full software. It's totally fine. So let's follow the documentation because I just want to show you one time. Okay. So let me run this command from here, copy, and I'll go here. Let me become root. Let me bring the prompt. This is my Docker machine. It's done. Nothing to delete. Now let me run these commands. I'm just selecting multiple commands and running it one shot, so it's not a problem. Now, what is the next thing? We will add this repository. So we'll say echo. From here, you need to copy till here, right? Line number 415. Is this copied correctly? Line number 415 echo. This is also dollar. This is also dollar. No, I need to till here. I need to copy till this is the whole command. All right. So this is done. We have added the repository. Now second thing is apt update one more time because the repository got added. Everything is okay. Now this is the main command to run Docker. Sudo apt-get install Docker plugin. The installation maybe looks very complex, but if you want to make it simple, you just run this command, okay? No need to run all these commands for Ubuntu. You can just run this command, it's done. But I'm showing you the whole official. Make sure that Docker got installed or not. If you run Docker here now, you will see this output, some syntax and all. So it means that Docker got installed. But if you want to see what version of Docker got installed, you say Docker -- version. It will give you this output like yes, Docker got installed. Okay, this is the Docker installation version. Okay, 27.5.0, and this shows that Docker got installed. Apart from that, what you can do, you can just copy some piece of this command, just like we copied in Git, right? We copy all this one line explanation of the command, right? So we can copy till here. Okay, these are the commands that got copied. Now what you can do, like, the Docker command syntax. Let's try to understand this. Docker syntax. What is the syntax of this Docker command? Just like Git, every command of Docker is going to start with Docker. Okay, every command of Docker is going to start with Docker plus some verb. Okay, so what are the verbs here? The verbs are like this. These are the verbs: run, exe, ps, build, pull, all. Say for example, if I want to run Docker run, so command will become what? Docker run. Okay, and some syntax. All right, so this is Docker run. The command. What is the syntax? Docker plus some verb. What are the verbs? These are the possible verbs. From line number 439 to line number 497, all these are the verbs. Okay. Now we are going to launch a container. We are going to launch a container. Okay, before launching a container, I will tell you one simple scenario, like very an example. Docker installation, we have done it. Like, let me tell you this is the most important concept in Docker. Okay, the concept says, what we have done here, like from where the thing started. The thing started from here, right? We want to run this code, right? We want to run this code. This code we can run in multiple ways, right? This code I have shown you. If we want to run any application code, we can run the code on the following. These are the ways, right? I can run on a machine like server like this. I can run on an EC2 instance. I can run on a Docker Lambda. Just ignore these two things right now. Okay. We can run on a physical machine. When I'm saying physical machine, like we can go to our data center and we can run the servers, images like this, right? These are the server, right? In any data center, we have these are the server, right? You may have seen in movies and all, hackers is like something is doing, but these are the server. These are the physical machine where you can run your application, right? This is one of the way. And another way of running your application that I'm showing you is on EC2, or that is basically on any cloud, the virtual machine. This is EC2, right? Where you can run your application. Till here, everyone is with me? Either on a physical machine or on a virtual machine. These are the couple of ways we can run our application. Now, in order to, if you want to run your application here, if you have to build a server, what are the things required if you want to install a server? Have you installed operating system on in EC2 or on your laptop or in your any server? What is the first thing that is required? Operating system image, right? We say, where is OS image, right? Maybe in a physical machine, it is in the form of ISO image. Okay, maybe in a pen drive or over the network. I don't know, but we need an operating system image, right? Storage and network, that is fine, but most important thing is operating system image. All right. Similarly, if you want to install EC2, what is the most important thing to install? AMI, Amazon Machine Images. Once we get an AMI, and then after that we install an operating system, or once we get an operating system image, we install operating system and we configure it. All right. And our code will start running. Like then we install our application code on top of it, maybe here or maybe here, and our application will start running it, right? This is what happens. Similarly, if you want to containerize any application, if you want to run in the form of container, like you want to run your application in this container, what are the things that are required? First of all, from your code, you have to create a file that is known as Dockerfile. Dockerfile is a text file where we define all the dependency. Code plus dependency, we write it. Say for example, if this code require Python to run, we will mention that this code require Python to run inside the Dockerfile. Okay. So what is Dockerfile? Dockerfile is a simple plain text file that take the code and define all the dependency. From this Dockerfile, we build something known as Docker image. We build something known as Docker image. Okay, this is image and this is Docker image. What is this image? This image is concept wise same as like ISO image, AMI, like this, because for any machine to run, we need an image. And what that image will contain? The code and the dependency in that image. From this image, we create something known as container. All right, this process you need to remember. This is the main process, and we are going to image as an image we call like this dependency, code plus dependency, we create an image out of it. Read only image is what? Read only file, right? Can you say what is ISO image? It's a read only file. You may have remember this disk, right? This in our college days we ask for like, who is having Windows ISO image, who is having Windows disk, right? That whatever written inside that disk, you cannot change it, right? It's a read only file. You cannot overwrite it. Similarly, this image is close to ISO image and AMI, but the only thing is it's very small in size. It's not full operating system. This image is containing what? Code and the dependency. That's it. Very light version of image. Okay, this is the process of containerizing any application. Just remember this diagram. This is the process. Okay, so now we are going to launch a container. For launching a container, what is required? Now tell me. For launching a container, what is required? I want to launch this guy. What is required? Image. That's it. Image, right? First thing we require image. Dockerfile, we'll see how to build Dockerfile, but first thing is require image. So the command to launch a container is this. If you scroll it up, line number 439 says create and run a new container from an image. Yes, this is the command I want. So the command will become Docker run and some image name. Okay, some image name. Okay, say for example, I want to create a Nginx container. Nginx is a web server. So I'll say or something like, Docker run Nginx, or I want to create a Ubuntu container. I'll say Docker run Ubuntu. I want to create another container, say hello world. I'll say Docker run hello world. Okay, these all are images. Okay, and we'll talk more detail about it when we'll discuss about the architecture of Docker container. But because I need to explain you this command, why this command is required, because I need to explain you how this happens. We have not yet explored security, resource allocation, and apps dependency. So I'm doing a little bit of reverse engineering so that we will reach here. All right, so if I go and run Docker run hello-world. Okay, so we'll get some message like this, and this is the output. Okay, and don't worry about these output. I will explain you everything. So let me first run couple of commands and show you. So this is one of the container that we have launched. Okay, and it says Docker run hello world. It says unable to find the image locally. Okay, and then it started pulling the image from somewhere, and it says pull complete and says status downloaded image is there. Something happened. All right, so let's see what happened. So there's a command that is known as Docker PS. Okay, so Docker PS is basically, if you run this command, it will tell you like the containers running. What is the word I'm using here? Container running on the system. If you run Docker ps-a, it will tell you all the container running as well as stopped. You can see this is one container that is start from this hello world image. It got exited. Exited means it is right now not running. It is stopped. Okay. Let me run one more container. Docker. I'll say Docker run. I'll say -d. I'll say -name. I want to give name of the container. I'll say my web app, and the image I'm using is Nginx image. Okay, I'm running this container. It's again I'm getting the same message, unable to find the image locally. Something is getting downloaded, and once that is download is complete, okay, status download is complete, and then some ID is a big number I'm getting like this. And if I do Docker PS now, I can say yes, one container is running, and this ID something is there. It is initial of the same, right? It is the same container. It is created from Nginx image. It is running from last 13 seconds. Okay, and the name is my web app, the name that we have given here, my web app. All right, so this, let me copy this command as well, because I'm going to explain you this command as well. So one thing for sure, we can from this command, we are getting that whenever I am running Docker run, it is creating a container for me, right? And that container is right now it is running also. Okay, why the hello world container got stopped, we will also see that one. But right now Nginx container is right now running. Nginx container is running because we can see with the Docker PS command, right? Okay, let me do one thing. Let me take a, so far what we have done, let me make a note of it. Here, step number 1, we have launched container using Nginx image. Okay, what was the command? Docker run. Okay, the command was Docker run, and image name, some syntax we have followed. The main command was Docker run, right? What is step number 2? Step number 2 is basically, we see that container is running, right? We have seen that container is running. With what was the command? Docker ps, right? We run Docker ps, we can see that container is running. All right. Now let me take a duplicate session of it. Okay, let me go here and say duplicate session. This is the same machine. Okay, this is also the same machine. I'm connecting twice. Okay, I'll say my password. Okay, this is the same machine. Okay, if I can do sudo, I became root of that machine, admin of that machine. This is the same machine. How to list down the process in Linux? What is the command to list down the process in Linux? Let me Google it if you don't know. PS, right? Yes. Okay, so if I say list down the process in Linux command, if you don't know, okay, that is why I'm typing it. So you can see here, these are the commands, some commands to list down the process. PS is the command actually. If you do PS and some option, you will get like all the commands. PS-AUX, that is also a command. If I want to list down the image, I mean, I'm coming to content of image and all. I'll tell you when, okay? Just give me some more time. We'll see everything. There is a dedicated section over the image. So now let me list down the process. PS-AUX. So this basically lists down all the processes that are running on this machine. Okay, this command lists down all the process. You can say process, the process ID, 1, 2, 3, all the processes. Almost 4,201 processes are running, and it lists down all the processes of my machine. But if I'm interested in a specific process, if I say PS-AUX pipe grep -I, I'm interested in Nginx process. I'll say Nginx. Is there any Nginx process running on my, what, this is a filter. grep is a filter. Out of 4,000 processes, I filtered out only all the processes that are running Nginx. Is there any Nginx process running on my machine? -I for case insensitive. Whether you type in uppercase or lowercase, it will make it insensitive. Okay, Vaibhav, case insensitive. The same command if I type grep -I capital Nginx, okay, it will still list down. Okay, but if you type the same command capital Nginx without -I, it will say nothing is running. Are you getting it? So -I is a case insensitive. Webho, you are getting it. So we have Nginx process running here. Can you see that this is an Nginx master process running? Are you folks with me? What is the process ID for this? What is the process ID? 3983. The ID is 3983. Yes. If I want to kill any process, stop any process in Linux, what is the command? Command is kill. Okay. Kill. Yeah, -9 is sometimes not required, or kill -9 and the process ID. So if I do kill -9 is like forcefully. Kill -9 3983. Can I kill this process? Let's kill this process. Kill. Let me grep this process again. Is there any Nginx process running now in my machine? No, because this is just a grep command. This is the same command ka process. No Nginx process is running. So can I make another note? What we did after that? After that, step number 3, we list down all the Nginx processes. Okay, with what is the command that we have used? PS-AUX, right? This is the command grep Linux, I mean grep Nginx that we have used. After that, what we did? Step number 4, what we did? We killed Nginx master process that killed all the Nginx child process. What do you mean by child process? If you go here, this is master process. Worker process are the child. This is parent, this is child. Worker are child. So this, when we killed parent, child automatically get killed. You can see we were having 1, 2, 3 processes running. Right now, all the processes got killed when I killed this master 3983. Okay, so that is for sure we have killed the process. Now let's see any container is running here. Earlier when we were here, container was running. Let me do docker ps. No container is running. If I want to see all the stopped and running container, what is the command? Docker ps -a. A means all. Yes, I can see that this Nginx container is also got stopped, got killed. Stop means got killed. But who killed this process? We didn't kill this container. We killed the process, right? So can we make an assumption here from this statement? Okay, when we kill the process, container got killed, container also got killed. Is this fair statement to make? Is this correct statement? Is my observation is correct? So from here, can I make a statement that containers are nothing but operating system process? Is this correct statement? Yes, obviously. This is operating system process only, right? So now next question is in my mind is, if it is an OS process, how it can run my code within it? How it is possible? How a process can run my code, because I want to containerize my code, right? I want to run code inside container, and container, now you are saying that container is a process. How it is possible a process can run my code inside it? Is it possible? It is absolutely possible. Now that is what we are going to explore. This observation is correct. What we did, let me go step by step one more time. We have launched one Nginx container. When we launch the container, we see that container is running docker ps command. It is showing me as a running container. Then we list down all the Nginx process using ps aux. Then we killed that same Nginx process. The moment we killed this Nginx process, the container also got killed. Okay, it means there is a direct relation between these two guys. So it means that when we killed the process, container got killed. So can we make a statement that container is nothing but an operating system process only? Yes, that is correct. If it is a process, then how a process can run a code within it? That is what the question is. Are you folks with me so far? Is it interesting? Are you finding it interesting? Okay, now let's figure it out how it happened. For this, let's go few years back. Okay, step back. Go to your college days. You have studied a subject that is known as operating system? Maybe, I'm not sure everyone, but maybe some of you have studied a subject known as operating system, Tannenbaum, or what is Dontainer? I don't get the question. There is somewhere typo. If somewhere typo, it is container, not. Step number 2, what is this? Oh, we see that container. Okay, that's a type. So how Linux works? So what happens in Linux, that this is a hardware. Okay. Over the hardware we have what? RAM, CPU, hard disk, like this everything comes under the hardware. Suppose this is a hard disk. Okay, just imagine, and I have a process. Okay, I initialize a process in Linux. I'm talking about Linux operating system. Okay. In order to run process requires some hardware, maybe RAM, CPU, or hard disk. Is it required? Yes, obviously required, right? Any process requires some hardware to run. Is this process going to get this hardware directly? No. There is one more component in Linux that we call kernel. Have you heard this word kernel? Kernel is, you have heard this word, kernel is heart of operating system, right? So this is kernel. What happens? Process will interact with kernel, and kernel will allocate the hardware. This is how it happens. But one more thing, process is not going to interact directly with kernel. There is something known as system call, or we call sys call. Somebody even doesn't know that is the not learn operating system. This is what happens in operating system. Process will generate something known as system call. System call will interact with kernel, and kernel will allocate the hardware. Okay, say for example, just imagine you are running, you are opening your CV. Okay, you are opening your CV. Okay, your CV is basically need to process, then you will see your CV. That document need to process, then you can see your CV. Whenever you want to open a CV, this will generate a process. this process require this RAM, CPU and everything, then you will able to see your CV. Okay, otherwise you won't able to. Sometimes you may observe your computer is super busy, like CPU and everything. When you double click your some process CV or something, it won't open. It will take some time to open. Why? Because they are not getting the required amount of hardware. When you open any file, it requires some amount of CPU and memory and all. That is known as hardware. Okay. So just this is how a Linux operating system works. If you have another process, what will happen? Okay, another process. This process will generate its own system call. Every process will have its own system call. System call will interact with kernel. We have only one kernel. That kernel will allocate hardware. Say for example, along with CV, I want to listen a song. So song will also generate its own process. Okay, I want to watch movie. That will generate its own process. That process also requires some part of RAM, CPU, memory, hard disk, all those things. Who will allocate? Kernel will allocate. This is what the architecture of an operating system. This is, we can say, how Linux works. This is how Linux works. Now imagine this is concept. Now imagine I have two processes. This is an hypothetical condition to explain you what is. Okay, this is, say for example, process underscore A, and this is another process underscore B. Okay, this process will generate system call, this process will generate system call. This is my kernel, that is okay, and this is my hardware. Just imagine, because of any reason, this process A require Python version 2. What version? Python v2, and this process B require Python v3. All right, Python v2 and Python v3. Okay, because of any, and this is my hard disk. Just imagine this is my hard disk. Hardware is hard disk. Because of any reason, any hypothetical reason, I am not able to install Python v2 and v3 on the same machine. It is not allowing me. Technically, we can install it. Just imagine if it is not allowing me to install. So what happens in this case? If I install Python v2, what will happen? If I install Python v2, then only process A will run because Python v2 got installed here. If I install Python v3, then only process B will run here. Agree? Now suppose if I have some mechanism where I can partition this hard disk, okay, where I can partition this hard disk in such a way that they are completely isolated from each other. I put a partition that they are isolated. So what we can do, in this portion I can install v2. I can say install Python v2. Okay, and this portion I can install Python v3 if they are completely isolated. If I got some mechanism so that I can completely isolate. So in that case, what will happen? Both the process can run. How? When a request system call coming from process A, it will go to kernel. Kernel will see, okay, this is coming from process A, so let me allocate this portion of hard disk. Similarly, a request coming from system call from process B, it will go to kernel. Kernel will see, okay, this is coming from process B, let me allocate this portion of hard disk. If this is mechanism is available, can we do this? Yes, obviously we can do this. We can very well do this. All right. So actually, this is what the container does. Okay? This container will have, this is one container. Okay, and this is another container. Okay, this is one container and this is another container. It's not working because it's an image. It's a screenshot. Okay, so this is just imagine this is one container. Okay, this is what I'm trying to say. This is one container and this is another container. But who will partition this thing? Who will partition the hard disk in such a way? So there is a feature of Linux kernel that is known as namespace. Okay, let me show you. Linux name space wiki. What Linux namespace wiki says, let me copy it for you. Linux namespace wiki says, what is namespace? Namespace, just read it. I mean, carefully read it. It says namespace are the feature of Linux kernel. They are the feature of Linux kernel. Okay, this is the feature of Linux kernel that is already there in Linux. That partition a kernel resource. Resource mean hard disk, RAM, CPU, those hard disks, such that one set of process sees one set of resource while another set of process sees different set of resource. It means that if I have a hard disk here with the namespace, I can partition this hard disk in such a way, if I can create as many as partition, that one partition is going to visible to one set of process, another set of partition is going to visible to another set of process, another set of partition is going so on and so forth. I mean, we are here allocating a dedicated hardware to a process, dedicated RAM, dedicated portion of CPU, dedicated portion of hard disk, all those things. This is what exactly aren't we doing with the virtual machine using hypervisor? We were giving the same thing, right? We say this portion belongs to this portion belongs to this portion belongs to this. Are we doing same in container, in process? Yes, and process, what is process? Process is container. Now your container can run your code like a virtual machine, like a like a virtual machine. Are you getting it? Because our process is going to get a dedicated portion of hard disk, dedicated portion of CPU that it is not going to share. Similar thing happening in the virtual machine, isn't it? We are giving this hardware portion of hardware to this virtual machine, this portion of hardware to this virtual machine using help of hypervisor. Here same thing we are doing because that feature is already available in Linux. Okay, so namespace is one of the feature. There is one more feature that container uses, that is known as C group. What is C group then? C group, or no, sorry, C group. Linux C group, not B group, C group. C group or the control group. Let me copy it and then I will tell you what is this. C group is like a capping, like a cap. What C group says? C group says, C groups or control group. It says it's a feature of Linux kernel that limits, means put a cap of resources like CPU, memory, disk, IO, and blah 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 blah. What is the meaning of it? Namespace says I can partition the hard resource in such a way that one partition is visible to one process only. But how big is the partition? If the partition is going to be that big, okay, or the partition is going to be that big, or the partition is going to be that big, is defined by C group. It should not be happen like, if this is my hard disk, one process will get this big partition and all the rest process are like dying for a small portion of it. It's not like that. That capping is done by C group. So that is what's a feature that limits accounts for the isolated resource usage. Namespace is what you can see. C group is how much you can see. Are you guys getting it? Using these two features of Linux and C group, your process start behaving like a virtual machine. And what is process? A container. Now, what is the definition of container then? Container is basically, now if I ask this definition in 10-year, 15-year folks, they will say, what is container? They will say container is a virtual machine. That is wrong definition. Absolutely wrong. Container is not a virtual machine. Virtual machine is different, container is different. What is the correct definition? You can say container is an operating system process that behaves like a virtual machine using the concept of namespace and C group. Are you getting it now? What is container? Your definition. So we started, this security thing is now solved. about this security and isolation app dependency, because they are now getting a separate area. So security is solved. It's not possible that one process will interact with other process because they are running in a dedicated portion. Everything, apps dependency and everything, we can solve it. Okay. What was that? Security, resource allocation. Yeah, resource allocation also we have solved, right? All right. So what is, we started from here, just try to understand the whole process, because that is what I need. I have created a container. We have listed down the container. We have killed the process and the container got killed. From here we made a assumption, we made, like, we identified that container is nothing but a operating system process. That is absolutely fine. But the question was how container is going to run my application, because if in order to run any application you need CPU, you need RAM, right? You need disk, lot of other hardware, right? These are the things required. If it is a process and it is running my app, then how it will get a dedicated portion of CPU, dedicated portion of RAM and hardware or hard disk, so that it can run my code like an independent, isolated way, right? This is what the problem was. For that, we understood that how Linux work. Linux, everything in Linux is a basically kind, we can say, process. Process has a system call interact with kernel, and kernel allocate the hardware. Hardware like anything, CPU, RAM, disk, all these things. Okay. Now, using the namespace feature of a Linux kernel, we can partition. Namespace is what? Namespace is a feature that is available in Linux kernel. Yahan par, like this is where that feature is already available. What this does, partition a kernel resource, means hardware, such that one set of process, means one process will see one set of resource, another process will see another set of resource, means it will see dedicated portion of CPU, RAM, disk. That is not going to seen by this guy. It is only and only belong to this guy. That is an isolation that offers by namespace. And this is the area where my code is going to run. How big is this area? That is determined by C group. Whether this area is going to this much or this much, that we can define with C group. Docker architecture basically. Okay, so Docker architecture has three components. First we call Docker CLI. Okay. Second we call Docker daemon. Third component is Docker hub. Okay. And what is the process of containerization? The process of containerization is this. Right, we have code. From code we create Dockerfile we create Docker image and contain. Don't worry, we'll have a lab on this. Okay, we will understand this in detail. Okay, so what is Docker CLI, what is Docker daemon, and what is Docker name is Docker hub? When you install Docker, where you run this Docker command, right, where you go and run this Docker command, Docker ps, Docker ps-a, all these things we are doing at Docker CLI. This is known as Docker CLI. Okay, this is Docker CLI, where you run the command. What command we ran? We ran Docker run Nginx, right? This is what something we ran. We ran Docker run Nginx. There are a couple of option -d and all, but this is about the CLI, where we run this command. When you run this command is handled by main Docker process that is known as Docker daemon, or sometimes equal to Docker D. This is the main Docker where how it is running. When you install Docker, this process got installed. This daemon started running. When you install Docker using these commands, this basically started this process. And if you want to see this process, you can just list down it. ps-aux grep-i Docker. So you can see that Docker D is running here, right? This is the main process that got started. This is the Docker D process, main process. Okay, this is Docker D, that is running like here. This does all the heavy lifting. This does all the hard work. When you run this command reaches to Docker D in the form of API. It is a REST API over HTTPS protocol. Okay, and Docker daemon sees this API and try to understand what you want to achieve. It is with this command, in this example, Docker understood, okay, this guy want to launch a container using Nginx image, because for container image is required and the image here is Nginx. So first it will search the image locally. It will start searching the image locally on this machine. Is there image available, image available, image available? It will search local, scan the local machine where the Docker is running. That is why it says the message, and there was no image, so it says unable to find the image locally. In this command also it says unable to find the image locally. Locally means on the same machine, not able to find the image. Actually, if image is not available locally, there is something known as a repository known as Docker Hub that is maintained by Docker Incorporation, the company behind Docker. There is a repository that is known as Docker Hub. Docker Hub is like GitHub as a repository only, but for only to store images. The location is hub.docker.hub. This is maintained by Docker Incorporation. This is Docker repository. Okay, Docker Hub. Can you see that? This is Docker Hub. This is maintained by which company? Docker Incorporation, the company behind Docker. This is Docker Hub. It stores all the images. Okay, if you see, if I say Nginx, this image is here. You can see this is the Nginx image. We will talk more about it, like how to store, how to upload, and everything. We'll do all those things. Don't worry about it. So the image is available at Nginx. When Docker daemon not able to find the image locally, because the message what it print, unable to find the image locally, then what it will do, it will go, first step is the request will go to Docker D. Docker D will scan, it's not able to find the image locally. Then it will go to Docker Hub and download the image. That is why we were able to see this message downloading, pulling, and then we got downloaded the newer version of Nginx latest image. So image is now from here, it got downloaded here. When the image is available, then a container started running out of this image, and we were able to see Docker ps command, yes, container is run. Okay, so it will connect this, then it will download the image. Okay, so this is step number 1. That is going to this. When you run this command, it will get converted into API. It will go to Docker Hub, Docker D. Docker D will run, scan, and understand and perform the job locally. But in this case, a container need to be launched, because that container require an image. Image was not available. So what it did, it connect with Docker Hub. Step number 3. And step number 4, it downloaded the image first. And then step number 5, a container get created. So this is Docker architecture. Docker architecture has 3 components. Okay, what are those components? CLI, daemon, and hub. CLI is where you run all the Docker command. Daemon is the main process. Most of the time, CLI and daemon run on the same machine. In our case, CLI is running on that Linux machine. Daemon is also running on the same machine. When you type anything at the CLI, that command get converted into an API request and it's go to Docker D. Whatever you mention in the command, Docker D will do all the heavy lifting. In this case, in this particular example, we want to create a container. For container, an image is required. Okay, so Docker D will see this command and understood, okay, this guy want to run an Nginx container using Nginx image. But that image was not available locally. So it went to Docker Hub, download that image and create a container for it. Are you folks getting it? If I go here, okay, and if I do Docker images, it will list me the Nginx image and the hello world, everything. This image is already available locally now. Now, if I want to create one more container, okay, using Nginx image, you can see docker run -d -name. I'll say -name new web server using Nginx image. This time image is already available locally, right? If I run this command, you can see directly the container got created. If I do docker ps, the new web server got created, right? Why it is not downloading the image this time? Because image is already available locally. It is using the same image to create my another container. Same AMI can you use to create multiple EC2 instance? Yes, right? Same ISO image can you use to create multiple server, laptop, desktop? Yes. So that concept is still same image, because earlier first time the image was not available, so it downloaded from the, and it got pulled and it got downloaded. But right now image is available. But if I create any another container, say for example, I am using web server 2 and I'm using different image this time. Say for example, I'm using Alpine or Ubuntu. Okay. What is message I'm getting? Image is not available locally. So what it will do? It will start downloading. From where it is downloading? It is downloading from Docker Hub. Are you guys getting it? -d to run in the background. Right now it's like running in the background. Otherwise, what will happen? If you don't run -d, let me show you. Okay, let me run web server. Or let me go here. Web server 3. Okay. And if I don't use this -d, my terminal will get locked. You can see this. I'm inside the container now. My terminal is locked now. Okay. I'm here. It's locked. So that is why we run in the background and get free our terminal. Okay, so we will see some of more commands of Docker. So let me give you some list of commands of Docker. Let me go and log into my GitHub. Okay, so here, I have written down some of the commands that you can definitely use it. Docker commands here. Okay, so these are the some set of commands that you should practice. Okay, what I'm showing you just the notes first so that you can understand. Yes, the commands are here. Okay, you can run it. We will use most of these commands one by one. Okay, but what is this command? How to run this command? What is the use of the command? I have mentioned everything here. All right, so let me start with now what we like in order to run a command container. Let's say for example, if you do docker ps, okay, docker ps, it will list down what is docker ps and what is docker ps -a. What is the difference? Docker ps will list down only the running container. Docker ps -a will list down the running plus stop container. If you mention -a, you can see whatever the container that we have created, all our status exited, 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 and exited. It means these containers are stopped, not running. Okay, these containers are stopped, not running. So if I want to start any container, the command is docker start. Okay, and the container ID. And here, in this particular case, you can see this is like your whole output. This is container ID. Okay, Docker assign a container ID to all the container. Okay, this is a hash basically that it assign. This is the name of the container. By default, when you don't give name, Docker will give you some funny name. Okay, but we have given some name, and if you don't give name, it will give some funny name, and it will tell you like what is the image, from which image they have got built. Okay, when they got created, till what time they are running and all. Okay, what is this command? We will see this command meaning in Dockerfile. Okay, what is the meaning of this command? We'll see in Dockerfile. So Docker ps will display the output of running container. Docker ps -a will display the output of container that are running as well as stop. All the containers. In order to start a container, Docker start and the container name or container ID. Say for example, I want to start my web app. This is the container. So either I can give this or even ID will also work. Okay, so let's start with Docker start my web app. So container got started. Now if I do Docker PS without -a, I can see that yes, container is, earlier the output was blank. Now I can see that container is running. Okay. There are a couple of things like, this is a container running, like how this container is running. So what happens here, just try to understand. We have this as a Linux machine. Okay. Over this machine, what we have installed? We have installed Docker. Okay. We have installed Docker here. Now, when the Docker install means Docker D is running. Okay. Docker D is running. The daemon is running. Install Docker means Docker D is running. On top of which we have created a container. That container is running like this. This container, okay, my web app is running on top of this machine. This is the container. Okay, this is how it is running. Can we create multiple container on a machine? Yes, we can create multiple container on a machine. Okay, say for example, let me run one more container. Let me start from scratch. Docker run -d it hyphen name. What is d? What is d? I'll tell you. Okay, hyphen name. I'll say my Alpine, and I can use an image Alpine ASH. So it says unable to find the image Alpine locally. What is this Alpine? Alpine is a Linux image specially designed for container. Okay, it's a very light version of Linux that is specially designed for container. I'll show you this image here. This in the Docker Hub. So here what happened when the moment you run this command is handled by Docker D, and it says it understood. Okay, you want to create a container using Alpine image, but the image is not available here locally. So let me download it. It downloaded the image and then the container got created. Now if you see Docker images, you can see the Alpine image is got downloaded. Earlier the Alpine image was not there. Okay, only we have Linux, Ubuntu, Nginx, Ubuntu and Hello World. Now we have Alpine image also. Okay, so and if I do Docker PS, okay, Docker PS, so I have two container right now running. First one was my web app from Nginx image. Second container my Alpine from Alpine image. So what happened in this diagram? I have one more container running here, and this container name is my Alpine. Okay, so what is happening here? We are kind of this diagram where we have an hardware, where we have an operating system, where we have a run C, that is Docker D, that is installed. We are creating this container, this container, this container like this. These container are independent application. This is okay. This is independent application created from Nginx image. This is independent application created from Alpine image. Can we create more containers? Yes, we can create more containers. But till how many containers we can create depending upon the size of the instance. If instance has, say for example, 10 GB of RAM and 20 CPU or something like that, then by default how much this container will contain, based upon that resource we can create the container. But the point here that I want to tell you to understand the concept, this is how it is running. There is a base machine. This is a hardware plus operating system. Over this we have installed this run C, and on the run C, these are the containers. Over this the containers are running. I'm just trying to explain you this diagram. This diagram is now getting clear. What is the meaning of it? Okay. Now we will perform this exercise. So what we are going to do, we'll have a code, okay, and we'll have a Dockerfile. So first, let's understand about Dockerfile, because code anyway developer is going to write. So what is Dockerfile? Okay, so Dockerfile is a text file that contains instruction, okay, that contain instruction how to build this image. Okay, Dockerfile is a text file that contains instructions. Okay, but instructions for what? Instruction how to build this Docker file. Okay, how to build this Docker image. Okay, I mean, what are the things that require to build an image? An image is something like that will make this code running. Actually, it will define all the dependencies that are required for this code. Every Docker file is going to start. I mean, when I mentioned that it has some of instruction. What do you mean by instruction? Instructions are set of commands, and commands are nothing but simple instruction like what is required, how it is required, and all. So this is what we are going to see. Just let me go to the text file, then here I can explain. And Docker file is a single word with capital D. Okay, there's no extension, not txt, not py, not php, nothing. It has no extension, just Docker file. Okay, so it is a Docker file is a text file that contain instruction to build Docker image, and these instructions are define the environment inside the container, including what software to install, what files to copy, what commands to run. Everything we define, because these are the instructions that is actually going to install your code, run your code the way you want. Okay, everything we define in the file. And every Docker command is going to start with a statement from. Okay, from is basically that is going to specify the base image that Docker is using. What do you mean by base image that Docker is going to use? Tell me one thing. If I am writing a code in Python, okay, if I am writing this code is written in Python, okay, what is the first, and if you want to run a code on your laptop or on your machine, say for example, this is my laptop, okay, and I am telling you run this particular code, and this code is written in Python. What is the first thing that is required for my laptop to run this code? If it is written in Python, Python must be installed. Compiler and all that is fine, but Python must be installed. If it is a C program, C must be installed here. If it is a Java program, Java must be installed here. Otherwise, I won't be able to run this code. Are you getting it? In college days, in your school days, whenever you run a C program or something, we first thing what we do, we install C, right? Similar like that. Okay, so from is actually specify the base image. Okay, base image is like what is required to run this code. If I am writing a Python code, if I'm writing a Java code, the base image I will take a Python. So what it will do, it will create a simple, very first layer of my base image. It is going to create a base image like this. Okay, say if I go here, it will from statement will create my base image, the first image here. It could be any, what should be the base image depending upon what is my use case. Okay, that is what the from statement specifies. So what is this specify? It is specify your base image used to build. All right, and say for example I want to use Ubuntu image, I can say something like this, from Ubuntu 20.4. okay, this is an example. Second instructions, like there are a couple of handful of instructions, 10 and 12 instructions are there only. Second instruction is run. Again, all the instruction of Dockerfile written in uppercase. Okay, all the instructions are written in uppercase. So what run is going to do, whatever the command that you want to execute, whatever the software that you want to install within your Docker. I mean, say for example, when I'm installing a code, okay, on Ubuntu, I want to upgrade my code or I want to install any software. So that we can specify with the run command. So what run does basically, run is a set of commands. This execute the command within the Docker image in the process of build. Okay, whatever it is telling, I will give you when I'll write a Docker file, it will become more clear, but just let me first explain the description. Okay, say for example I want to install something like this, run apt-get update or install Docker image. Okay, next command is copy or add. Copy or add is basically copy the files that are required to copy the content from your base machine inside the container. All right, there is one more instruction that is known as work dir. Work dir is, this is a command that specifies the working directory inside the Docker file. What is the meaning of working directory? Say for example, most of the time when you install any software in Windows, what is the default location of installation of software? C program files, right? Most of the time it is a C program files, right? Where the softwares get installed by default. Similarly, work dir is the thing where we specify where we want to install our code within the container. Okay, if you don't specify the work dir, by default everything will get installed over the root. Okay, so it's a good practice to specify the work dir. All your configuration file, all your software, everything will get installed inside this directory, whatever you are specifying. You're setting the path, or you can say specifying the location where I want to install everything. Okay, and how we specify, we'll specify something like this. We'll say work dir space app. So inside /app directory, everything will get installed. Okay, what do you mean by everything will get installed? Say for example, this is a container right now running, right? Docker yes. I have two containers running. This is one container, this is another container. Okay, this is one machine, this is another machine. Okay, when I'm saying inside the container, what is the meaning of it? If I have to go inside the container, the command is docker exec -it, and let me go inside the nginx container. So I'll say container id, and I'll say for example bash command. What is the meaning of this command? I will tell you in a minute. First, let me show you something. So you can see my prompt got changed. Earlier I have a prompt like docker this. Now I have a root @ this. My prompt got changed. Right now where I am inside the container. I am here inside this machine. I was here. Okay, I was here. From here I went inside this machine. I am here inside a space, because container is also kind of a machine only, right? So I can go inside, I can log in inside, I can install software inside, I can open port, whatever thing that you can do on this machine, similar activity we can perform here. Okay, we are here right now. And what is the meaning of this command? Don't worry, I will tell you. If you give me some time, I will explain each and everything I'll connect at the end. Okay, but we are inside the container. Whenever I'm saying that /app is in this Docker file, basically /app we are creating here. Okay, inside this directory, something like if I do df-h, this is the file system of container. So there will be /app directory that will create, and everything will get installed here. Okay, if I have to come outside the container, okay, there is control p q. If you press the key in the same sequence, control plus p plus q, press your control key, press p and press q, you will come outside the container. Okay, and if you do docker ps, the container is still running. Okay, so this is what I'm talking about. So exec, I will explain this command in a minute. Okay, but you are getting it what I'm trying to say. Creating a directory, it means creating inside the container. Run something, installing something inside the container. Okay, whatever you want to install inside the container, that you specify run command. Whatever you want to copy inside a container, that you specify with copy command. Work dir is where you want to install all your code and everything, that you specify with work dir command. From is the base image on which you want to install everything. Okay, and now there is one more command. I mean, that we specify is known as expose. Expose is like if you want to open any port within the container, that is known as expose. Exposing the port of a container. Okay, like say for example, if I'm running a web server, I want to expose a port number 80. So I'll say expose port 80. Then port 80 will open inside the container on this machine. Okay, not here, on this machine. Okay, now there is one more very important command is known as cmd. Okay, cmd is basically, or the entry point. We will understand the difference of cmd and entry point. Okay, cmd is specify what is the command that you want to your container with to start with. Say for example, you are creating a code, okay? This code you want to containerize, right? This code you want to containerize. You want to containerize this code, right? So when your container gets started, you want to actually run this code. That code must be running. This is what the whole purpose is. When the container somebody do Docker run, actually this code should get started, right? This is what the main purpose. I want my application to be running. So that we specify in the cmd command. When the container gets started, what you want to run? When somebody that Docker run, which software, which application it should start, that we specify in the cmd command. Okay, these commands specify that should executed when your container gets started. All right, and you will get all those things. I think you are getting 20% to 30%, that I know, and that is very good if you are getting 20% of it. When you will create an example, your understanding level will further improve. Okay, even if you are getting some part of it. Okay, these are the some commands that we use to create a Docker file. Before creating a Docker file, let me write something here to explain you this command. If I have to go inside Docker, the command is docker exec, execute, go inside the Docker. If you want to see what is exec, if you come here in our notepad and we have exec, what is this line number 440 says? Execute a command in a running container. If you want to execute a command in a running container, that is what you can do. Okay, so what we can do here is, if you want to go inside a container, the command is docker exec -i and -t. -i for interactive, T for terminal. Okay, I for interactive and T for terminal. Let me explain this command. Interactive means, what is the meaning of interactive and what is the meaning of terminal? Terminal has same meaning. Okay, I is interactive and terminal T is for terminal. Terminal is like, this is a terminal. This is a terminal. Okay, so you are getting, when you run this command, you are getting a terminal of container. This is container terminal command prompt that we generally call. This is a terminal of container where you run all the commands. So T for that. Now, can I interact with this container? Yes, I am pressing ls command. I am getting the output. I am pressing I am typing df-h. I can interact with container. Yes, you can interact with container. Let me come outside, control PQ. I came outside. I'll make sure that my Docker PS is running. Yes, it is running. Let me go inside again. Docker exe without -i, only -t. Am I inside the container? Yes. Am I able to interact anything? Nothing. Whatever I am typing is, I'm getting no response. Container is stop interacting with me. So because I have not specified -i, even control PQ is not working. So I have to do control C. Are you getting it? What is interactive means? If the moment you stop I, it will stop interacting with you. It will stop talking to you. T is for terminal. Now the question is, okay, fine, but what is this at the end? You type bash. Why? Because when I go inside the container, I need to tell what command I want to run. Generally, bash is a shell. Like, in Linux, there is a concept of shell. You get shell here. I mean, to interact, a platform to interact with container. Okay. This is bash shell. This prompt you are getting is a bash shell. If you don't type this one, I mean, it will give you the default one. Okay. So let me show you. Control P, Q, Control P and Q. Oh, I have not typed I. Okay. Sorry. And let me do -i. Okay. And if I remove this bash, let me see what is happening. Can you see what it says? Docker exe option, you need to specify a command. Otherwise, Docker has no specific command for you to give. Docker doesn't know when you land what to give you. So you need to tell, because it's a container, it will contain only the things that is required to run your code, nothing more than. It is not going to entertain you to come inside and play with me. It's not for that. Only this code is whatever required for this code. I will contain only those things. And where I will define those things in Dockerfile. Okay. We are defining everything in Dockerfile. So when you go inside the container, container doesn't know how to interact, what to give you. So for that, you have to specify give me bash shell so that I can interact with you. -I is important if you want to interact. There is one more command now. If you do docker ps, if you are not familiar with exe, there is one more command that is known as docker attach. Okay, docker attach, and you have to give, say for example, alpine, and if I want to go inside this, I can give ash attach, docker attach. One second. So here you can see I am directly inside the container ash attach, because for creation of this container I have already given ash shell. Remember when I created this container, docker run I have given already the ash shell. So I have specified the container. Whenever somebody log in, you should give an ash shell. So D for daemon, run as a backend, I for interactive, T for terminal. I have given at the time of creation of the container. If you have given like this, you can directly do attach. Okay, docker attach and the container name. What is the container name? My alpine. So I got directly the prompt. ls, this is the output of this container. Which container? The alpine container. Okay. Now let me create a container. All right. Now say for example, we now here at some level, like understanding some components of Docker and all. Now let's try to replicate the whole process. Okay, this whole process: code, Dockerfile, Docker image, and container. So code is something that is written by developer. Code is like code. Remember what is code? Code is from where we started our discussion, right? Somebody has a business idea and you write a code. Code is like application source code. Okay. Any program that you are using, Ramu, like you are using Zomato, you are using Chrome. Okay. That are you using Chrome? Chrome for you is an application, right? For you is an application. You are downloading the exe file, you are installing it. But Chrome, somebody has written the code, like in some programming language, they have coded this application. How this application is going to behave, how people will log in, how authentication happens, everything, how the UI will look like, everything they have defined in the code in some language. That we call code. Okay. So, and who writes this code? Most of the time, it's a developer who writes the code. All right. So, say for example, we want to containerize an application. So let me create, I'll say mkdir. I'm going to create a directory for my project. I'll say I want to use a Python code. Okay, I'll say mkdir Python Docker app. I have created my project directory. I'm working on a Python code. I'm for a Python application. I want to develop a Python application. So next thing is cd to that. So this is my project directory. This is where I am right now. First thing first, we have to write a code. I'm going to take a very simple code. Okay. And the file name is, say for example, app.py, vi app.py. Okay. App.py. This is a Python program, and Python program ends with an extension py. Okay. And then we will write a program here, a code here. Don't worry about this code. If you understood, it is okay. If you don't understood, that is absolutely fine, because this is something we are going to not as a DevOps, you are not going to write a code, developer will write a code. Okay. So this is very simple application. It is going to print an output, hello, Dockerize Python application, and it is listening on the port number 5000. Okay. Let me copy this code also at the notepad so that it has little more visibility. Our app.py is a file, and this is the code. Okay, let me save it here. So the file is here. Okay, this is our code. This is our code. This code is what, whenever you run this code will display this output. Okay, and it is going to listen on the port number 5000. Okay, that is fine. Till here, everyone is good. All right, this is our code and this is right. Who will write this code? Don't worry, it's a developer job. If you understood this code, that is fine. If you don't, it's perfectly fine. It's a developer responsibility. Then we create something known as another file, vi requirement.txt. Okay, requirement.txt is like now whatever the things that is required in order to run this code that we define in the requirement.txt. Say for example, this code uses the Flask framework. I'll define Flask. Okay, and there is one more kind of a code application that is required for this one. So this is a Flask framework. You can see here this is a Flask framework that is used by this particular application. So this is going to be a requirement in Python. How we define the requirement? We create a file that is known as requirement.txt and the Flask. Responsibility of these two files is with developer. Developer will write this particular two files. Okay. App.py, everything is here. Yes, everything is here. Let me see. Okay, vi requirement.txt. Let me also write a requirement.txt. We'll say, where is my requirement.txt? Right, and what is the requirement for my code? Who will know that what is the requirement? Developer's responsibility. Developer will know that what is the requirement of this code. Okay, he will only know and he will write all those things. Don't worry about it. Now these two files are here. Okay, these two files are here, app.py and requirement.txt. So what is happening here? We have a folder where we have two files, app.py and requirement.txt. In this folder we have two files. First one is app.py and we have another file that is requirement.txt. Now we are going to create another file that is Dockerfile. Okay, we are going to create our Dockerfile. Dockerfile is what? Capital D. And it's a single word, no extension. Okay, this is Dockerfile. We are going to write a Dockerfile to utilize these two things inside my Dockerfile, and using this Dockerfile, I am going to build an image. This is going to be the process. Are you folks getting it something? Initially, the image will also in the same machine. Okay, but first let me create a local image. Then what we will do? We will check that we will try to run a container out from this image. We will create a container using this image. This is what I want to achieve. Alright, so let's start with Dockerfile. So what we will do, we'll go to our terminal, we'll say vi Dockerfile. Alright, so first thing first, we are going to write the base image. Like this application is created, this application is written in what? This application is written in Python. So we'll say from, okay, we'll say from Python 3.9 slim. Okay, 3.9 slim. So this is Python 3.9 slim. Where is this Python 3.9 slim? If you go here and say Python, okay, and if you go to this Python, this is the Python image. Okay, Python Docker official image. And if you go here, like there are so many versions of Python is available. There is Python 3.14, 3.14 slim. Okay, out of these many versions, what version is useful for you? You should ask your developer. Okay, you should ask your developer, like I should use this image, which image, which version of Python. Okay, that we need to ask. Okay, so once we have that clarity, we can go ahead and choose the base image. Okay, say for example, I am using 3.9, right? So 3.9 may be somewhere here, 3.21, 3.12, 3.11, 10, 9, right? So this is one of the image that we are using, 3.9 slim, this one. Okay, this is the image that I'm using here. Okay, so this also we need to understand. So I'm using 3.9 base image, and then we are specifying like what are the files that I need to copy here. So I'll use copy what? Copy or let me first specify the work dir. I'll say work dir. Okay, and I'll say /app. So I want to install everything in /app inside the container. Okay, and there are some requirements, like we'll say copy. I want to copy what? I want to copy requirement.txt because this is something I want to copy. Okay, say this one. Let me go to diagram here. So these are the files that I want to copy, right? app.py and requirement.txt. So okay, inside this file, inside the Docker file. So for that I can use copy. So this is the from statement that we are creating the base image. We are specifying the directory. This is what it is. The directory is okay. Now after that, what we are going to do, we are going to write a we are going to tell, like, this is what my app dir work dir. Now we want to copy what I want to copy. Tell me what should I copy inside the Docker file. What is required to copy inside this Docker file? Do I need to copy app.py? Yes or no? Yes. Do I need to copy requirement.txt? Yes or no? Yes. I need to copy these two files. Okay. So what is the copy command syntax? Any copy command syntax is source and destination, right? So what we will do, we will say copy dot to dot, or you can say copy dot to slash app if you have any issue. Okay. But you can say this is a more professional way. What is this? We are specifying to install everything on a slash app. This is become our work dir. Copy dot means whatever in the current directory. Dot is the current directory in Linux. Whatever inside here in this directory, copy everything to Dockerfile. I mean slash app. It will copy everything to your Dockerfile. This is what I want. Okay, inside the Dockerfile means here in slash app. Why these two files are required? Because these are the two main application that is required to run my code. This is my code. This is the dependency of the code. All right. Next thing is what we need to copy we need to say, for example, let me write it very simple. Otherwise, what we can do here is we can say copy requirement.txt to one file, and then I want to run. Yeah, that is why I changed it. Okay, I just mentioned one file to requirement.txt to dot, okay, to the app.dir. Then I want to install whatever mentioned in the requirement.txt. I want to run those things. For that, there is something known as pip is a package manager. So I'll say run, okay, pip install. Let me copy this thing. So this is whatever mentioned in the requirement.txt. I want to install that. For installation, where I want to install inside the container, right? When the container will get created, whatever mentioned in the requirement.txt, it should get installed here inside the container. For that, I am mentioning a command pip install no cache dir means flush the cache, and whatever mentioned in the requirement.txt, install it. What is pip here? Pip is a Python package manager. Okay, Python package manager that will whatever you mention in the requirement.txt, it will install it. Okay, so this will install it here, the package. Then what is next thing? We'll do copy of dot, and we'll say, or we can say copy of app.py, or copy of what you can say, copy of app.py, or copy of dot to dot. Basically, we are copying all the content of our application app.py to here. Okay, then what is the thing? We need to expose the port. Our application listens on the port number 5000. So I'll say expose port 5000. You can see here it mentioned that port is 5000. So I'm opening that port in the container. Okay, then we are specifying cmd command to run, like at the start I am telling that you should run a pipe. You can run this one. Okay, cmd python app.py. App.py is already copied here in app using this command. Okay, so whenever my container gets started, you should run any Python program. If you want to run, you have to, let me open this Dockerfile one more time. Any Python program that you want to run, you have to run Python and the program name. So this is what I'm telling you. Run Python and run this program when container gets started. What is cmd? Cmd will only run when a program, this command will specify the command that should executed when the container gets started. So when your container gets started, which application is going to run? This code is going to run. Your code is going to run. Okay, so we have a Docker file that is ready. Okay, So we have a Docker file that is ready. So if I clear my screen, if I do ls, we have Docker file app.py requirement.txt in the same directory. I'm at the base machine. From this Docker file, the next step is to create image. And folks, if you are not able to understand each and every part of Docker file, that is completely fine. I will again explain it. First, let me run through this whole process so that your concept should become clear. I will write couple of more Docker files and it will become clear. Okay, so don't worry about it. So what is the next step from Docker file? What we want to create? We want to create image. Okay, we want to create an image. So let's create an image. Before that, let me delete all the previous images. Docker images. I can see I have couple of images, Alpine, Nginx, blah, blah, blah. So, and if anything is running, Docker PS, there's some container running. So what I do, I do Docker stop, and I'll stop these two containers. I'll say stop, stop. I'm stopping both the containers. It got stopped. Let's wait. It will be stopped. So it got stopped. Can you see that? Yes. So let's delete everything from my container. Like, I want to delete all the container, all the images and everything. So for that, there's a command is known as Docker prune. Okay. So let me run Docker system prune -all. Don't run this command in your production box or anywhere. Okay, this is dangerous command. It's my test machine. I want to delete all these images, all these container, everything from my machine. So that is the command. Otherwise, if you just want to delete images, okay, and if you want to delete even Docker RMI, remove image, and you can delete Alpine. So it will remove the image because right now the container is holding. So first you need to delete the container. Docker ps-a. You can see there are so many containers because this container is holding that image. So what we need to do, we need to first delete the container. So how to delete the container? Docker rm and the container name. Container, Docker spelling is wrong. Docker rm and the container name. Container is gone. Error container depends upon other container. Okay, there is another container. So let me delete Ubuntu. So what we'll do Docker ps -a. I'm just cleaning my system so that you should not get confused. So I want to delete everything. So this is exited. Let me delete one of the container and Docker images. Okay. So first, if you want to delete image, let me first stop Docker rm and the container name. What is the container name? Ubuntu. This is the container. You can give container name or the container ID. It will remove the container. Now if you do Docker ps-a, you will see that Ubuntu is gone, right? Ubuntu is gone. So that is fine. Ubuntu is gone. So now what you can do, then you have to delete the image. Then you say Docker RMI remove image. What is the image? Ubuntu image. You can say delete image. First you need to delete the container, then image. Then this image is also got deleted. If you do Docker images, okay, it will say you can see Ubuntu is gone. But this step you have to follow for each container, each image. If you want to delete everything in one shot, then the command is Docker, okay, system prune -all. If you want to delete all the container, all the images in one shot, okay, then it will delete everything. But it is a dangerous command because it will delete everything. Now if you do Docker ps-a, there is no container, okay. Docker images, there is no container. I mean images, there is no images. So our system is blank, okay. Okay, so system prune is little dangerous. So now we have, if I do ls, I have Dockerfile, app and requirement. Do we have any image in our system? Images? No system, no image. Do we have any container running on our system? No, there is no container. Our system is almost kind of a brand new system. Now we are going to create our own image using Dockerfile. So command is for that Docker build. Okay, and you can give some tag like say I say -t, I'll say Python Docker app, something like that. Okay, I'll say Python Docker app and dot is like your context. Where is your Docker file? Where are all those images? You can just give because we are at the same location. Okay, so we can just give dot. If you run this one, it will start building an image. Can you see that it start building an image here? Okay, let me see what happens here. Do we have image created? Let me copy this command, docker build, and copy this command from here to here. So what, oops, so what happened to this command? Something happened or what? Control Z. Do we have copied all this command? Yeah, but here you can see this is got copied. This is created, naming, exporting images, copy something, exporting, writing image, naming Docker app, caching something. It happened, but let me see what is the message. It's something weird, right? I mean, it doesn't look copied good. Doesn't look good. It's something weird. I'm not copying it. First, let me see. Image got created. Docker images. Yes, an image got created. Can you see that this is our image got created? Are you folks able to see it? This is just got created. That is why it's giving me a minute ago. So we are till here. We have Dockerfile. We have images. Now from image we want to create container. Okay. So let's create a container. Docker. What is the command to create container from an image? Docker run. Right. So we have Docker images. Yes. We will create Docker run -d. I want to run in a background. I'll use one more option that is known as -p. -p 5000 colon 5000. What is the meaning of this -p 5000 colon 5000? I will explain you in a minute. Okay. And I will give you the image. Yeah, but there are two ports, right? But what is the meaning? I will tell you in a minute. First, let me create a tab. Okay. So this is Docker run -d, the command to create a container. Let's see. A container got created. Let me see. Docker ps. Yes, container got created and it is running. Okay. Now I want to access my application. I want to access my application here from this. For that, let me just log into my virtual machine. The virtual machine has a public IP address. This. The VM over which we have installed Docker. This is an EC2 public IP address. Okay, let me open a port on the security group. Okay, then I will tell you one in a minute. All right, so it is something like this. Okay, this is our container. That is our EC2 instance. Okay, this is our container that is running inside this EC2 instance like this. Okay, and we are sitting here. We want to access our application. So first thing first, your request will go to the physical machine. I mean that VM, and from VM it will go to the container. Okay, something like this. It will go like this to container. For that, we have given the IP address of this guy. So let me copy this IP address. Go here, type it and mention colon 5000. Can you see that hello Dockerized Python application output? This was our same application output. So let me quickly revise it whatever we have covered. Therefore, the most important thing that you need to understand is this. We have a code. That code I want to run inside the container. That's it. This is what actually we want to achieve, right? But can we run this code directly inside the container? No, there is a process for that. From that code, we have to create a Docker file. Docker file is a text file that will have some set of instruction. That instruction is basically we write how this code is going to run, what are the dependency of the code, what are the package that is required to run this code, whatever it is. What is the port number required, what is the command, what is the application that I want to, what is the command, what is the program that I want to start when we launch the container. Everything we specify in Docker file. Okay, When Dockerfile is, but Dockerfile is a text file from, it is just a text file. From this file, we cannot do anything. I mean, we just define it. But from Dockerfile, using this Dockerfile, we create Docker image. So whatever the mention in Dockerfile, it's get recorded here in the form of image. When the image is ready, we create container out of it. That is the process for any and every container. In our case, we have a code that is app.py. It's a very simple code. This code will generate this as an output. This is a web application. This will generate this output. How this code is written, why Flask, it's all developer responsibility. Leave it. Okay. And apart from that, developer also mentioned, because in Python, if you have any dependency that you want to use in your code, that you have to define in requirement.txt. All right. I want to run this code. And for that, there is some requirement. Everything I have mentioned in the Docker file. Now let me copy the Docker file here. Let me put it side by side. This is our Docker file, right? In this Docker file, we mentioned that this program is written in Python. So we say that we will use a Python base image. That is fine. This will create one base image like this. Okay, this is the first layer of my image. Then I said create a app directory /app. So it will create a /app directory here inside this image. Okay, forget about this one. It will create a /app directory like this. Okay, then it says copy requirement.txt. So whatever the requirement.txt, it will get copy inside the /app. Then I said pip install requirement.txt. Whatever mentioned in the requirement.txt, it will install that one. That is Flask will install, because in requirement.txt Flask we have mentioned. Then we mentioned copy . So whatever available inside this directory, you can see also Docker file is also got copied. So this directory has 3 files: app, requirement, Docker. Everything will get copied inside /app. Why /app? Because we have already defined it. Then we mentioned expose port number 5000. Then a port will get open, 5000 will get open over this. Now after that we mentioned cmd. This command will only execute when you run docker run. The moment you run docker run command, it will start creating container and it will see what you have mentioned in the cmd. Okay, you mentioned run app.py, so it will run app.py. And what is the output of app.py? The output of app.py to display this message. This is what the output of this command. It will say print this, define this, and we are calling it and it will define it. That is why the moment we created the container, we got this out. Now the question here is, what is this :p.p, right? What is this? Where is this command, right? What is the meaning of -p and p? This is what the next thing that we are going to learn. Okay. We have p -p 5000 : 5000. Okay. To the second one, the second 5000 is telling about the container port that is mentioned in our code. And the first 5000 is telling me the base node, this node code. This is the VM on which we have installed Docker. What happened? Let me tell you about the Docker networking. The moment you have a machine, let me stop the container. Okay. See Docker ps. Let me stop this container. I'll say Docker stop. Container name Docker got stopped. And if we do Docker ps, nothing is running. Okay, now this is my Linux machine. How to see the IP information of Linux machine? What is the IP address and what is the port? The command is IP addr show. I want to see the IP addresses of my machine. The command is IP addr show. If I run this command, you will see that I have a couple of things. This is L0, this is ETH0, this is some more port. There is something known as Docker 0 also, right? This is the basic. But if you install just ifconfig is also I would say previous generation of Linux. Now they have changed it, ipADDR show. ifconfig will also work, not a problem. If you just install a Linux machine without installing Docker, you will see this command only. Okay, I can show you. Maybe tomorrow we'll launch a new machine and I'll show you. But if Docker is not installed, Docker not installed. Remember, we have installed Docker yesterday. You will see only these output. Okay, this is loopback address that we call, that is for 127.0.0.1. Every machine will have a loopback address. You can go to your Windows, you can go to CMD, and there you can type ipconfig. Okay, config/all, ipconfig/all. You will see all those things. Okay, IP address of your Windows machine, loopback address, everything. Okay, same thing in Linux. We can see like this. This is the ETH interface. ETH is an interface. Okay, that is, every machine will have a network interface card that is called NIC, network interface card. Okay, if you go here and you to type NIC, and if you see the images, this is NIC, network interface card, that your laptop has an NIC. But right now in our case, in our home and everyone, we have Wi-Fi NIC. Right? We don't have wire nowadays, right? Earlier we used to put RJ45 cable and all. In your home, if this is your TV, this is your smart TV or mobile phone, your mobile phone also has a Wi-Fi NIC. Your TV has an NIC if it is a smart TV. And you have in your home, there is a router, right? Airtel router, AT&T router, or whatever, it is a router. Okay. When you connect your NIC, give your password, and for this you connect to this router and then you connect to the outside world, right? This is what happens. You can see Facebook, all those things, Netflix and everything like this. Are you getting it? But for that, NIC is required. That's a network interface card. This is what NIC for the virtual machine, ETH0. This one is for cloud specific because it's in Azure cloud. Just ignore this because they kind of install one more interface for other connection and other processes, other services as well. Right now, I'm just ignoring it, okay? Because most of the time you'll see only this. Cloud specific, I'm just ignoring it because we are not learning cloud here. Okay, so this is the interface card of this machine. Okay, the moment you install, we will talk about cloud here. So Wi-Fi, you understood. This is the network interface of the card. The moment you install Docker, there is a bridge get created that is known as Docker 0, like this. This is a network driver, Docker 0. What is this Docker 0? This is a network driver that get installed when you install Docker. So now that is why we are able to see this Docker 0 because we have already installed Docker here. Okay, when you create container, let me create container now. That our container, where is that? Docker run, yeah, this is the command, right? We have run this container, we got a container got created. Yes, container got created. If I do Docker PS, container is running. Now let me show you the IP address, ipADDR show. Can you see that L0 was there, ETH was there? We have ignored this guy. Docker 0 was there, but there is one more interface, VETH something got created. So what happened when you create a container will get created like this. This container will have its own network interface card, NIC. That is VETH something. I'm not giving this much long name, it is very difficult. VETH, I'm just mentioning VETH, virtual interface, and some number. This will also have an interface. Now we want to access application. Our application is running where? Our application is running inside this guy, right? This app.py is running here, right? It is running here and I am sitting here. I want to see this application over the internet using my laptop. I have used this. This is my laptop, right? This Firefox is my laptop, right? I am having my laptop. I am running here. Okay, I want to use Firefox for that. I want to connect this guy, app.py. So how the connection will work? Let's try to understand. The moment I'll make a request, the first request will goes to NIC. Okay, let me make a little bit more professional. Instead of curve, I'll be rounded. Okay, so this is, it will go to NIC. From NIC, I have opened a port 5000. 5000. That is why I mentioned Docker run first 5000 is for this guy. Can I use any port? Yes, you can use any port. It is not necessary that whatever open in the container, you can use the same container. It's not required. It's not at all necessary. Okay, I can show you. I can run one more container using the same image. This time I'll use some other ports. I'll say 8080. Is it created another container? Docker PS? Yes, two containers are created. Okay, can I access the application on 8080 as well? Let's try. Copy this thing, go here, put it here and mention colon 8080. I get the output, but this is a different container. Okay, I'm not attaching with the same container. It's a, though both are running the same application, but app.py is running here, and this guy will also have its VTH. If you want to see, let me show you. Right now I have only one VETH, right? Docker 0, 1 VETH. Now let me run IPADDR show. Can you see that I have 2 VETH? Second container ka virtual interface. So when I'm hitting this, now let me tell you how traffic flows. Okay. So when I'm hitting this IP address at the port 5000, when I'm hitting this application at the port 5000, okay, my traffic is going and hitting here NIC of that 5000. 5000 is matched with this container. So it will go to Docker 0 to this VTH, and we are able to access our application. When I am hitting this IP address at the port, 8080, it will go to Docker 0, it will go to VTH, and you can see app.py running on this container. Because the application is same, so we are getting the same output. Now let me go here. Let me take two sessions here. Okay, I will take duplicate session. I will go to this machine as well. Okay, so these are the two machines. This is one, and let me also do sudo here, and I will say Docker PS, and here also Docker PS. Okay. Oops, sorry. Same machine, we have two containers running. Here also two containers running. I am going to log in one container at a time, okay, on these machines. So here on this machine, I will log into this container. I'll say Docker exec-it. This container, I'll say /bin/bash. I'm inside this container. In this machine, in this terminal, I log into second container. Docker exec-it, this one, and I'll say give me bash shell. I'll say bin bash. This container I am at 9B3. This one I am at 670. Two containers running, I am logging into. Let me clear the screen. Clear. Now let me run IPADDR show. Okay, sorry. I mean, the package itself is not installed. I mean, IPADDR package must be netutil package must be installed. So in our machine, we have not installed netutil. We have just installed Python application. Are you getting it? Because IPADDR is a command that must be installed. In our Linux file, in our here, we have just mentioned to install this, right? Pip install to run.txt. So the package is not there. So let me run Docker run -dit. I'll say container A. Okay. Alpine ASH -. So it is creating one container here. Let me create another container on the same machine with container B. I am creating container B. So I have 4 container running here, Docker PS. If you see, I have 4 container. Okay, let me show you the output like this. Otherwise, you will get confused. Can you see that I have 4 containers running? Container A, container B, and this one. Let me log into inside this container. Docker exec, or let me do Docker attach. Docker attach to this container. attach. And inside this container, let me log into another container here, and I'll say Docker attach this container. If I do ipaddr show, this container has this package. Can you see this interfaces? Let me make big screen, otherwise it's not very clear. ipaddr show. This is the loopback address of the container. This is ETH of that container. But this ETH is like this. We are here. Okay. And from this container, if I want to ping google.com, am I getting the response? Yes, I'm getting the response from google.com. Okay. Now how the traffic is flowing in this time? I'm inside this container. Okay. I'm right now inside the container and I want to connect Google. Google is somewhere running over the internet, some in the Google cloud, right? How the traffic is flow? It will go to Docker 0, from Docker 0 to NIC, NIC to internet, and internet to tada. If somebody wants to connect me, it will come like this, NIC, Docker 0, and this. If I want from inside the container, if I want to connect like this, that is one. Okay.
Just a quick info, guys. Intellipaat, in collaboration with Microsoft, offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor-led sessions along with self-paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI/CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies, real time labs powered by AWS simulating production level environment, 15 plus in demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course without a doubt can set your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.
So what is container orchestration tool? So container orchestration tool is a software solution. Let me write something here so that you can refer it later. So container orchestration tool is a software solution designed to manage, deploy, scale, and automate the operation of container in production. Okay, this is what you need to understand. If the question here is, you may ask this question, or that question may be coming in your mind, that why actually we need, right? I mean, why we need something like tool like Kubernetes? Why not we are managing these containers manually? Why? Because we know how to manage container, we know how to create container, what is container, all those things we have discussed, right? How to run a container, how to deploy a container, how to write a Docker file, everything we have discussed. What is networking, what is how computer networking works, I mean container networking works. We discuss all those things, that is fine. Is this question is coming in your mind, like why we need this kind of tool, right? That is one thing. It is a time concern. The main question is because the scale we operate, the number of containers we operate. Think about any website. Say if I go to Amazon, if I talk about this website Amazon, like this is one microservice. I think I have shown you. If not, this is one microservice, this is another microservice, this is another microservice, so on and so forth. These are the different microservices that are running, and this Amazon is basically running on EKS, AWS EKS. Okay, and this has hundreds, thousands of containers, hundreds and thousands of containers that are running. Managing these many containers manually, definitely it's a problem. Okay, the scale we are operating nowadays, it's very difficult to manage a container manually. And the one thing that it's going to be time taking and manual. Remember, we started the discussion of DevOps, like when we discuss DevOps, what is DevOps? And here at some point we say it's a delivery of high quality product, but quickly, right? Quickly is not going to possible manually, right? Quickly means fast, fast means automation, automation means tools, and this time we are learning container orchestration tool. Okay, so just try to connect all your dots. Like, whenever you are learning any tool, that thought process should be very clear in your mind, that why, what is use of this. Just don't learn just because this is in the course content. At least spend some time to understand what are the problems that I'm going to solve with this tool. What are the use cases where I'm going to use this tool. That is very, very important. If you're really targeting for a role, something like solution architect, cloud solution architect, okay. So there, architect means what? You are going to design something. Until unless you are not going to understand the problem of what you are going to design, tell me, right? Until unless you're not able to understand what are the use cases, how can you design something? So focus in learning the tools, as well as what are the problems I can solve with these tools. What are the use cases where I can utilize this tool? All right. So let me write something. So what is container orchestration tool? Container orchestration tool is a software solution. Okay, because at the end of the day, it's software only. That is to manage, deploy, scale, automate operation of containers in production, any environment. It's not only production, we can test dev anywhere. Okay, and actually I can write something like this. Containers are lightweight portable units that package the application and their dependencies. Okay, so in modern distributed system, like, when we deploy any system like distributed system, like Kubernetes is a distributed system. However, in modern distributed system, managing multiple container across various environment manually becomes complex. So container orchestration tools simplify and streamline this process. So that is why it is using. So what are the key function of a container orchestration tool? The key function of any container orchestration tool is basically you can automate the deployment. Okay, you can automate the application launch. Okay, you can fully automate the application deployment. You can scale your application, whether scale out or scale in, that is possible. You can do load balancing your application. Okay, you can have a load balancing your application. You can do resource management. So all these things, resource management, high availability, everything is actually, okay, all those things is pretty easily done by container orchestration tool. Storage management, that also very, very important topic of container orchestration. Okay, there are many container orchestration tools that we have discussed, like Kubernetes, Docker Swarm, right? Apache Mesos, AWS ECS, Nomad, right? But out of these, Kubernetes has captured the market. You can say it's a de facto. I mean, container orchestration tool synonym is Kubernetes. And the people don't say container orchestration tool, people say Kubernetes. Okay, just like people don't say container, they say Docker. Okay, and there are some tools that are dependent on the that are underlying is Kubernetes. That's just like AWS has EKS, Azure has AKS, Google has GKE, OKE, IKE is from IBM, Oracle has OKE, Oracle Kubernetes Engine, Google Kubernetes Engine, IBM Kubernetes Engine. What are these managed Kubernetes cluster? We will see how it is different from Kubernetes cluster. We will see in the architecture. All right. Now let's understand the architecture of container orchestration. Architecture of Kubernetes. Okay, architecture wise, Kubernetes is very simple. There are two components. Okay, first component we call control plane. Okay, or sometimes we also call manager. Okay, but control plane is more correct word. But in normal talk, we also say manager, Kubernetes manager. Second component is called data plane, or sometimes we also call it worker node. So control plane is like this guy. Okay, this is control plane. It's something like who will take all strategic decisions. Okay, control plane is like no master worker architecture. You can say this is the architecture. Control plane where it is going to take kind of all the strategic decision. It is like a manager within the team. Okay, what manager does in a team? Manager will say who will do what, right? You are going to work on this project. Okay, Venkat, you are going to work on Java. You are going to write the Java code. Okay, Gaurav, you are going to create a CI/CD pipeline. Okay, Prahlad, you are going to work on XYZ project, right? This is what manager decide. Who will do what? All the decision part is basically comes to the manager. Worker node is like engineer who does all the real hard work. Okay, who is going to write the file? I mean, who is going to run your application? Actually, what we are going to do here, we are going to containerize our application and run it, right, in the form of container. This is what we want. We want our code to be run in the form of code that should be run in the inside the container, right? So container is basically going to run on a node that is known as data plane. Okay, but how this is going to run, where it is going to run, it is decided by control plane. Okay, so this is at very high level, at 1000 feet. You can see this is the architecture of Kubernetes. It has two components. First, we call control plane. Second, we call data plane. Okay, and this is the architecture of Kubernetes. Okay, so let me also control plane and the master node. Now we will dive a little bit deeper. This is control plane or the master node. It's responsible for managing cluster and it to take all the decision. Worker node is again your data plane. Okay, where actually your workload runs. Now let me talk detail about control plane. In control plane, there are couple of components. Okay, we will talk about most important one, and when we'll have a fair understanding, we'll talk about more components. First component we call it the Kube API server. The first component is known as Kube API server. Or let me just talk Kube API. So first component is a Kube API server. Second component is known as scheduler. Okay. Third component we call controller manager. All right. Fourth component of Kubernetes master is there is a database that we call etcd database or etcd database. What is the name here? etcd. Okay, or etcd, etcd, whatever you want to say. That is fine. This is your database. So these are the four main component of your Kubernetes master. Similarly, in data plane, we have three important components. First component we call kubelet. All right. Next component is kubeproxy. And last component is we call runc or container runtime. Container runtime is same runc that we discussed in Docker. Okay. If it is Docker, then it will be Dockerd. Okay, because Kubernetes can manage any type of container. It is because we have studied like Docker is one of the type of container. Okay, so these are the 7 components. There are some add-ons also. We will see those add-ons little later. But let's first start with what is the role of all these components and how these things are connected. Okay, so these are the 7 important control manager is only having one. All right, now what is the role of these things? First, let's understand Kube API server. Kube API server is something like an API gateway. Okay, it is nothing but an API gateway. Okay, but what do you mean by API gateway? Any communication will happen via Kube API server. Even if you are going to talk to Kubernetes cluster, you are going to connect via Kube API server. If you are creating a cluster and if you want to connect to this cluster, okay, you are going to talk via Kube API server. Okay, so this is what the Kube API server. Any component, none of these components can talk to each other. Any communication will happen via Kube API server. Controller manager is not going to directly talk to the scheduler. They will talk to Kube API server, and Kube API server will basically connect them. Its CD is a database. What is its role? I will tell you, but that is also only and only get connected via to Kube API server. Only Kube API server can talk to its CD database. None of the other component can talk to its CD database. Okay, so the Kube API server is kind of a gateway where all the communication, all the components communication within the Kubernetes, any external communication, like if you want to talk Kube, you will also go via Kube API server. All right. Now, this is one thing. Second thing is in master plane is kubelet. Kubelet is basically an agent of Kubernetes. You can say agent of Kubernetes that will run on all the worker node. You can have one node Kubernetes cluster, you can have two node Kubernetes cluster, you can have 100 node Kubernetes cluster. What do you mean by that? If I have to run so many container of these microservices, for login I have 10 my container, for menu I have 10 container. So if each microservice will have 10 container, 1, 2, 3, 4, 5 microservices. So I'll have a 50 containers that I need to maintain. If I have a one node Kubernetes cluster, all the 50 container will run on single node. Okay, but that's not the correct. I mean, that is not a correct architecture, because if that node fails, then what? So what happens? We'll have control plane, and in data plane we'll have multiple data planes. Okay, just to maintain the high availability, and your containers will get distributed across all these nodes. Say for example, I have 3 node, 4 node, 5 node Kubernetes cluster. Let me remove this 6th node. These are the 5 node. These are the 5 worker node. Okay, these are the 5 worker node. Okay, these 5 worker node are running here. So my container will get distributed across all these 5 worker node. Okay, so this, and each node will have this kubelet, kubeproxy, and runc. So kubelet is an agent that runs on each Kubernetes worker node, and what it does, it gives the status, like what is my health status, how many containers I am running, I am healthy or not, everything it will update to the Kube API server. Okay, because this is it's a kind of heartbeat. Okay, remember the one concept that is known as cluster. We call Kubernetes cluster. So what is the concept of cluster? Cluster is like group of server running the same application. Okay. Remember we discussed this concept in SWAMP, right? Group of servers running same application or same code. So this is also, this Kubernetes is also a cluster, because these are the group of servers that are running. So kubelet will explain like what is the health, what is my health, what I am doing, how many containers, and everything it will report to the Kube API server. That is why we call this guy as an agent of Kubernetes cluster. Okay, second component at the master is, let me put this guy like this. Can I drag this a little bit? Yes, okay. This is concept of cluster. And let me put a border here. This side of border is master plane, data plane. This side data plane, this side control plane. Okay. And let me drag like this. Let me drag like this. Okay, second component is scheduler. Scheduler is something very important component. Now I'll give you one example. Say I have two machine, okay, machine A and machine B. All right, I have to run my application. At machine A, I have 2 GB of RAM and 2 CPU free available. And machine B, I have 4 GB of RAM and 4 CPU available. And I want to run my application. Which machine is best suitable to run my application? Should I run my application on machine A or machine B? Where you are going to run your application? B. Why B? Because it has more resource. So you did some calculation, right? You apply your logic. This is what scheduler does, okay? Scheduler will tell if I have so many node, okay? If I have so many node, where to launch this container, where if I have this login container, okay? I have this menu container, all my microservices, this is login, this is menu. These are the container that needs to be run. But wait, this login container run on this machine, this machine, this machine, which machine to run, which worker node to run, how to decide that? Menu where I should launch on these containers. This is what decided by scheduler. Scheduler will only decide where to launch the container by running some algorithm. It will only decide. It is not actually going to launch. Okay. Scheduler decide where to place the container. And now I will say one more word. I'll say where to place the pod. I'm not going to say container now because in Kubernetes we discuss about pod, but what is pod? Don't worry. Right now for us, pod is equal to Kubernetes. Okay, just for a few more minutes. I will explain what is pod. Don't worry. Okay, so this is something where to launch those pod that is going to decide by scheduler. And in scheduler is going to decide. Say for example, I want to launch a pod, then how the communication will happen, I'll tell you. The moment if you want to launch a pod, Kube API server will say, hey scheduler, can you tell me where to launch the pod? Scheduler will go and say, for example, there are 1, 2, 3 node. Okay. Then scheduler will go and say, okay, let me run my algorithm on this node, and this node. The algorithm, he will run algorithm. What algorithm? Don't go there. It's a complex Go program. It will run, but it will internally managed by Kubernetes. And then he will decide, okay, this node is best to launch this particular pod. Then it will come back to the Kube API server and say that node number 2 is good to launch the pod. Then the Kube API server will say, thank you so much. It will connect to the kubelet of node number 2. Okay, and say, hey kubelet, go and launch this pod. Kubelet will connect to the runc because pod is for us is container right now, and who launches the container in Docker also, it's Docker D, the runc, right? It will download the image and it will create the container. So what it will do, it will see is this image available locally. If it is not, it will download and then it will create a pod for you, container for you. Okay, so what is the role of scheduler? The role of scheduler is it will decide where to launch the pod, and factor that affect the decision is like what is my CPU utilization, what is my memory utilization, what is my storage, node labels, taints, tolerance, affinity, anti-affinity, pod priority, these things that we are going to learn. Okay, but it decides where to launch the pod. Okay, run says same container runtime. I can say container runtime. Okay, run is nothing but container runtime like Docker D. Okay, run is nothing but container runtime like Docker D. All right. There is another component that is known as controller manager. Controller manager, I will tell you with an example. Okay, you know auto scaling group, but controller manager is not auto scaling group. Okay, don't get confused. I'm just giving you some analogy. The role of controller manager. When say for example you have an auto scaling group and you have decided that you are going to run with 2 EC2 instances. Okay, this is one EC2, this is another EC2. Okay, so what we mentioned that my desired count is equal to 2. that I need 2 EC2 instance. What is my current status? This is my desired status. Current status is what? Current status is also 2, right? Currently, how many instances are running? 2 instances are running. And what is my desire? It is also 2. Is current status is equal to desired status? Desired status is equal to current status? Yes, it is. Right now, current status is equal to desired status. So, auto scaling group will take no action. When current status is equal to desired state, it will take no action. Alright. But at any point of time, if one of the EC2 instance, say for example, got deleted or terminated, is current state is equal to desired state? Answer is no. Desired state is 2, but current state become 1 if one of the instance get deleted. In this case, what will happen? Auto scaling group will kicks in and it will launch one instance for you. The moment it will launch one instance for you, everything will become the same, right? Current status will become desired status, auto scaling group is happy, and everyone is happy, right? But the point here is to understand how it works. When this mathematics changes, whenever desired state is not current state is not equal to desired state, auto scaling group will come into the picture. Okay, in auto scaling group or something like in this kind of situation, we have something known as desired state. Desired state is like this much of instance I want to running at any point of time, at every point of time. This much of instance I need to run my application. That is known as desired state. Then current state is like actually what is the actual status. Okay, this is your desire, this is your wish. Is your wish equal to the current status or not? That is what known as current state and desired state. Right now in this case, current state is equal to desired state. Yes, it is, because both are 2. If any instance got deleted because of any reason, okay, if this instance got deleted, how many instances running right now? What is the current status? 1. What is my desired status? 2. Is my current status is equal to desired status at this point? No. Whenever this situation comes, then auto scaling group will launch one more instance for you. Okay, the moment it will launch one more instance for you, this mathematics, this is again holds true, then you are good. This is how controller manager also work. Okay, what it will check, say for example, here how many container or pod I want to run for login? 1, 2, 3, 4, 5, 6. This is my desired state. I'll say this is the desired state. If any of the pod or container got deleted, then controller manager will kicks in. It will say, okay, this is got deleted. Then controller manager will say, inform to the Kube API server, this is got deleted. Kube API server will ask scheduler to go and launch one more pod. It will again go and check all the 3 instances, and out of 3 it will identify, say for example, the first one. Then the scheduler will say, hey, Kube API server, you can launch the pod on the first one. Then the Kube API server will connect to the kubelet will connect to the runc, and runc will launch your pod. Okay, so what is the controller manager role? It will keep an eye on over the resource, like what is my desired state. We will define in a file. Okay, we'll define the configuration, and everything will become clear as I'm mentioning with an example. All right, so where we define, how we define, you will get to know that. We will define in a file. So what is this controller manager? It ensures that desired state is maintained. Just ensures the desired state. All right. There is one, and don't worry about this thing as I'm mentioning again and again. It will become clear, crystal clear. Believe me, if you can trust. Just give me 10-15 minutes more. When I'll install a Kubernetes cluster, I will show you everything running. Then you will figure it out what I'm trying to say. Just by word, it is little difficult to explain. But if you can give me 15 minutes more, it will become clear. Okay, we are done with 1, 2, 3, 4, 5 component. Okay, and the 6th component is etcd. Etcd is a database. It's a key value database. It basically stores the status of all the components that are running in Kubernetes. Store the status of Kubernetes cluster, store the status of pod, store the status of node. Everything is getting recorded here inside this database. Okay, cluster name, cluster configuration, everything getting stored here in etcd database. So etcd database is basically, you can say, it's a highly available key value data store. What is the cluster state, what is the configuration, what is secret, everything, what is deployment services, all the objects of Kubernetes, everything getting stored here. So you right now you can just say like stores all the cluster state and data. Stores all cluster state and data. Okay, everything will get stored here. Okay, what is this kube proxy? Kube proxy is basically step, I can say kube proxy is basically helping in Kubernetes networking. Okay, for Kubernetes networking. What is meant by networking? Any communication, like kube API server connects to kubelet, kubelets connect to runc, controller manager connects to kube API server, etcd connects to etcd, kube API connects to etcd database. All this communication, node to node communication, object to object communication, everything is handled by kube proxy. It helps in establishing all this networking. How part we will see, okay, we will discuss about Kubernetes networking in detail. Then we will see what is this kube proxy. All right, so we have, as of now, we understood, okay, there are 7 components in Kubernetes. One is like control plane, that is a master that takes all the decision. Master has 4 components: kube API server, controller manager, scheduler, and etcd. And data plane has 4 components, 3 components: kube proxy, kubelet, and runc. We have kind of a high level understanding of all these roles, like what are these roles of these components, right? This we understood. Now we are going to discuss about first thing, what is pod, okay, and how it is different from container, okay, and then we will launch a Kubernetes cluster. And once we launch a Kubernetes cluster, then we will understand, we'll go through this diagram one more time, okay, with an example. Then you will get all your answers. How we place the desired state, where we place, how it works, how scheduler going to check, everything you will get crystal clear, okay? What is pod? So philosophy. So this is what philosophy, but philosophy of what? Philosophy of containerization. Containers. Okay. So what is philosophy of container? We just try to understand when we discuss about container. Okay, we started discussing something like from here, right? We want to, this is very interesting, please listen it, because I have seen people not explaining this, they are just telling the definition of pod. That is really bad, because they are not explaining the actual reason. We started our discussion like this. We want to run this code, right? We want to run this guy. We have seen, okay, you can run this guy on a physical machine. Is it good? No, because we are wasting our resources. Can we run this on virtual machine? Yes, we can run, but we also discuss about some pros and cons of it. Then we decided, okay, there is something known as containerization container, where we'll have app and just the dependency. App means one microservice, right? In our case, it's one microservice. But what is microservice? It's a business logic, right? It's a business logic, nothing else, right? How people will log in, how the UI will look like, they will get user ID and password, menu, how the menu will look like, what are the things that we need to code. Basically, we are coding the business logic, nothing else, right? Okay, so container philosophy says that you will code one business logic in one container. What is philosophy says? What is the main funda of container? You should code one business logic. I can say BL. Okay. Can I code multiple business logic in a container? Yes, of course. Why not? Nobody is stopping you. But your container or microservice will say, for example, just in our case, If we want to identify my login application, this is my login. Okay, this is my login application and I am coding. This is my container of login application. This is a code and I have created a container, Dockerfile, Docker image. Now container is running. Okay, that is going to tell. But I'm a coder, I can code it. But somebody from the business, somebody from the who owns the business, they also want to know the sales of their pizzas. Like they are getting how the pizza are getting sale over different part of India. Say for example, somebody in Delhi, somebody in Bangalore. How the pizza is going to sell? What is the sale in Delhi? What is sale in the in Bangalore? If Delhi people are eating less pizza, they are ordering less. Then we have to give them some promotion so that they can start off order more pizza and we will make money. Right? For that, I want to also collect their name, their location, their IP address. Okay, all those things also I want to collect. And this is my just login program. What it will do? It will give user, what is your username, prompt for username and prompt for password. That's a very simple program. Can I put this logic here also? Yes, you can. Definitely you can. But your program will become something like this, right? This is not going to be the same. You are running out multiple business logic in the same container. You are actually moving from microservices to monolith kind of approach, right? Microservice only runs login, nothing more than that, nothing less than that. Menu will run just menu. Okay. Apart from that, it is not going to run anything. But I also want to run my business. Okay. If you are saying that this is not, you should not do this because the whole idea of containerization is defeated. But what about business? So people invented a solution. Okay. They say, okay, fine. Let's do one thing. Let's run your container inside something known as pod. This is your login container. And if you need any further information from login to do some processing or something, run one more container inside the same. Okay, this will say for example a dependent container, or I'll say C2. Okay, so a pod is something we call atom of Kubernetes. Okay, it is an atom, means smallest unit, electron, proton, neutron. I know atom can be further broken down, but atom, just keep it as like a smallest unit. In class 9th or 9th standard, we studied atom is the smallest unit, and in class 11th we studied atom can further be broken down into electron, proton and neutron, right? Now it's all wave. If you're still studying physics and all, I mean, they say there's nothing like electron, proton, neutron, they are all waves. Okay, but anyways, that's a different discussion. So that is what the atom, it's the smallest unit. So in Kubernetes, we don't create container, we create pod, and pod can contain one or more container within it. Okay, most of the time, 90% of the time, you will see pod will contain only one container. But sometime if you have some dependency that in output of one pod is going to act as an input for another pod, another container. If output of one container, okay, is going to act as an input of this container, in this case, you can run in a pod, in the same pod. Because I cannot put the same logic here, my container size will increase. The whole idea of containerization is defeated. So in order to avoid this, in order to follow the philosophy of container, we can do this. Okay. So in Kubernetes, we don't directly create container, we create pod, and pod will create a container within it. Can pod will always run multiple container? No, it depends. It depends upon the use case. If I have some dependency, in that case, I can run 1 or 2 or 3 container within the pod. But most of the time, it is going to run a single container. Okay. Because if we run all the business logic in the single container, my container will become like this. And I don't want. What is the purpose of making container a huge machine, right? The whole idea of containerization, one business logic, one container. That's it. That is what the philosophy is. Are you folks getting it? So what is the definition of pod? Pod can have multiple container within it. But is it necessary to always have a multiple container within it? No. It depends. So pod is the smallest unit of Kubernetes. We don't deal with container, we deal with pod in Kubernetes, but pod actually my application is running in container, same thing, but there is one more layer on top of it that is handled by Kubernetes. All right, with this, we'll go and launch a Kubernetes cluster. Launching Kubernetes cluster, there are a couple of ways. First way is known as something Minikube. Okay. Second is something like you can have a physical machine or VMs. Okay, where we'll have, where VMs like EC2 instances, you can go and launch your Kubernetes cluster. One EC2 instance you can make as a control plane or master. One you can make as a data plane, and you can join this in the form of cluster. Okay, this will become your Kubernetes cluster. Another way of launching Kubernetes cluster is something known as managed Kubernetes. Managed Kubernetes cluster, that is, we are going to study AWS EKS. What happens in managed Kubernetes cluster, this control plane is not handled by you. It is handled by the vendor, the cloud provider. They will maintain a, why is it so? Because you are again interested in your application, your code, your app is running here. This is something, is an infrastructure work. Maintaining the high availability, maintaining everything is a cloud vendor responsibility. We even don't know where it is running, how they are running, but we will get access to this where we want to run your application. That's it. And that is the most suitable form of running Kubernetes cluster, because if you are going to maintain your Kubernetes cluster, you have to maintain the high availability of your master. Why? Because if this EC2 instance goes down, your control plane is down, right? Your control plane is down. So you have to maintain this. Instead of running your application, your main focus will be maintaining the infrastructure. Okay. So most in cloud, we prefer this. It's most widely used. We don't do this. Minikube is a test bed, or a, you can say, test or for learning purpose. It's a single node Kubernetes cluster. One node Kubernetes cluster. Same node will become master. Same node will become controller, data plane. Same node, single node. Why? Because for learning, I mean, no need to invest, launch two EC2 instances and see what is going on. You have to pay for two machines. Here you can, one single node, you can launch Minikube on your desktop, laptop, EC2 instances, anywhere. Okay, so it's a very simple to install, simple to manage, and it's only for test and learning purpose, not for deployment of your production workload. Okay, so we will start with this and we will move here. Okay, these two things we will cover. With Minikube, I will solve this one, like how it works and all, or we can directly start with EKS, that's not a problem, but I'll show you how to launch a Minikube cluster also. Minikube. So for Minikube, there are three simple steps. It's one of the easiest way to install Kubernetes. First step is install Docker. We know how to install Docker. Okay. Then you have to, second step is install kubectl or kubectl, whatever you want to say, and install Minikube. Third step is install Minikube and start it. Installation of Minikube is very simple. Okay, I mean, you just need to download it. That's it. Okay, you need to download Minikube. Okay, that's it. Installation of kubectl is very simple. You just need to download it. All right, that's it. Okay, but what is kubectl? First, let's understand. Kubectl or kubectl is a command line utility. It's a command line utility to connect to Kubernetes cluster. To connect to Kubernetes cluster. But how we can connect to the Kubernetes cluster? You can connect to Kube API server only. Okay, you can connect to this guy only. So what you will do at your desktop, laptop, or whatever your machine, you will install kubectl and you will connect kube API server using kubectl. Okay, so that is also required. If you want to connect your Kubernetes cluster, you want to deploy your application, you have to install kubectl. So it's a command line utility. It's a client software. Okay, if you are connecting to facebook.com, right, you are opening replication facebook.com, what you do at your desktop, you have a client software, right, Firefox, Chrome, or anything. That's the client software. Similarly, that's a GUI base. Okay, that's a graphical user interface. Similarly, this is a client software that we need at a client machine to connect to the server. Using Firefox as a client software, you are connecting to Facebook, Google, but those are the applications that are running somewhere else, right? We are connecting via client software. Similarly here, okay. And if you go to my GitHub, this is Kubernetes workshop. You can have Minikube installation October 2023 file. Okay, here I have given you a step-by-step documentation like installation of Minikube. Okay, installation of Docker. We all know how to install Docker. You can just apt get Docker IO. That will also work. Okay. Once this is done, this first part is installation of Docker. Installation of Minikube. How to install it? We just need to download it. wget will download. Okay. This is the location where Minikube is available. You can just download it. wget is a command to download. Once Minikube get downloaded, you need to copy to this location usr local bin. So what I have done, I have already ran this command to just because it takes some times to install cluster. And don't worry, because don't think that I'm not showing you how the installation. I will show you detailed installation of EKS. This is just a test bed. You can follow this documentation, download it, copy it into mini usr local bin and make it executable. Minikube is installed. Similarly for kubectl, you can download it with curl command. You can make it executable and you can move it to the usr local bin. When these three steps are done, you need to start Minikube. Just Minikube -- start. Minikube start -- driver is equal to Docker. So let me just log into one of the machine. So let me show you. Just copy this command. So what I have done, I have already downloaded and run this step just to save some time, and you can start Minikube. Minikube is not installed. Okay, fine. So in this machine, Minikube is not installed. That's a good thing. Let me see Docker is installed. The Docker is already installed on this machine. Let me see anything running here. Docker ps. Okay, let me can sudo su Docker. Let me say Docker ps. Docker ps -a. There are two containers. So what I will do, I will delete all these things. And say Docker system room -all. I'm just cleaning my system so that everything get deleted. So on this machine, okay, on this machine only Docker is installed. Okay, this step is done. On this machine only Docker is installed. We know how to install Docker, right? We have so we'll install from Minikube. So what I will do, I'll first download Minikube with the wget command. You can say it got downloaded 10%, 16%, 20%. It is downloading it. With the command line you are done, just like you are downloading on your browser and exe file get downloaded, something like this. Okay, we are just downloading from the command prompt. I'm copying the Minikube and then I'm making it is executable. Okay, sudo this one. All right, now we'll install kubectl. So we'll copy this command and we will run this command. Kubectl downloaded. You can see it's pretty simple to install Minikube. Just it will take 5-7 minutes and your cluster will be ready. Okay, I'm making it executable and I am moving it to usr local bin. Now you have to add your user to Docker group, otherwise you will get a problem. So add your normal user to Docker group. Now you can start Minikube cluster. All right, so Kubernetes cluster is going to start. But this is for Minikube. And what is the use case of Minikube? For learning and test purpose. Okay, we don't deploy a cluster to production, like production one will see. Okay, because I want you first to little bit familiarity with Kubernetes. Then we'll see how do we deploy in Kubernetes production one. All right, so Minikube cluster got created. If I want to run kubectl command, so you can just say kubectl and press enter. Okay, so you can see this is the sum of the verbs, like any kubectl command, just like any command will run something like kubectl, okay, plus some verb. And what are the possibilities of verb? These are the possibilities of verb, some basic commands. Okay, these are the verbs, like one line explanation of these verbs. Are we going to run all these commands? The answer is no, because even I have not run all these commands in my life, because some of the commands that we are going to run, some of the commands, if required, we will see and run. Okay, we should know how to run it. The main thing is here, you should know how to run this command, how to get help. Okay, so we will see some of this command: beginner, intermediate, and deploy commands, cluster management command, troubleshooting command, all those things. Most of the commands we are going to see. All right. So this is Kubernetes cluster got installed. Now, if I want to see, and there is one more document that you can refer, is kubectl. Quick reference, not cheat sheet. This document is also very good that you can refer for kubectl command. So it's a kubectl help page, how to run a kubectl command. There is something known as kubectl autocomplete. Autocomplete, like in Linux Bash, if you press tab, your command will automatically get complete. You can type some character and press tab, the command will automatically get complete. That feature you can enable here in kubectl also. You can just need to source it. Okay, you can go here and just run this command. Why I'm doing it? Because my life will be a little easy. Source, and I just type some initial of command and press tab, my command will automatically get completed. That is, here we'll go and run it. Alright, so this you can do, and in this document also it talks about all the Kubernetes commands, like kubectl command, a lot of commands, like what are their use cases and all example that you can refer it later. Okay, that you can refer it later. All right, so let's see the status of our cluster. So command is kubectl. Okay, kubectl get. What is get keyword? Get is a keyword for listing down anything. Say for example, you want to, if you go here and search for kubectl basic command, line number 897, what it says, get says display one or many resources. What are resources in Kubernetes? Resources in Kubernetes is something like node is a resource, pod is a resource, and we are going to create so many other type of resources. So we will see how to create resources. So if you want to list down those resources, command is kubectl get. I want to get nodes. How many nodes I have? Kubectl get nodes. I can see I got this output. The name of the cluster is this. I have only one node because it's a Minikube. It says control plane, and it's just got created 5 minutes before, and this is the version of Kubernetes that is running here. Similarly, if I go and say kubectl get pods -n cube -system. What is this -n cube -system? Don't worry, I will explain you. But I just want to list down the pods. Can you see that there are pods running? There is something known as etcd pod is running, API server is running, controller manager is running, proxy is running, scheduler is running. There are some add-ons are also running that I mentioned, that there are a few other components, but main component we can see, right? etcd, API, scheduler, controller manager, all these things are running here. Okay. because the same machine is acting as a control plane, same machine is acting as a data plane. It's a single node Kubernetes cluster. Okay, now, okay, fine, this is all good. Now the question here is, I will run some lab, okay, I will run some commands, and first we will understand this diagram one more time. Okay, this diagram one more time. For that, I am going to create some resources in Kubernetes. I need to explain something. Resources in Kubernetes, or sometimes we call objects in Kubernetes. There are two ways we can create objects in Kubernetes. First, we call imperative way, and the second way we call declarative way. Imperative way is something like over the runtime, like run with the command, and over runtime we create the objects. Declarative way, what we do, we declare everything inside a file. Okay, that file is in the YAML format. Okay, and then we run this file. We create object, we run this file, and the object gets created. Which one is better approach? Better approach is this. Why? Because here we are defining everything, what we are doing, why we are doing. We are writing a file. We are writing all the configuration inside a file, and we are running it. So in future, if I want to see what I have done, I have a reference material. If I have to modify and run anything, I can go and modify the file and rerun it. So that is kind of an easy way of management, right? Easy of managing the things, because this is something kind of a, very if in future, if I have to documentation also I'm maintaining. Here is something like on the fly, and the command directly I'm creating. We do imperative way of creating an object when for one, if I have to do something for one time or something like that, we can do it. We will see both the things. First, I am going to run the declarative way. I am going to write a YAML file for creation of pod. Okay, and don't worry about this YAML file. I will explain each and every line of it. First, let me run some lab so that I can explain this diagram to you one more time. Okay, so I'm going to create a pod, and I will show you how Kubernetes maintain all those things. I'm creating a file, say for vi pod.yaml, and I'll create a file. This is the code, and don't worry about it. It's very simple. It's very simple English. Okay, and we will see. So first, let me create this file. I'll go here and say vi there pod.yaml. I'm defining everything inside a file. Okay, and saying file is here. Yes, file is here. Pod.yaml is here. I need to apply this file, so we'll say kubectl apply. Okay, and we will kubectl apply -f, name of the file pod.yaml. Okay, before that, let me, I press Control C. I have not run this command. I want to see kubectl get pod. It says no resources found in the default namespace. Just remember this error message. Not error message. This is not error. This is just a message. Let me apply this file one more time. I mean, apply it first time. Kubectl apply pod.yaml. It says pod got created. If I go and run the kubectl get pod command, I can say it is creating in the creation state, still creating, because I think image is getting downloaded. And if I go and run it again, it says running. All right. So let me paste this command. So what happens here when we run kubectl apply pod.yaml command? Okay. Let me explain you what happens here. This was the file pod.yaml. How this file is written, what is inside the file, just ignore it for a few minutes. Okay, because we are going to discuss in detail. Pod.yaml is here. When we run this file with the command, kubectl apply -f and the name of the file. When we run this command, what happens? This command is getting converted into an API request. Okay, and this API request is reached to the Kube API server. Remember, we can connect to the Kube API server only. When the Kube API server see this and it got to know that, okay, this guy want to create a pod. Okay, this guy want to create a pod. But where to launch this? In this case, we have only one node Kubernetes cluster, so we have no choice. But still, Kube API server will go to the Kube scheduler. Okay, and it will say, scheduler, I want to launch a pod. Can you let me know where I should say, for example, there are two nodes. Okay, then the scheduler will say, okay, wait a minute, let me run my algorithms here, let me run my algorithm here. Then it will come back and say, this is node number 1, this is node number 2. It will say, hey, Kube API, node number 2 is better to launch the pod. Then it will say, thank you, Kube API. Let me connect to the kubelet of that node number 2, and it will say, hey, kubelet, go and launch the pod. Then kubelet will say, okay, let me instruct the runc. Runc will say, okay, let me launch the pod. Okay, but which pod? Pod will contain container. Okay, which container? Let me see what container you want to launch. Just I'll show you this YAML file. Let me remove all those things. I want to launch a Nginx container using Nginx. I'll explain you this syntax and everything. But here it is very clear that I want to create pod. Pod will contain a container. Container has for container we need an image, and this image is Nginx image. So then what will happen? Kube API server will go to the runc. Runc will download the Nginx image. So that is why it was showing creating right earlier. So let me explain one more time with this diagram. So what happens? We ran kubectl apply command. Where we ran kubectl apply command? We ran in our desktop. That request converted into an API. It hits the Kube API server. Kube API server reads this API, understood, okay, this guy want to create pod. Scheduler, where should I launch the pod? Let me tell you. It will go and run the algorithm on all the nodes and come back. Node number 2 is better to launch the pod. Okay, thank you. Kube API server will connect to the node number 2, kubelet. Hey kubelet, launch the pod. Okay. Runc, launch the pod. Okay, let me download the image and pod created. Are you getting it? How these things are connected? Alright. And don't worry about the revision. We are going to repeat it 100 times. You will get it. Okay. So what happens whenever we run this pod.yaml, request will convert it into an API. This API request is like, same like, when you run Docker command, the Docker command get, converted into what? The Docker command get converted into an API. An API is handled by Docker. So here your API request will go to the Kube API server. Kube API server, whatever you mention, in this case, I want to create a pod. Okay. Now this pod, who will decide where to create the pod? Then the Kube API server. Here, a couple of things will happen. First step, Kube API will connect to scheduler. Okay. First thing, and say I want to launch a pod, and where should I launch the pod? Scheduler will say, scheduler will identify the place, right? This is what I mentioned, right? What do I mention here? Where to place the pod. Who will decide? Scheduler. It will identify the node where to place. Then after that, what will happen? Step number 3. Kube API server will connect the kubelet of that node. Okay. Then kubelet of that node, step number 4, kubelet of that node connects to runc of that node. Okay. So then runc of that node will launch the pod. So this is how it runs. Now let me tell you one more thing. If I go is the pod is running kubectl get pod, the pod is there, okay? And if I want to say kubectl describe pod and the name of the pod. Pod also you can write PO, it's a short form, it will work. Okay. Can you see that there's a detailed information about the pod, like what is this container, what is the ID, what is the image name, everything is like so much detail. What is the command? kubectl describe. We have described it. Okay, all those detail about it. You know where this information gets stored? etcd. All this information getting stored at etcd. This is what I was saying. Stores all the cluster and information, cluster and configuration, cluster state and configuration. All right. Now let me show you one more thing. Say for example, this pod got deleted. Let me drag it little here. This is basically how kubectl works, that you need to understand. Okay, how commands work. All right, so let's go here, and I have a pod, kubectl get pod. We have little bit of understanding of some of the component, little better understanding. And this is the pod. Let me delete this pod. How to delete it? kubectl. Delete is the verb here. I want to delete pod, but which pod? This is the name of the pod. You can see this is the name of the pod. I will delete this pod. Okay, the pod got deleted. Yeah, just imagine this is not deleted by me, but just because of any reason it got deleted. But the pod is not getting launched by itself, right? It is got deleted, but it is not getting launched. And I told you that Kubernetes will maintain your desired state. All right. So desired state was one, like I want to launch that pod, but something happened and the pod is not getting created by its own. So this is where we are going to learn another object in Kubernetes that is known as replica set. Okay, first object that we have learned is pod. Pod contains container within it, and we have seen that yes, it contains a container, and I will explain you this YAML in detail. Here it's contain a container and it uses the Nginx latest image. That is from this, even I don't understand the syntax, but with a simple English I can say yes, it uses an image and it is running a container within it. All right, now the pod got deleted. There is another object that we call replica set. So another object we are going to study is replica set. Okay, so second object is replica set. Okay, let me create a replica set. If I go here, we'll say vi nginx-replica set. Let me also create here. And copy the code. Don't worry about this code, okay? I want to create 3 replicas of the pod. My desired state is 3. You can see 3 we mentioned here. 3. Okay. The file is there. Yes, the file is there. Replica set YAML is here. How to apply this file? kubectl apply is a command, and you have to give them path and enter. It says yes, replica set got created. Now if I go and see kubectl get pod, can I see that 3 pods are running? 1, 2, and 3 pods are running. Why 3 pods are running? Because somewhere in our configuration we specify that my desired count should be 3. We have mentioned that I want to launch 3 copies of the application. And don't worry, I'm telling you again and again about this file. I will explain you. Okay, I will explain you. First, I'm telling you the working, how it works. So I have 3 pods running. What is my desired state? 3. What is my current state? Is 3 pods are running. Is desired state is equal to current state. Let me delete one of the pod. What is the age right now? You can see 56 seconds. Let me delete one of the pod. kubectl delete pod and the pod. Pod got deleted. 7HVQVK something got deleted. Yes, got deleted. Let me see how many pods are running. Oh, still 3. Just there's a one new pod that just got launched 7 seconds before. QMMNS, this pod is there. Yes, this pod is there. W4NB, W4HNB, yes, it's there. 7HVQK is there? No. Another pod get replaced. Oh, somebody launches the pod for me. That pod just created 7 seconds. Why somebody launches the pod for me? Because my desired count, my current count was not equal to the desired count. What happens here? Let's try to understand with the diagram. The moment the pod got deleted, controller manager kicks in. Hey, desired count is not equal to the current count. Current status is different. Then Kube API server, okay, let me ask scheduler to launch a pod for you. Then it will say, hey scheduler, can you launch a pod for me? It will go and run the algorithm and say, this node is good to launch the pod. Then the Kube API server will connect to the kubelet. Kubelet will connect to the runc. Runc will download the image, or if the image is already there, it will launch a pod for you. Everything happens so quickly within few millisecond, and everything happens internally. Okay, it's not auto scaling, by the way. It is controller manager will always desire state and something. Auto scaling is different concept. I given you this analogy to understand the concept. Okay, I mentioned very clearly, controller manager is not auto scaling. You got how controller manager works? Kube API server, etcd, kubelet, runc, scheduler, controller manager. Is it clear? Out of 7, 6 objects are clear. Okay, so actually we don't create the pod directly. Okay, we create do we create replica set directly? No, replica set also has some issue. We will see another object type. Okay, third object type that I'm not going to name here right now. Okay, that is going to solve one more problem. Okay, what is the problem with replica set? Which object solve that problem? We will understand that. Once we'll understand these 3 objects, then I will explain you this YAML file in detail. Okay, once we understand the YAML file, then we'll move ahead with the Kubernetes networking concept, how networking works in Kubernetes. Then we will understand storage concept in Kubernetes. Then we'll understand some more objects in Kubernetes like config map, secret, okay, roles, role binding, cluster role binding, and then we'll understand the concept of namespace. Then we will launch a real world application. Okay. kubectl, whenever you create a file, what is the structure of this file? You will see this file is in YAML language, and we will also see this YAML in few minutes. Okay, what is this YAML, how to write YAML and all. But whenever you write a file, say for example I have written a file, then we will run kubectl apply command. This kubectl apply command, the moment you run kubectl apply and the file name, okay, this will get converted into an API request. It's an HTTP REST API, HTTPS protocol. This will go to Kube API server. Kube API server will read this, because all this information, whatever we have written in file, it will get baked inside this API. Kube API server will read all this information and try to figure it out what actually you want. In this particular case, we want to create a pod, because the file has written like pod.yaml to create a pod. Okay, pod runs container. Okay, so it means we want to launch actually container. All right. So Kube API server will prove if I have multiple EC2 or multiple VMs as a worker node. Say for example, I have one worker node, I have say 2 worker node. Then where to launch this pod? On this worker node or on this worker node? Who will decide this? This is going to decide by scheduler. How scheduler decides this? It runs so many algorithms, not as a so many, but it runs a couple of algorithms, and based upon this, it decide like what to do, where to launch the pod, which node is best suitable to launch this particular pod. It will just identify the node. Okay, it is not going to actually launch the pod. The moment it will identify the pod, it will inform to the Kube API server. Then Kube API server will connect to the kubelet of that node. Kubelet of that node will connect to the runc, and runc is actually going to launch the pod. That is container within it. Okay, so this is the whole process. This is going to be fine. Then we discuss created a pod, we created a replica set, and we see how this communication we try to understand, right? This diagram we try to understand. Let me copy this diagram one more time. We will go and discuss a couple of times so that this diagram at least should be clear, crystal clear in your mind. All right, so let me just log into my instance. This is my instance. So this is where we have installed Minikube. Okay. So whenever you stop your machine and so whenever you stop and start your VM, you have to always restart your Minikube. Okay. So what was the command that we have used? What I'll do go to history and I'll grep for Minikube. So you can see this is the command we have used, right? Minikube start -- driver is equal to Docker. So this command you have to run it. Whenever you log in, stop your machine and start it, start Minikube program. This will turn your Kubernetes cluster. You can see it's again starting the Kubernetes cluster. You know, actually what is happening here, if I tell you, you know which driver we are using here? Which driver we are using here? Docker, right? You know what is happening? I mean, ultimately in Minikube, how container is running? It is creating a Docker container, and within Docker container, Kubernetes is running. This is what is happening. Because it's a test machine, right? We can containerize anything. So we have containerized Kubernetes cluster, but don't get confused. I don't want to confuse you. But here in this Minikube, in our setup, we are running Kubernetes cluster inside a container. That is what Minikube is giving to us. We can use Minikube driver is equal to Docker. We can use driver is equal to Oracle VirtualBox. We can use so many driver. Okay, even you can run container using Kubernetes in Oracle VirtualBox deploying Minikube. But we are using simple Docker. It's very simple to install because we just want to learn some concept. Then we will move production grade cluster, that is EKS. We are going to launch EKS. EKS is what? EKS is a Elastic Kubernetes Service. Oh, why it is dancing? Elastic Kubernetes Service from Amazon, AWS. Okay, that is why I don't want to tell. But this is in this particular setup. Kubernetes doesn't depend upon Docker or something. In this, because you can containerize anything. So we are running Kubernetes inside a Docker container. In this particular setup, I'm telling you again and again. Here in this my setup. This is the way only. No, this is not the way. We don't run Kubernetes like this because we are learning some concept, so that is why. All right, so our Kubernetes cluster is ready. If I do kubectl get nodes, you'll see I have a Minikube single node cluster is ready. Just keep this output somewhere so that when we launch multi-node cluster, I will compare this. Okay, so this is my cluster is ready. Now let me see, is there any pod running? Kubectl get pod. Yes, I have 3 pod running. Why there are 3 pods running? Because we have written a file for replica set. Which object we have created? We have created replica set. Okay. If I do kubectl get replica set, so I can see that I have, this is the replica set. Okay. In this, you can see this particular output. You can see kubectl get replica set. Just like pod is an object, replica set is also an object. Okay. And it says I have 3 as a desire, 3 as a current, and 3 as a ready. Because my desire count was 3 pod are running. So that is why no need to, controller manager. Okay, controller manager is not going to kick in because right now desire is equal to current. All right. If I delete any of this pod, right now I have how many pods are running? 1, 2, 3. Let me delete the bottom one, W4HNB. I'll copy the pod name from here. Okay, let's copy the pod name. How to delete a pod? How to delete a pod? Kubectl. Okay, kubectl. What is the verb here? Delete. Okay, but what I want to delete, which object I want to delete? I want to delete pod. Which pod I want to delete? Now you have to get the name of the pod. Are you getting the syntax? Kubectl delete is the to delete any object. Which object? Pod. Which pod? This pod. Okay. So if you go here, what is the syntax for what is delete, 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 delete? Are you able to see delete somewhere? Delete, 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 delete. Here, line number 899. What it says? Delete resources by file name as standard input, resource name. We are and names. We are using this one, resource and names. Okay, so this will go and delete the pod. Okay, so kubectl delete pod name and the pod name and just copy it. Okay, let's go here and run it. It says yes, deleted. Now if I go and say kubectl get pod, I can say I have 3 pod, but this one, the bottom one, W4HNB is gone. We have another pod, VW2SX, and it just got created 5 seconds before. All right. And the status is running. Can I see my replica set status? kubectl get replica set. Yes, it is still 3 desire, 3 current and what. But so when I deleted the pod, current becomes for couple of milliseconds, it become 2. The moment it became 2, who will kicks in? This guy will come into the picture. And there, as I mentioned, there are a couple of types of controller manager. Okay. There are a couple of types of controller manager. Here, controller manager, or the full name is Q controller manager. We call them Q controller manager. Okay. This Q controller manager has couple of types. First type, that is known as node controller, and another type is replica controller, replication controller. Replication. There are a couple type more we will study as we move ahead. Controller manager for replication. It means there is a controller manager for replica, for replica set. Okay. Replica set. What type of object we have created here? We have created a replica set. For this guy, there is a controller manager. Okay. But for pod, there is no controller manager. Okay. Pod, there is no control. So when you directly create a pod, and the pod get deleted because of any reason, because there is no controller manager for this guy, what will happen? It is not going to auto create. You have to manually create it. Okay, so that's the problem with the pod. If you directly, I'm saying problem with the pod, it doesn't mean that we don't launch pod. We don't directly launch the pod. That's the point. We launch replica set. What replica set will do? If you launch replica set, okay, replica set will launch pod for you. Okay, and replica set pod has 2 things: desired state and current state. The moment there is a mismatch between desired state and current state, who will kicks in? This guy will kicks in. Replication controller, and then this guy will go and make sure that you have desired state is equal to current state at always. So that is why the pods are getting launched when they are getting created by replica set. But when you just create the pod, okay, without replica set, if it got deleted because of any reason, then there is no controller manager behind it, so it won't come up. It is now, tell me one thing, it is better to launch pod or launch pod via replica set? Quickly run an example. Okay, so here kubectl get pod. How many pods I am having? Because somewhere in our configuration of, if you look at the line number 999, what it says, replicas is equal to 3. This is key and this is value. Right, this is key, this is value. So if this line says that my desired count is 3, I want 3 pod. That's the meaning of this line, and that is why we have 3 pod running. Right now, if I go and see the pod.yml, this is here you can see in this YAML. In every YAML, we are specifying two things that are important. First one is what is your API version, that object has an API version. So what happens in Kubernetes, there are multiple objects, okay? There are multiple objects like pod, replica set, deployment, service, config map, secret, stateful set. There are so many. We will go and study one by one all of them. But right now we understood two objects, replica set and pod. Okay, so first you need to specify what is your API version. For pod, API version is v1 and the kind is pod. You have second line says what type of object I am going to launch, pod, right? If you scroll it down and go to the second file, here we are saying we want to launch which type of object, replica set. Okay, so we have to specify which type of object we want to launch. So here we are launching pod only and here we are launching replica set. Now, if I just launch pod, okay, we have used this YAML, okay, and let me launch the pod. The file is here. If I do ls, I think file pod.yaml. Let me apply this file, kubectl -f and pod.yaml. If I go and say kubectl get pod, I can say I have 1, 2, 3, and okay, it's not yet created. Pod nginx pod is got created. Pod.yaml, where is this guy? kubectl get pod. It's not getting created. Okay, let me first remove the replica set, maybe. Kubectl get replica set. Let me delete this replica set. Kubectl delete replica set and the name of the replica set. I just want to delete the replica set. Now let me see the pod. You can see I have no pod running in this, okay, because we have deleted the replica set. If you delete the replica set, that means you want to delete that object. Okay, so in that case, the pods are not getting auto created. But when we are deleting just the pod, we are still keeping the replica set. So what is happening here? This is my replica set. It created 3 pod, pod 1, pod 2 and pod 3. For replica set, there is a controller manager which is watching this replica set. It's always watching this replica set. Okay, if any of this pod is just the pod is getting deleted, it says, okay, this guy wants 3 pod. Let me go to the cube API server. Cube API server will go to the scheduler. Scheduler will identify the node and another pod will automatically get created because there is an object that is monitoring this particular object. Okay, so replica set has a controller manager. But if you just create the pod, for pod, there is no such controller manager. If it got deleted, it's got deleted. Replica set will launch pod for you. If you create replica set, automatically it will launch pod for you. You have no need to go and launch pod manually. Pods are managed by replica set. If you want to get rid of this pod, you have to go and delete this replica set, not the pod. Because you are telling Kubernetes that I don't want this replica set. So whatever component replica set has launched, it will go and delete it.
Okay.
The file. I'll come and explain this file. I just want to cover one more object, then I'll cover this file in one minute. Now, tell me one thing. How many of you have, say for example, what would be the process of launching this pod? Okay. Say for example, we have created pod. Okay. For pod, actually pod, what is pod running inside it? They are running container. Right? Pods are running container within it. Right? My container is running inside the pod like this. But in order to create a container, what is required? In order to create container, an image is required. So we have to mention somewhere in configuration of pod that image, container image. For image, what is required? Dockerfile is required. For image, Dockerfile is required. How we create Dockerfile? We create Dockerfile using our code. right? Actually, this is the process. We have a code. From code, we create Dockerfile, and from Dockerfile, we create an image, and we use this image in our pod configuration. Then pod will get created. Pod will create container within it, right? This is the process. And here, say for example, the pods are getting created by one more object that is known as replica set, right? This is what is happening here. Replica set will create pod, and pod will contain container within it. Say for example, in our case, the desired state is equal to 4 or maybe 10. Just imagine this is one pod, it will create 10 pod. Okay, just imagine this is second pod, and there are number 3, 4, 5, 6, 7, 8, 9 between, and this is the 10th pod. Just imagine these are the 10 pod that is created by this replica set. 10 pod got created. Say for example, my desired state is 10. Replica is equal to 10. Those pod contains run apps. If fails the other, right? Okay, so this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pods. Okay. Now tell me, this code has, say for example, this is my laptop, and this code is basically uploaded to GitHub. This code is, say for example, at GitHub. I push this code, and this code is at GitHub. Okay, and this code is written by me, and I posted this, push this git push. Okay, I did git push and run this code. Okay, and the version of this application is 1. Okay, tomorrow if I have to modify, if I have to do git commit, I am working on some bug, I'm working on something, I'm working on a branch, and the bug got fixed, then I did git merge, right? And the version got changed from 1.10 to 1.15 or 1.11, just next version. Just imagine it's 1.11. Then what will happen? That code will get modified, right? If the code is getting modified, we have to create new Dockerfile. Are you folks getting it? Because we have to modify the Dockerfile also. The same Dockerfile is not going to use. Somebody asked this question, how we modify the code and all, right? How to launch a different version of application. So this is Dockerfile we have to write. From that Dockerfile, we have to create new Docker image. Are you folks with me so far? It's making sense? Yes, we have done all these things. We have created Dockerfile, we have created Docker image and everything. Okay, from this Dockerfile, do I need to change Docker image? Do I need to change the pod replica set configuration and specify a different image there? Right? But how actually we are going to do this? Because 10 pods are already running. So one thing what we can do here is we can say, okay, delete all this pod in one shot, Kubernetes kubectl delete replica set, and apply this replica set. It will launch 10 new pod. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Is this a good way to upgrade our application? No. Why? Because there is a downtime. For some period of time, your application will be down. The moment you delete the pod and the new pod will get created, maybe taking 2 minutes, 3 minutes, 5 minutes, I don't know. But for some period of time, your application will be down. Are you folks getting this? So what is the better way of launching this? Better way of launching this is what we can say is, let's do in stages. What stages? Say for example, first I will, from this replica set, I will create first another pod. That pod will be 1_new, the new pod. That means from new code. Okay, just -n I'm mentioning here, _n. Just this is from this particular image. The moment this pod is up and running, what I will do, I will delete one of the old pod. Then what I will do, I create the second pod from this image, 2_n. Okay. The moment this pod is up and running, I will go ahead and delete the second pod. So on and so forth. In stages, what I do, I'll launch one new pod, I'll delete one old pod. I'll launch one new pod, I'll delete one old pod. I will keep doing this exercise till I have replaced all the 10 old pod. I will launch the 10th new pod, and I will go and delete the last 10th old pod. Is this a better way of upgrading the application? Launch one new, delete old. Again launch one new, delete old. Again launch one new and delete old. right? This is known as rolling update. This in this fashion, this is known as rolling update. In this case, there is no downtime, but you cannot delete the old part because it will get launched by itself. Yeah, but I cannot do this manually. Manually, sure shot, I cannot do this. But this phenomena is known as this concept is known as rolling up. What is rolling update? You got it. Rolling update is like you create new version of application in stages in some percentage and delete the same percentage of the pod from the old configuration. By rolling way, you can upgrade your application. This facility, this feature is not available with Replica Set. This rolling update feature is available with something known as deployment. Deployment is another object in Kubernetes. That is, what is this? Is an object in Kubernetes. What is the difference from Replica Set? Deployment has feature like rolling update. It will do it for us. We don't do it manually. It will do it for us. I will show you how. Okay, first of all, when you create a deployment, okay, when you create deployment will create a replica set for you. Okay, and replica set will create pod file. This is what we do in Kubernetes. We don't create directly pod. We don't create replica set. We create deployment. This is where from we start in Kubernetes. Okay, but people just directly teaches deployment, and that is sometimes very confusing. You should understand why we are not directly using pod, why we are not directly using replica set, and why we are using deployment. Because deployment will create replica set, and we know that replica set will create pod for us, and pod will get created. But what extra deployment is offering? This rolling update. Let me show you. I have a replica set. Let me see kubectl get rs. I think I don't have replica set, right? We have deleted it. Let me apply this one more time. We'll say kubectl apply -f in the replica set. Replica set got created. Let me see kubectl get rs. Yes, it is there. I want to describe this replica set. I want to see the detail of it. I'll say kubectl describe replica set and the name of the replica set. I can see this is the detailed information of replica set. From where this information is coming? Who is storing all this information? It's CD, right? So can I see that yes, name is equal to replica set. What is this namespace? Don't worry, we will discuss. Selector, labels and all. So it says 3 current, 3 desire, pod, 3 all looks okay, but there is nothing like this. Just remember this one, okay? Just this one, okay? What we are going to do, we are going to delete this replica set and we are going to create deployment. I just want to keep this output so that I can show you something. Now what I will do, I'll delete this one. kubectl delete replica set. Which replica set? Name of the replica set is nginx-replica set. I have deleted. Okay. All right. So let me create a deployment.yaml. I'll go here and create a file. I'll say nginx-deployment.yaml. Sorry. Okay, so I'm creating a deployment.yaml. What is this deployment.yaml? Don't get confused, okay? Everything is simple. I will explain it. Just ignore this file for a minute. Let me copy this file. Go here and create the file vi deployment.yaml. After this, we'll learn this file, okay? We'll learn YAML and we'll learn this syntax of this file, on this file. So we have a deployment.yaml. Let me see kubectl get pod, nothing is running. kubectl get replica set, nothing is running. Theme, right? Now let me apply this deploy. What is this? Deployment.yaml. How to apply this file? kubectl what? Next, what is the next command? How to apply this file? kubectl. What is the verb here? Apply, right? Apply and -f. Name of the file is nginx-deployment.yaml. Yes, it says something got created. It says deployment got created. All right, let me copy this file. Moment we apply this, we got this message. Now let me show you something. kubectl get replica set. Oh, replica set got created, right? We have not created it, but it got created. Can I see kubectl get deployment? Yes, a deployment got created. So first this deployment got created. This deployment created this replica set. You should always follow. You need to make sure that this deployment has created this replica set. You can see the name. What is the name of deployment? Nginx-deployment. What is the name of replica set? Deployment name plus some random character. But it will always contain the name of the deployment if it created by a deployment. Now if you see the pod, kubectl get pod. Yes, there are 4 pod. What is the name of the pod? Deployment name, replica set name, and last is the random character. Every pod will have a deployment name, replica set name, and the last 4 or 5 characters are random character, 5 characters. Deployment name, replica set, some random character. Deployment name, replica set, some random character. Have we created this replica set? No. What we created? We just created the deployment. Deployment created this replica set created these pod. Why there are 4 pod running? Because replica is equal to 4. So my desired state is 4. How this naming convention will follow? This is very important. Sometimes you have to remember these tricks in troubleshooting. Okay, so deployment name, replica set name will have what? Deployment plus some, I'm just mentioning some random characters. 1, 2, 3, 4, 5, something like this. And pod will have replica set plus deployment. Are you getting? So you have to remember this naming convention as well. So pod will, deployment will create replica set will create pod. If you delete pod, who will kicks in? Replica set controller manager. Okay. Now let's do one thing. Let's go here and see the detail of this deployment. kubectl describe deployment and the name. What is the name of the deployment? Name of the deployment is nginx-deployment. And let me do it here. So let's now read it. This is name, default. Can you see that there is a strategy type? Were these lines were available in replica set strategy types? Rolling update strategy 25% max, unavailable 25% max search. These were not there. Everything is almost similar as a replica set, but strategy type was not there, right? You can see replica pod status is there, but strategy type is not there. Let me do one thing. Let me take a screenshot till here. I cannot take the full screenshot because it's a huge content. So what I'll do, I'll just, this is replica set, okay? This is replica set. And let me also copy the deployment from here to here. Okay, let's go here and paste the deployment. All right, so what I do, I just copy the some part of deployment, some till here, I think, right? And that will describe, that will, then we can compare. Oh, it's a huge size. Okay, I'm just putting here. Can you see upper one is replica set and the bottom one is deployment. Here you can see there is no such update strategy or something, but here we have a rolling update strategy and the strategy type is rolling update. These 2 lines not there, it's there in only deployment. So deployment gave us the feature of rolling update. Okay, are you folks with me so far? All right, good. So let me do one thing. Let me show you how actually it works. No, deployment, you can always also type just deployment. .apps is the full syntax. You can just type deployment. Even if you could type deploy, it will work. Okay. I mean, I'm pressing tab. That is why it is taking the full name. Otherwise, it is basically deployment only. Okay. With this, let me do one thing. let me do one thing. Let me show you this rolling update in working. For that, I need to apply some trick. Otherwise, because Kubernetes does all these things very fast at the back end, we won't able to see anything. So what I generally do, let me clear this screen, go back here and delete the deployment, kubectl delete, and instead of describe, I just want to clean everything. I'll do it from scratch. Deployment got deleted. Yes, it got deleted. Now let me see kubectl get pod, nothing is there. Kubectl get replica set, nothing is there. Kubectl get deploy, nothing is there. Right, so there's nothing. My screen, my system is clean. So what I'm going to do first, I'm going to create a deployment. Okay, let me create a deployment first. I'll say vi Linux IP deployment, and I will create a deployment here. Can you see that just one thing? I mean, it's YAML is one of the simplest scripting language. Can you see this image? Which version of image we are launching? Am I launching the latest version or a specific version? Which version of image I am launching? 1.19, right? Yes. 1.19 image I am launching of Nginx. All right. How many pods it is going to create? 3 pods. All right. Okay. What are rest other things? What is the name of, what is the object type I am creating? Deployment. What is the name of that object? Nginx-deployment. Right. So that is why it's taking the name as an Nginx-deployment. And it is going to create a basically pod. Okay, it will create a replica set, and replica set will create a pod. Strategy type is what? Rolling update. Okay, is it necessary to mention? It is not necessary to mention, but that is fine. And it says max unavailable is equal to 2, 1, and max surge is equal to 1. What are these meaning? I will explain each and everything. Just remember it is mentioned in my file. Is it okay? So, and my application listens on the port number 80, so it's open the container port 80. All right, so let me save it and apply it. So we'll say kubectl apply. Can you see that pod got created? Let me show you one by one. Kubectl get deployments. Yes, it's got created. 1 of 3 is ready, not 3 of 3 is ready. Let's wait. Not 3 of 3 is ready. Okay, earlier it was just creating 1 of 3 is ready. Now it's 3 of 3 is ready. Let me see the pods. kubectl get pods. Yes, all the 3 pods are running. Name of the pod is Nginx deployment. This must be replica set. Let's verify it. kubectl get rs. Yes, this is the replica set number. All right. Now let me describe this. kubectl describe this deployment, and I'll do pipe move. I'll do line by line. So this is, we have describe here. kubectl describe this deployment. This is the name of the deployment. It got created. What is labels annotation selector? Just ignore it for some time. I will explain. Important thing here is replica is equal to 3. Desire is equal to 3, total is equal to 3, available is equal to 3. That is means current is equal to desire right now. Strategy type is rolling update. That is what we have defined. And rolling update strategy is 1 max unavailable, 1 max search. Oh, okay. Image type, can you see that image type? 1.19. This is the same image we have used. I think I have not copied here. 1 second, let me copy the YAML here also. Okay, this is the same image we have used. Image is equal to 1.1.9. Yes, the same image is here. All right. My deployment is ready. Now this information is coming from Kube. Now Kube etcd. Let me take a duplicate session of it. I am taking the same machine's duplicate session. Let me say duplicate. This is the same machine. Okay. Please focus here, because it is really difficult to show how Kubernetes works, because it does all the things very fast. As an end user, we generally won't able to see it. So what I will do, I'll take 2 sessions here. Okay. The session. Let me change the color. I'll go to change setting. I'm just taking all this pain to explain, show you something. Otherwise, I can also very easily say this is how it works and I can move ahead. Background, will modify it and we'll make it little yellowish, right? Light yellow color looks okay, and apply. Is it okay? This is another same session but different color, just to make sure that you see the difference. What is how Kubernetes work? I'll try my best to show you, but Kubernetes does all these things very fast. Sometimes it is very difficult to show. This is at the lower half. We will make some changes and we will see the result here. Okay. So how to see this? Let me see. kubectl get pod. Yes, I can see there are 3 pod, and there is a command kubectl get pod --- watch. This command is a live command. Okay. If there is any change, you can say I didn't got the next prompt, right? I didn't got the prompt. It is still there. It is live monitoring the pod. It will keep watching the pod. If there is any change in the pod, you will show here, right? Some will get created, deleted, or whatever. Let me first scale the configuration. Instead of 3, I want to launch 2 more pod. I want my replicas to become 5. Okay. There are a couple of ways to do it. Okay. If I want to scale, okay, scale means scale in and out both. Scale in and out. I mean, scale in and out both. What I can do, first thing is modify the YAML file. Okay. So let's try this one. We'll go to our YAML file and reapply the YAML file. I'll go to this yellow white one because here this is my lab. This is the result. So I'll open the file vi-deployment.yaml. It was 3, right? Let me make it 5. Replica is equal to 5. All right. But I have just changed the file only. I have not yet reapplied. How to reapply it? Same command. kubectl apply. kubectl apply -f and enter. Can you see that 2 pods are creating? Are you folks able to see it? People will just say scale and they'll say, okay, you can see the number of pod will increase. If you can run the watch command again, how many pods we have? 1, 2, 3, 4, 5, and we have seen live, like, it got created. Right? Now, this is one of the method. What is the first method? Modify the file, and this is the recommended method. This is the recommended method. And that is why, remember I told you how many ways we can modify the configuration. There are launch an object. What are the ways? First one is known as imperative way. Second one is known as declarative way. We are using declarative way because we have a file. And this is the importance of declarative way. You have file. You can make some changes and reapply it. Whatever changes you are making, you can first take the backup of the file, like my deployment version 1.yaml. And second, version 2, you can modify it. So what you did first time, what you have done right now, everything is a record available. So declarative is more better way of launching the Kubernetes object. Imperative, you just directly make it changes with the command prompt. Are you folks getting it? Can I directly make the changes with the command prompt? Yes, I can make the changes with the command prompt. Let's go here and see it. kubectl. What is that? Scale deployment. Which deployment? nginx-deployment and replicas. Let me scale down, right? Let me scale down. How many pods we are running? 5, right? I'm scaling down to 2. So what it should do, instead of creating, what it should do? Terminating, isn't it? What is the command? kubectl scale. Let me just check the syntax of the command. And name of the deployment, let me try this one. Can you see that 2 pod got terminating? If you want to check the number of pod, we can just see how many pod right now? 2. Because my desired state is now 2. That is why 2 here. This is the second way. Second way is what? Do with kubectl commands. Third thing is little dangerous. Okay, is known as kubectl edit command. We are directly modifying etcd database. etcd database. How to do this? Let me show you. I will just create little bigger. I think here we have 2 pods. Out of 5, because we have not changed the image, we have not changed the configuration. It's the same image, same thing. I have 5 pod, 1, 2, 3, 4, and 5. Out of this, I want to delete, I want to keep only 3. So what it will do, it will just delete running 2 and any random 2. Yeah, because I've scaled down, but I have not changed the image. Have I changed the image? Rolling update will come only picture when I will change the image. Image is same, Nginx 1.19. Are you getting it? The same image, same code, same image. But instead of 5, I want to scale down. I'm scaling down, scaling in. Okay, when we change the image, then rolling update will come. When we want to upgrade or downgrade application, change the version of our application. Okay, don't get confused. Now, the second way of modifying the same stuff is kubectl edit and the deployment and the name of the deployment, nginx-deployment. This is, and which database it got opened? It's a etcd. Okay, and be little careful when you are modifying this, otherwise you corrupt your object. Where is the replica? Replica is equal to 2, right? Let me make it 6. I'll say 6. The moment I'll save this file, you will see the changes will start happening here. Okay, you will see changes here. I'm saving this file. Can you see that? It is creating. It will create 4 pod. The message is repeating itself. That is why you are seeing so many numbers. But if you Control C and if you just do watch again, you will see how many pod? 1, 2, 3, 4, 5, 6. So what are the ways we can modify the configuration? Safest way, modify the YAML file, reapply it. Another way with kubectl command. The dangerous, it's not recommended. If you are little comfortable with Kubernetes after 6 months, then you can use this edit method and directly modify it. Okay, so it is just scale in and scale out. Same image, same everything. Now let's go ahead and change the image type. Right now we have an Nginx image that is 1.1.19. With this image, we have created a deployment. Okay, and this deployment has created 4 pods for us, right? Pod, how many pods right now we have? Let's see how many pods we are running right now. 4 or how many pods? Yeah, you should use deployment. Let me see, kubectl get pod. I'm having 1, 2, 3, 4, 5, 6 pod, right? So this is current situation. We have 6 pod. Okay, this is pod number 1. Okay, this is pod number 2. And this is pod number 3, pod number 4. Okay, pod number 5, pod number 6. Now I want to change my image. Okay, this deployment has created 6 pod. Okay, this is the status, right? Okay, this is the status, right? It has created 6 pod for us. This particular deployment has created 6 pod for us, right? Now I want to change the image. Say for example, I want to change the image from 1.19 to 1.21. Say for example 1.21. Okay, with this, what I want to change this image in my deployment configuration. Okay, then all these pod are running with what image? 1.19, 1.19, 1.19, 1.19. I'll say mention just 19 here. Just imagine this is 1.19. All these are 19 version of my application. 19, 19, and 19. Okay. Now I want to upgrade my application. I want to upgrade my application to 21. So like this I want to do. Okay. I want to upgrade my application so that pod should run with the new image 21, 21, 21, 21 and 20. Using the same deployment. Okay. I want to use the same deployment so that it should launch this, something like this. This is 19, this is 20. Ari, this diagram is clear. This is what this is current status. This is what current status is. This is what we want to achieve. This is what the target is. Okay. Deployment has a feature. If you go and read it, okay, and if you say kubectl describe deployment, Nginx deployment, there's a feature. 3 lines are important: replicas, max unavailable, max search. Okay. Actually, this line is very important. Strategy type and these 3 lines. Let me copy these 3 lines. In deployment, there is these 3 lines. Just remove this line. Feature, it is going to use rolling update. Max unavailable 1, max search is equal to 1. What is the number this means? It means that maximum how many new pod it is going to launch one time is equal to 1. Maximum how many old pod it is going to delete one shot. This is also equal to 1. This is what max search and max unavailable. Max search means this is max search and this is max unavailable. Okay, max search and max unavailable. It means that how we are going to reach the target. What it will do, it will first create new pod with version 21 here. Okay, because max search is equal to what? 1. When this pod is up and running, what it will do? It will go and delete one of the old pod. Then again, what it will do? It will, one second, let me put the diagram something like this. Okay, what it will do? First, it will launch one new pod. Then what it will do? It will delete one of the old pod. The next time, what it will do? It will again go and launch one new pod. Then it will go and delete one of the old pod. Why it is doing in 1 because it is mentioned in the configuration max search is equal to 1 and max unavailable is equal to 1. Can we change this number? Yes, of course we can change this number. We just need to modify our configuration here and maybe 2, or you can also mention in the term of percentage, 25%, 30% like that. Or otherwise, if you are okay with this configuration, let's see how it runs first. The answer to your curiosity is like, can we change this number? Answer is of course yes. How? I have already shown you. You can just modify this file and do kubectl apply, reapply that file. It will change this number. Okay, don't worry about it. So, but let's see first how it works. Okay, changing is not a rocket science. You can very easily do it. First, let's try to understand how exactly it works. Max search is clear. Max unavailable is clear. Max search, first it will search, then it will make it unavailable. What it will search? The new version. What it will unavailable? The old version. Okay, it will keep launching one new pod, deleting one old pod, launching one new pod, deleting one old pod. Then it will launch another new pod and it will delete one of the old pod. Then again it will launch one new pod and it will delete the another last old pod. So this way it will replace all the old pod with the new pod one by one. Is this rolling update feature? Is this update is happening by a rolling update? It is rolling update. Let's see in action. So we have 6 pod. I think I'm already sharing this file every day, right? And let me do one thing for you folks. What I can do here is what I generally share. So at the end, what will happen? Okay, at the end, I'll have something like this, right? I'll have something like this, right? So what is this diagram? This diagram is like this. All the old pod will get deleted. Okay. I'm telling you the final configuration. This is the status. Okay. Let me take a screenshot of it. All right. So it will be with you always. Now let me run this. We are already modifying the image. If it is image, it means that already somebody has written the file, created the Docker image and uploaded the Docker image. That in the backend you have to do. We are using public image. Process will remain same. Are you getting it? We are modifying the image. It means somebody has written the Docker file and uploaded a new image there in the Docker hub. If you have to do it in your application, you have to write Docker file, Docker image, Docker login, Docker push, and then you have to write deployment.yaml and change the file configuration and run this command. What do you mean by manually? At least you have to you have to inform Docker. I mean, you have to inform Kubernetes that you want to change the image. Decision is your right. Kubernetes will do it for you. So first focus over the command. The command is first way of doing it. First method is by command by kubectl, because this is also a modification, right? By kubectl command. And this is you can do with this kubectl set image. I want to set image of deployment. Pick deployment nginx -deployment and nginx -container image is equal to 1.21. Instead of this one, we can say nginx container image is equal to 1.20. What is the current version of image? 1.19. If you want to verify it from the configuration, you can run command kubectl describe deployment nginx deployment I grep -i just grep image. Can you see that we have current image 1.90? I want to change this image. Right now I am having 6 pod running. Okay. Let me control C clear the screen. Let me run this command again. I have 6 pod running. Now I want to change the image. Let me run this command. kubectl set image. Okay. Set image deployment. Which deployment? This deployment. Which image? nginx 1.21. Can you see that some pods are creating, some pods are terminating? Are you folks able to see it? Can you see that it is creating and terminating in stages? But it is happening very fast. It's very difficult to identify what actually it is doing. But we can see that we have terminating messages also and creating messages also. Right? And now I think everything got completed. Let me see Control C and run this command. I have all pods got created just few seconds before. 19 second, 28 second, 18 second, 29 second, just few seconds before. All right. Running. Is my image got modified 1.21? Is my image got modified? Yes, my image got modified. Old pod are gradually terminated and new pod will be created. First new pod will get created and one old pod. In what number, in what percentage? It depends upon these feature. Rolling update strategy. If you mention one here, one will get created, one will get deleted, one will created, one will deleted, one will created, one will deleted, one deleted, one created, one deleted, one created. Like this fashion, it will move ahead. Okay. This number, can we change it? Yes, of course we can change it. We have seen how to change it, right? We can modify, open this file, put whatever the number you want, done. But the best option is 25%. By default, it's 25%. You can use the default one, 25%. If you want to see the rollback strategy, I mean status, okay, you can run this command kubectl rollout status. It will tell you like what is the status of the rollout. can go here and run this command. You can say successfully rolled out. Okay. If you at any point of time, if you want to roll back, okay, any point of time you want to roll back, you can do rollout undo. Rollout undo is the command. Okay. So let me. Okay, what is the command? Rollout undo. If I'm doing rollout undo, definitely here some changes are happening. It is going back. It is going back to what? It is going back to 1.19. If you want to verify it, can you see that current version is 1.19? Because I have rolled back. Let me quickly summarize it. What we have done, basically we have created a deployment. And why we need a deployment? Because deployment is going to launch something known as Replica Set, and we know that Replica Set is going to launch something known as pod. This flow we know. But what feature that was not available with Replica Set? The rolling update. Why we need a rolling update? Because you never seen website like, have you seen you log into Netflix and says we are down for maintenance? Have you seen this message anytime? I have never seen that message. I have seen this message in IRCTC, right? Have you seen this message in IRCTC? It means that IRCTC is a bad design. No, this is very good. I mean, sometimes you may get this message even Netflix also. It's not like Netflix is like very no, definitely Netflix is very well designed because they have I know their architecture is very well designed. And in Netflix they are also something like Chaos Monkey script. They will purposefully shut down their machine randomly just to make sure that their high availability is working or not. If you want to read about it, just search for Chaos Monkey Netflix. Okay, so that's a different story. But what I'm trying to say, nobody wants to shut down their business even for a minute. Domino's, Pizza Hut, Zomato, Swiggy, Ola, Uber, whatever it is. They want their application Rapido. If they shut down for a minute, they will lose good amount of money, right? People are all over the India, all over the world using their application. So that's the purpose. Nobody want to shut down their business. If we are using rolling update, then what will happen? I mean, just Replica Set, because Replica Set doesn't have the speech feature. If I want to upgrade my application, upgrade is a normal phenomena. Yes, we always get a message that new version of application is available. Right? It means that there is a team working on the enhancing the application, fixing the bug in the previous release, and adding more and more and more features. Right? So upgrade is unstoppable. Your application will definitely upgrade to enhance it so that more and more customer can join, right? Because ultimately it's all business, it's all money, right? So deployment is a better thing rather than Replica Set. Now the question is, do we only do application upgrade, or we also do some other kind of upgrade? We also do some other kind of upgrade. Maybe I want to scale my number of pods. I want to change something, some configuration. So what are the ways we can do changes in the deployment? In deployment, these are the two things that is one thing. There are a couple of ways we can change the configuration. First is there is first method with modify the YAML file and reapply. Okay, that's the first, and this is the most safest way and recommended way. This is the first method. Okay, what is the another method? Another method is basically you can run kubectl apply command. Okay. Second method is via command directly. Okay, you can do it with the second method is via command directly. What do you mean by that? Here we have upgraded our image via command only, right? We just run kubectl set image, right? Can we do in other way? Yes, we can do it another way. If I go here, open the deployment file. I have nginx.deployment. Just vi that file. What is the current image mentioned here? 1.19, right? Let me change into 1.21 and reapply it. This is another method. Okay, this is another method. I have changed the file, but it's a file only which got changed. My deployment is not got changed. What I'll do, I'll say kubectl apply -f in the name of the file. What is the current version of image? Right now also is 1.19, right? We have just roll back. Let me reapply that file. Can you see here? Yes, it got started changing same way. Either with the command prompt or with the file. Same thing is happening. Okay. Now if I go and see what is the image version. Yes, 1.21. Which one is better? It's your decision. I prefer this method. Because why? Because I can take backup. I know what I am doing. I am recording the things. With the command prompt, I am running command, and after 6 months, somebody asks, hey, why you change this? I have no answer because I don't recall like why I have run this command. I don't know. But if I am doing with file, I know. Early, I'll take a backup of this file and I'll reapply. And I'll mention something in the backup. Changes, I'll put some comment. This change I am doing it because a new version of application got released. We were working on this bug, it got fixed. We are reapplying. Whatever you want to write, okay? That is something. Third thing is again, can we change something some other way? Yes, there is a way we can change it via kubectl edit command. Alright. kubectl edit command. Can I change the image also with kubectl edit command? Yes, why not? Let's do it. kubectl edit. What I want to edit? I want to edit deployment. Which deployment? nginx-deployment. Change it. This is I'm modifying the etcd database. Open this one. Go down. Yes, 1.21. I want to change you. I will make it 1.19. Is it changing? Let's see. It is changing. Can I let me make sure it's got changed? Yes, it changed. 1.19. Are you folks getting it? There are three ways, or there are a couple of more ways, but this is enough, right? These are the three ways we can change it. Okay, so either you are going to change with the command prompt or with the file, it is your choice. But we can change some configuration of deployment. Yes, we can definitely change some configuration of deployment. Okay, we can definitely change some configuration of deployment. Okay, is everything everything is possible? No, there are some parameters that we can change, there are some parameters we cannot change. Okay, so these are the methods. Why deployment? Because it has a rolling update feature. How to apply rolling update? These three methods. Okay, is only rolling update only always we can change the version of upgrade application? No, we can change also scale it, scale out, whatever the things that we can change via these three methods. Yes, we can change it, Leslie. If you want to change the port number and all, you can change it via file. File is the safest way. What I'm going to do is we are going to launch an EKS cluster. Okay, let me walk you through the steps. Yes, EKS is a paid service. So here I can see here, this is my Mumbai region. Let me go to Hyderabad. Here you can see there is one EC2 instance. Okay, this EC2 instance that I have created already. Let me start it. Let me launch an EC2 instance from scratch so that I can show you. This I'm selecting Amazon Linux. Okay, and it is T3 micro. Then select a key pair. I'm selecting VPC and all. Okay, so it's simple. So let's see the instance. So this EC2 instance, you can see it is running. So let's connect to this EC2 instance. All right, so this is an EC2 instance that is running. Is this my EKS cluster or it is just an EC2 instance? Okay, so this is just an EC2 instance. So what we have done here is we have created this EC2. That's it. Okay, this is just an EC2 instance. AMZN Linux. This is Amazon Linux. Okay, and it's an EC2 instance. That's it. Now, first what we have to do is we have to install AWS CLI. So let's see how to install AWS CLI. Most of the cases, if you are using Amazon Linux, AWS CLI must be installed. Let's make sure that. So what we'll do is say AWS -- version. So you can see that AWS CLI is already installed. Okay. Everybody knows how to install AWS CLI. So AWS CLI is a command line. Just say, for example, you want to create an instance, this where I am right now. Okay. This is basically known as AWS console. Okay. This is known as this GUI, known as AWS console. Okay. Where we go to EC2, other services and create. This is one of the way to create resources in AWS. This is known as AWS console. This is AWS console. Okay. For this, you have to type URL, you have to log in and all. Second way of creation of resources is AWS CLI. This is a command line utility that you can install on anywhere. You can install on your desktop, you can install on your laptop, anywhere, and you can install even on EC2 instance. And from there, you can manage all AWS resources. That is the command line utility. So how to install it? You can just CLI installation. Here you can see there are multiple operating system mentioned here. You can install on Linux, you can install on Mac, you can install on Windows, right? So we are interested in Linux, that is AWS, Amazon Linux. So if you click on Linux drop down, you'll see that how to install AWS CLI. This is one of the way. If another way is basically, this is the command. You can just copy these three commands. Okay, what it will do, it will download AWS CLI first and install it for you. Okay. AWS CLI installation. So this is the way. First you need curl, it will download the AWS zip file and then you can unzip it and install it. What I'll do, I'll just go ahead and run all these three commands. Though it is already installed, but let's do it. So you can see it has downloaded this zip file, right? AWS zip file. And then what you need to do, you have to unzip it, unzip, and once it got unzipped, you need to install it. It's got unzipped. If you do ls, you can see this is an AWS folder. There you will see all the installable. So in under AWS folder, there is an install script. So we just need to run that script. It will go ahead and install AWS CLI. It says it's installed. Now how to verify it? You can just run AWS -- version. So it will say yes, it got installed, right? So first step is AWS CLI installation, that is done. Second step is assign a role to AWS. Okay. We will assign a role to AWS instance. For that, we'll go to console. Okay, go to your EC2 instance. Okay, go to your instances. This is my AWS EC2 instance that we have just created. Click that instance, go to action. security or modify IAM role. Okay, here you can select an admin role that you can create also and just update the IAM role. Okay, so this instance right now we have an EC2 instance where what we have done, we have installed AWS CLI here. Okay, second thing what we have done, we have assigned an admin role to this. Assign an admin role, right? Second thing what we are going to do, we have to install kubectl. Kubectl we have also installed for Minikube, right? This because this is a command line utility that we must have running in order to handle the cluster. Okay, so how to install kubectl? Here in our document. So here you can see installation of kubectl. These are the commands. First you need to download it, then you have to made executable and move into your path variable. This is exactly what we have done in your Minikube also. Same thing we are going to do because it's a command line utility that is required to run. So we'll say curl download kubectl. It is downloading kubectl. Then we are going to make it executable. If you want to see, you can see ls kubectl got downloaded, right? Just make it executable and move this kubectl to your path, that is your local bin, so that it will available your path. We'll say sudo and move it. Okay. Now let's verify that kubectl is installed or not. It's kubectl version command, and that will display the output. It means it got installed. All right, so kubectl is also installed. Where all these things we are installing on an EC2 instance. So far we have not yet done anything related to EKS cluster. Okay, we are just preparing all those things that is required to launch an EKS cluster. Okay, next thing is to install the command line utility EKSCTL. For installation of EKSCTL, what we need to do, we need to download it, untar it on a temp directory. So this is the command to download and untar it. The tar file will get downloaded, tar gzip file. You can say amd.tar gzip file. We need to download it and untar it. If you see this command, this is a silent command. Silent command is, it is not going to display this kind of output that download what percentage is downloaded. It will download from this particular location. This is a GitHub repository for EKS. Okay, and it will download the tar.gzip file. When the file will get downloaded, it will untar it in your TMP directory. The same command will do everything. You can just copy this command and run it here. And if you go to cd/tmp in your TMP directory, you can see EKSCTL downloaded here, right? So we have just downloaded the EKSCTL. It got downloaded, it got untar and everything. Now what is the next thing? We have to move this file, okay, to your path variable. We'll move this file to your path variable. Now make sure that you are able to run EKSCTL command. So what we'll do, we'll just try run this command EKSCTL works, and so it got installed. So on this machine, on this EC2 instance, we have installed kubectl, we have installed EKSCTL. Okay, so all the prerequisite got installed on this machine. Everything is got installed. Now from this machine, we are going to launch our EKS cluster. We can launch our EKS cluster. Okay, let me go and duplicate this tab. This is AWS Management Console. Okay, we can go here to services and search for EKS. If you can click here, this is an EKS Kubernetes service. Okay, this is Elastic Kubernetes service. Okay, Elastic Kubernetes service, Amazon EKS. It's a fully managed Kubernetes cluster. Okay, and it has how it works. You need to provision the cluster, then you need to connect the cluster, and then you can run your application. That's it. We are in the process of provisioning the cluster. We are here right now. Is it done? No, we have not yet provisioned. What we have done, we have created an EC2 instance. From here, we will provision this server. Okay, sitting here, we will launch the server. When the server will get launched, sitting here, we will connect to this server. Sitting here, we will launch our application. This is kind of our jump box, launching pad. This is from here, we will do everything. This is my EKS cluster? No, this is not my EKS cluster. It is just an EC2 instance. My EKS cluster is running here. Are you folks getting it? Okay. All right. So this is the EC2 instance act like a jump server here, kind of jump server for EKS cluster. Okay. Now it says EKS. Why you use EKS cluster? It's, as we have already discussed, it's a fully managed cluster. Fully managed cluster means what? It's basically the control plane is managed by AWS. Okay, we don't get access to we don't know where the control plane is running, how they're managing it, but it is managed by AWS. Okay, so that is why we call this service as a fully managed cluster. EKS, AWS CLI installation, you won't able to, we need to assign role. Okay, and without that, we won't able to create EKS cluster. That's a dependency. This is a usage here. Yeah, without it, you won't able to install. So that's a prerequisites, you can say. So this is EKS cluster console. You can install cluster from here also, create cluster. Okay, and this will give you a form that you need to configure everything, like what is a lot of information here, but somehow, this is now AWS has made it very simple. Okay, now, like recent past few years, AWS made this very simple. Earlier, it was not like that. When 2016, almost 8 to 9 years back, AWS launches this service EKS. Okay. Earlier, AWS has another service that is known as ECS. Okay, what is ECS then? ECS is one of the service. Okay, if you go here and if you search for AWS services here, you can search for ECS. So there is an Elastic Container Service. Okay, and you can see here Elastic Container Service. This is another service managed given by AWS. Okay, this is not Kubernetes. This is not Kubernetes. I say like these are the managed AWS EKS, Azure AKS, GKE, OKE, IKE. These are the managed Kubernetes service. Okay, but some of the services that is not Kubernetes is one type of container. There are some other services like Docker Swarm, Apache Mesos, Nomad, and AWS has ECS. AWS ECS is also a container orchestration tool. Okay, that is not Kubernetes. Okay, it's not a Kubernetes cluster. Okay, so that is what the point is. So here ECS is not a Kubernetes cluster. ECS is another service that is in-house, AWS in-house product. Okay, this is different. EKS is different. Okay, so we are launching EKS cluster, but in 2016 when AWS created this EKS service, okay, that time they made this launching of this EKS cluster was not that much simple. They have a lot of things that we have to give, and a lot of companies are facing issue in launching. Like it's little complex. You have to do a lot of things. To launch an EKS cluster from the console. So one of the company, what they have done, they have created a command line utility that is known as EKS CTL. Okay, they created a EKS CTL is a command line tool created by another company. Why? Because they are facing some issue in launching AWS cluster from console. So they thought like, let's create something that will make our process little simpler to launch a EKS cluster. And that tool becomes so popular that this company bought by AWS later. AWS like this utility and they say, okay, we will pay you, give this tool to us. Once they sold this tool to AWS, and now this EKS CTL become the command line utility to launch EKS cluster, and it is very, very simple. It's one of the easiest way to launch EKS cluster. Okay, here you will get a lot of confusions like VPC and all, everything, a lot of things are there. But if you use this tool, it's very simple. Let me show you. So what we have done so far, we have created EC2 instance, we have installed AWS CLI, we have installed kubectl, and we have installed AWS EKS CTL. This all done. Now from this cluster, from this machine, we will launch our EKS cluster. What is the command to launch an EKS cluster? The command to launch an EKS cluster is this: EKS CTL create cluster and in name of your cluster. Apart from that, if you want to give in which region you want to create a cluster, you have to give region, like in US East, AP South, Australia, wherever you want to create, you have to give this region. Once region is given, you can give the instance type also. You can give number of instances. By default, if you don't give number, it will create two node cluster. Okay, and if you want to specify availability zones also, that also you can specify. Okay, so here what I have done, I have written a very simple command. I have said EKS CTL create cluster. Name of the cluster is my lab cluster. Region I am creating in AP South 1. What is AP South 1? It's Mumbai, right? If you go to Mumbai, this is my Hyderabad region. Let me switch to Mumbai. In Mumbai region, if I go to EKS, you can see that I don't have any EKS cluster. If I click on cluster, there is no cluster. Okay, it says you have no cluster. So I'm sitting in Hyderabad, my EC2 instance running in Hyderabad, right? This is an EC2 instance, that running instance. From Hyderabad instance, it's in Hyderabad. Can you see that here? Asia Pacific Hyderabad. I'm sitting in Hyderabad, and from here I will launch a cluster in Mumbai region. You can launch cluster any region, okay? From any region to any region, because once you provide the region name, it will launch the cluster in that region. Copy this command and just go ahead and run it. Go to your EC2 instance and run it. Done. So what actually it does, this EKS CTL or any how cluster get created. If you go to here, let me duplicate this session. And if you go to Mumbai region, you can see my lab cluster is in creation phase. You can see it's creating. We have just launched it. This is the name of my cluster. It is creating. And if you go to CloudFormation, okay. In CloudFormation, you will see that it's created a stack, and it is the CloudFormation who is basically creating the EKS cluster for you. It is creating VPC, it is creating NAT gateway, all those resources for you, and it will create a cluster in some time. It says creation in progress, create in progress. You will see that yes, cluster is creating. So it will take, so who is actually doing it? It's CloudFormation. On the cluster creation, this command, yeah, by default it will take Amazon Linux. The nodes, okay, these nodes, what it is going to do, it is going to create a cluster like this. This is my, come on, yes, this is my EKS cluster. There will be one control plane. This is going to be the control plane. That is hidden from us. We don't know where it is running, but ultimately it is running somewhere in AWS. When you run any kubectl command, you are hitting what? API server only, kube API server of that control plane. And we are creating two node clusters. So this is node 1 and this is node 2. Okay, both are AMZN. AMZN means Amazon Linux. This is Amazon Linux and this is also Amazon Linux. Our workload is going to run here in the form of pods. Okay, this has kubelet, kubeproxy and runc. This will have kubelet, kubeproxy, runc. This kubelet will connect it to the kube API server. This also get connected to the kube API server. Whatever we are running here, say for example, kubectl apply deployment.yaml. So whatever we are running here, it will kubectl, whatever the command. This command is basically converted into an API. It will go to this kube API server, and the kube API server will instruct same way, but this is not visible to us. That's the only thing in the managed Kubernetes cluster. This is managed by AWS. This part is something like this. It's hidden from us. We don't know. All right, it is completely managed by AWS. Okay, so let's the cluster get created first. Charges for EKS, I think it is, let me just check. I need to check the documentation. What you can do, AWS EKS FAQ. Okay, any service you want to learn in AWS, first you should also read the FAQ of AWS, that service. Amazon EKS FAQ. In FAQ, there is a section of billing, integration, hybrid, pricing. This you can click on pricing. If you want to know pricing of any service, what is the easiest way? Go to FAQ and go to the section pricing. Pricing and availability. How much does Amazon EKS charge? You have to pay 10 cent, no, 0.1 cent, okay? It's not 10 cent per hour for Amazon EKS cluster. Okay, so this is the pricing. And it also depends, okay? This is for EKS pricing, okay? This is just an EKS service pricing, okay? But you have to pay for the EC2 instances that also you have launched. 2 EC2 instances launched. You are using an EKS service, right? For that service is just 0.10, right? Like 0.10 cent. Okay, this is what per hour, right? That is what. And apart from that, you have to pay for these two resources like normal EC2 instances charges, because this will create two worker node, right? If I show you here, it will make sense in a minute. This is my EKS cluster. If I go to EC2 in Mumbai region, EC2 instances running. So you will see right now, there is no instances running for me in Mumbai region. Where I have created the cluster in Mumbai region, there is no instances running right now, because cluster is still in creation phase. Okay, if you go here, Elastic Kubernetes service, it says creating. You just refresh it. It is active now. Okay, cluster is active now. Now, if you refresh this guy, I think it will create an EC2 instance here. Let me see. Just wait. Cluster is active, but still CloudFormation is doing something. Okay, still it says your cluster is this, EKS cluster is this. Still it is doing. Just wait. Let it be complete. Then you will see that there are two nodes get launched on EC2. What are those two nodes? Those are the two worker node. It is creating something else. It is installing add-ons and all. How much do you have to pay in real life projects? Overall, I mean, this is not a straightforward answer that I can give you, Amit. It all depends, like how big is the cluster, how many hours you are using. It all depends, right? If you are launching M4X large instance on your EC2 on your worker node, and somebody is launching T2 small, so charges are different, right? It is something depends upon what you have launched. How big is the cluster? If somebody is launching 10 node EKS cluster, then that guy definitely need to pay more than somebody who's launching 2 node EKS cluster of same type of instance. Number of instances, type of instances, that depends upon the total cost. I think it is done. Let's go and see if EKS instances get launched or not. Still not launching. Oh, okay. We have created in Mumbai region, right? We are at Mumbai region. Let's wait. What it says, deploying the lab cluster. Now it is deploying the node group. Okay, my cluster node group. Then node group will have an EKS EC2 instances. EKS cluster lab cluster node group. Let's go here and try to refresh it now. Still not yet created. Wait for a minute. Cloud formation stack EKS cluster. Waiting for cloud formation to create the node group. One second, Leslie. Yeah, you can see here the nodes are getting launched. This is where I am right now. I am at EC2 instance, right? What are these EC2 instances? These are the EKS CTL create cluster, right? The command that I have used, t2.medium. By default, how many nodes it will launch? It will launch 2 nodes. So that is why there are 2 nodes got launched. My lab cluster ng, that is node 1, and this is node 2. If you refresh it, you'll see these 2 nodes are running. Still status check is going on. We have not created these instances. CloudFormation created this instance. And who instructed CloudFormation to do all those things? It's EKSCTL command. Okay. Alright, so this is done. So what we have done, basically, let me quickly revise it. We have created an EC2 instance. First step, create an EC2 instance. Okay, over that EC2 instance, what are the things that it require? So first step is install AWS EC2 instance. Second step is over that EC2 instance, install AWS CLI plus kubectl plus EKS CTL, right? These are the 3 things that you have to install. Once this is done, what you have to do, you have to run command. Third step is run EKSCTL command to install, to launch EKS cluster. Okay, this is very simple. Okay, it's just a 3-step process. It looks complicated because it is taking time. Otherwise, it's just simple step. And I have prepared this document, and that document is also in my GitHub repository. Let me also show you. Otherwise, you may get confused. Where is my GitHub? Just give me a second. In my GitHub, you can go to EKS workshop, or maybe Kubernetes workshop. This one is first link for my EKS workshop, that contains all the steps. In this link, in this repository, I have a file. If you go here, it as overview. Somebody able to see EKS file somewhere? EKS 2024. I think in this directory you may have somewhere AWS EKS M. Can you see that this file? Under this repository, there is a folder 2024. There is EKS repository. Okay, so first step is launch an EC2 instance. Second, install kubectl. Tadam! Copy these commands and run it. Test kubectl install. Click here, it will get copied. Then set up EKSCTL. Download and install in the same command. Just make sure that it is running. Then assign a role to your EC2 instance. Once all these things are done, then you need to create a cluster, EKS cluster create, and this is what you can create it like this. Okay, and if And after that, you can also check it that Nginx deployment has been deployed or not. Everything you can check it. All right. The steps are here. Okay. So once EKS cluster is installed, you can see it is saying it is installed. You just run kubectl get nodes. Can you see that it's a 2-node Kubernetes cluster? This is one node. This is another node. Remember, in Minikube, we have one node Kubernetes cluster, right? I have kept this command somewhere here, right? I pasted that command somewhere, right? Yeah, get node, get pod, somewhere I have pasted. I don't know. Where is that? Yeah, here, I think, right? Can you see that in Minikube, we were getting just one node as a control plane? Here, what we are getting, role is none means it's a worker node. And there are 2 worker nodes. Why there are 2 worker nodes? Because by default, it will launch 2-node Kubernetes cluster. All right. The reason I have shown you here, we are not going to learn EKS. The reason I have shown you this, because I want to show you a production grade cluster. I cannot teach everything on Minikube. Okay, so I will show you some of the stuff that is required, how we launch cluster and where we launch it. How to add node and all those things will time permit, will show you. But first, let's complete EKS. I mean Kubernetes topic. We are going to start with Kubernetes networking. Okay, how networking works in Kubernetes. Okay, why it is 2-node? Because by default it will launch 2-node. Remember, I have shown somewhere here, right? Minimum it will launch 2-node. Okay, if you're not specifying anything, by default AWS will launch 2-node. If you want to launch 3-node, 4-node, more node, you need to specify here with node count. Okay, so we have a cluster ready. Now we'll talk about something known as deployment. So let me quickly launch some resources. We will do vi my dev.pm. This is the deployment file, that same deployment file that we have used. I do kubectl get pod. So you can see that no pod is running. If I deploy this kubectl apply -f, and before that I may forgot, so it's better to tell you folks. In here, like, in my repository, if you go to this repository, and this file is important. Okay, what you can do, you can just open this one, and I will walk you through the YAML, but this is a step-by-step document about YAML that you can refer it later. Okay, that you can refer it later in detail. But this is just a YAML that I have discussed here, how this YAML files are written. So YAML is another language. Okay, YAML is like another language. Very simple. Okay, it's not like coding, any coding language. It's a scripting first of all, and it's a very simple scripting. It's a plain English. Okay, and YAML basically works something like key and value pair. Okay, there is something key, there is something value. Like key is name, value is John. Key is age, value is 30. Right? So this is key value pair. This is the concept of key value. There is another concept that is known as a list. List is basically one key can have multiple values. Okay, can represent the sequence of items. Say for example, fruits. I can say apple, banana, cherry. Right? So this is list. Okay. Similarly, list can also have a value in the key value format. Student, under the student, this is name, this is age, this is name, this is age. So under a student, there are 2 students. One is Alice, another is Bob. Like this is name is equal to Alice, age is equal to 20, name is equal to Bob, age is equal to 22. Okay. What is important here? The important is indentation. This space you need to maintain. This space you need to maintain. You can see under the body of student, the name and the age is coming. Okay, so this is not case sensitive. There is another concept of dictionary. Dictionary is like dictionary are collection of key values pair. Okay, like user has a name, has an email. This is one user. Similarly, database is a topic and is host name, port number, code, and like this is how we write dictionary. Okay, and we have aliases and anchors also, but we don't generally use here in deployment and all. Similarly, if you see, like, there are a few other concepts. Now, if you just use the same concept of only three concepts, what? List, first key value pair, list, and dictionary. Three things. What is key value pair? What is list? What is dictionary? Now, if you use the same concept, you can see here we have written a deployment. Can you see that this is list key value pair? So when we write a deployment, let me copy this deployment here and explain this YAML. First, let me explain this simple. Okay, where is my 14 Feb? 14 Jan, right? 14 Jan, this one. This, let me first explain you this. The first YAML that we have launched is basically pod.yaml. This is pod.yaml. This pod.yaml, okay, this is pod.yaml. In pod.yaml, if you see here in this file, first is API version. Every resource in Kubernetes will have an API version. Okay, there are multiple resources, and Kubernetes put all those resources in a bucket, in some bucket. You can say some resources belongs to this API version, some resources belong to this API version, some resources belong to this API version. But how could I know that my API version is V1 or V1/beta or whatever it is? How could I know that? For that, we have list of commands. Okay, so we can verify this from the Kubernetes commands. If we go here in my repository, GitLab tutorial, GitLab, I will do EKS workshop, Kubernetes workshop. I'm looking for a file. Just give me a second. Yes, this API. It is at top, and I was looking like, let me just open these files. So here in Kubernetes, that is what also I have mentioned. What is API version? Okay, so what is API version? The API version in Kubernetes is manifest a specification version. I mean, but it is like, Kubernetes has multiple objects that you all folks know. Objects means what? We have deployment, we have pod, we have replica set, and other resources like services, config map, secret, all those things we are going to learn. So what Kubernetes does, like, they put the resources in different API group. Okay, why? Because based upon their use case, based upon their what is the purpose of that particular resource, they put into different API groups. Okay, some pod may belong here, deployment may belong here, replica set may belong here. Similarly, secret may belong here, Kubernetes may secret or the daemon set will belong here. It depends, like, it has resources in different API groups for their use case. This is what I mentioned. Group, the API group, example apps, batch, networking, and all. Version, the API version with which group, like V1. V1 is like for the public. It is for normal public. It is released. V1 beta means it is still there. It's in beta phase. Still they are testing it. Okay. So apps/V1 means the group is apps and the API is V1. Are you getting it? So this is group/API. Now if you go to the pod one, it's just V1. Okay, so because it's a pod, it belongs to apps only, so that is like API V1. And if you scroll it down, okay, and let me read the replica set, what it says, apps/V1. It means it belongs to the group and it's V1 as a this one. And if you go to the deployment, Where is our deployment here? App/VM. So replica set and deployment belongs to the same group and same API. All right. So this is how we can figure it out. Okay. So there are like V1 beta and all everything. If you want to see all the API version, you can just run this command kubectl API -versions. Okay. Oops, sorry. Let me first cancel this one. So these are the API versions are available. Okay. All these are the versions that are available. Do I need to remember everything? No, not at all. You just remember the from how to get the information API version that you can figure it out, and you want to know which resource belong to which API version, then you should run kubectl API-resource. So there are two commands, API-versions, API-resource. If you run this API-resource, okay, and I will tell you at the easiest, what is the most easiest way to remember all those things. First, I'm telling you the hard way, then I'll tell you the easiest way. API-resource will tell you which resource belong to. You can see the name of the resource is this. These are the resources like services. Services belong to, as short name is SVC, namespace, and it is belong to the kind is service. Let's see deployment. You can see deploy, the short name is deploy. Remember kubectl get deploy will also work, and it will belongs to apps group. Okay, and kind is deployment. So group information of a resource you can get from here. Replica set short name is RS. It belongs to this one. Similarly, these many resources are there. 1, 2, 3, 4, 5. You can count it. There are so many resources in Kubernetes. Are we going to learn everything? No, because some of the resources Kubernetes uses for internal purpose. No need to know, but we will know most of it. Okay, whatever we are using it. Now the question comes, okay, this all is fine, but how could I remember? This is very difficult, right? What you need to do, you go here at the internet and type command k8s.io or kubernetes.io. Kubernetes.io is the document for you. This is the document. This is the only source of truth for you. It is, you can remember each and everything from here. Okay, it is basically your document. And now who maintains this document? The CNC of the organization behind Kubernetes. Okay, so everything and anything written here is the source of truth for me. I am not going to trust on any other document. I am just going to trust on here on this document. But how to use it? Here you can see there is a list of document heading, right? Document. Click here. Go to documentation. You will see like there are some at the left pane. You will see there are some headings are here, right? And it also says how to launch a Kubernetes cluster on try Kubernetes, how to set up a Kubernetes cluster, and how to contribute to this. This is an open community. You can also contribute. There are some tutorials also. That all those things you can watch. That's not a problem. But here there is a section known as concept. That is very, 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 very important for you. Click on concept. You will see like all the resources mentioned here. Say for example, I want to learn about deployment. Okay, I want to master deployment. Okay, this is what you guys should do. What you need to do, instead of searching here in deployment, you can also reach it here from here. What is the best shortest way? You can say Kubernetes deployment and press enter. Always make sure that you should read something of kubernetes.io. Don't read these things. I'm not saying these are good, bad, or ugly, but you are at the starting phase, right? You are building your concept, because nowadays everyone is writing blog, everyone is writing creating YouTube channel and all. So you should not watch each and everything, because sometimes I have seen those people doesn't know the concept and they are teaching, like they are creating a YouTube video and teaching, because nobody can correct them there. So the best thing what you should do, you should read authentic documentation. Who is authentic? Kubernetes.io, because these are the guys who are behind Kubernetes. Okay, so whatever they are telling is truth. If you want to read AWS, what is the best place? AWS documentation. Are you going to read somebody Medium article or AWS document? Obviously AWS document, right? So here also you need to read kubernetes.io or k8s.io. Click here. This is how you can see we are coming from concept only. Concept, workload management. So if you go here, concept and workload management, you'll see deployment, replica set, stateful set, all those things are here. If you click on deployment, so you can see deployment. What is deployment is written here. the best part, the easiest part, if you are facing some issue in writing those YAML, click here. This is what I do most of the time. Okay, I'll copy this deployment in my file here. Okay, and if I have to modify it, say for example, I have to create a deployment with name my deployment. So I'll change the name. I'll say it should be my deployment, and I want to create replica is equal to 10. I'll say 10, and instead of this everything I'll say 14.2. Okay, I want to create with latest, then I'll remove this tag. Done. My deployment YAML is ready. What is this apps version? That is also given. Okay, so initially what you should do, you should use this documentation, how to use it, copy this YAML, change something and apply it. Okay, or directly if you want to apply, that is also not a problem. You can apply it directly. And even if you want to, without downloading, if you want to do it, you can just copy this link. Otherwise, you can just do kubectl apply, that will automatically get applied. What I will prefer, I will say, go copy this link and go to your machine and do wget and download this YAML. So you can see this YAML got downloaded. You can see this YAML got saved. Okay, and if you ls this YAML, you will see yes, this YAML is here. nginx deployment.yaml. Okay, you can vi this YAML here and modify it directly and apply it. Are you folks getting it? Okay, let me just run kubectl get pod. So we can see that there is no pod running. Now if I go and deploy this YAML, if I say kubectl apply -f and the deployment, this deployment we have copied from the same website, right? We have created this deployment. So it says, it's give me a message deployment got created. Now if I go ahead and say kubectl get pod, yes, pods are running. And one more thing, if I say kubectl, okay, get pod -o wide means a long listing, a detailed information of this pod. So can you see that? Let me copy this output in the notepad. I think with more visible here. I want to show you in one line. Okay, this is the actual command output, okay, because it's in one line. You can see what is this is name, this is ready, status, repeats, age, IP, node, on which node they are running, and this. So let me delete these things because this is not required for us. I'll just delete it so that I can extend. Okay, now you can see it is little bit better. Yeah. So here you can see we have this is the pod name, and this is running on these node. Okay, 1, 2. There are two nodes, 172 IP and 237 IP. Out of which, just observe it. This is two node. These are my two nodes. This is basically 172 IP. This is 237 IP, right? This is the, and out of these three pods, two pods are running on 172 and one pod is running on 237. This is okay, fine. This is what we can see. And each pod has some IP address, right? All right. Each pod has some name. All right. That is okay. This is just my observation. We are just make a note of it. These are the IP. Let me do one thing. Let me go here and delete this 36 IP address, this pod. What is the pod name? This is the pod name. How to delete a pod? kubectl delete. And what I want to delete? I want to delete pod. Which pod? This pod. Pod deleted. All right. Now let me run the same command. Yes, pod got created 6 seconds before a new pod got created. But if I observe this pod, okay, if I observe this pod, I'm just copying the first line, okay, so that it will be little easy to compare. If I observe this pod got deleted. Let me delete this line also. Okay, this is just got created 6 seconds, but the IP was first 2.36. Now the IP is 1.23 and it is launched on the same node, that is fine, but the name also got changed. So can we make an observation in deployment? Okay, in deployment, when a pod getting replaced by another pod or new pod. Why it is getting replaced? Maybe the old pod got deleted or something. Then in that case, what happens in deployment? When a new pod getting replaced by the old pod getting replaced by the new pod when it got deleted, there are two things. First thing, the name of the pod changes. That is correct observation. Yes. What is the second observation? The second observation is the IP of the pod also changes. Can you make this statement? Yes, that is correct. This happens in deployment. Right? If you don't believe it, let's delete 135 and 248 both the pod. Let me delete it. kubectl delete pod, and I am going to delete this time this pod 135 and 248. The pod got deleted. Yes, let me run the same command, get wide. The 135 IP got deleted, 18 got launched, 240 got deleted, 180 got launched. The IP at P66PP is got replaced by V5ZM and XCP. Right? Both the pod name is changing and the IP is also changing. All right. This is just an observation. Okay. This is just an observation. Yes, the pod is getting created, then the pod IP and the name is changing. Now tell me one thing. If I want to communicate to machine, this is machine one. Okay, this is computer one, or let me launch my computer only. Say for example, this is my laptop. Okay, this is my laptop. This is your laptop. Okay. I want to copy a file from my laptop to your laptop. Okay. What is the first thing that I will ask you? I want to connect these two over a networking. Okay, I want to connect these two over networking. What is the first thing that I will ask you? Say for example, this is me. Okay, this is Kumar, and this is, say for example, who else is Abhishek. Okay, Abhishek, what is the first thing that I'll ask you? I will ask you, Abhishek, tell me the IP address, right? IP address. I'll say, hey, what is your IP address? Right? But if IP address, that is fine. But say if this guy's IP address changing, it's not permanent, if it is not fixed. What about this network connection? This goes for a toss. Are you folks getting it what I'm trying to say? If the destination machine IP address keep on changing, when keep on changing, it's not like changing, but it's not permanent. And I'm using that IP address for my configuration, then IP is changing. So this is what happening with the pod. Pods, their name is changing, their IP is changing. If this IP is changing, can I transfer this file to here? No, right? It's not possible. I need to perform this exercise at every now and then. If it is changing, it's not possible. So that's the problem with the pod networking. I mean, this pod. I mean, if you want to connect with this pod, in our case, we have, say for example, it's a 2-node Kubernetes cluster, right? This is node number 1. This is node number 2. Some of the pod, let's say for example, this is login pod. This is login pod. Login like pizza login, okay? And this is menu pod, like pizza menu, our online pizza. Say for example, login is running here, menu is running here, or they are running on the same machine also. It doesn't matter. Say for example, menu is also running. One pod is running here, one pod is running here. Now login wants to communicate with the menu pod. You can connect to this or this, but the problem is menu pod is IP is not fixed. It may change, so I cannot trust over just the IP. So this is where the Kubernetes says, okay, if you want to connect these pod, you need to work with services. Kubernetes says, if you want to communication, launch services. Services is service or services, whatever you want to say, service we call, or short form is SVC. Is the short form SVC. Remember, we have seen all the short form here just now. Is a command get resource, right? API resource. here we have seen services, right? Services, where is services? Short form services, SVC. Can you see that service SVC, right? And this is services, okay? So SVC, services. So you have to use services in Kubernetes resources, but there are a couple of types of services, okay? Services, there are a couple of types. First, coming over the type, first let me explain you the type of communication. If this is my Kubernetes cluster, okay, this is my Kubernetes cluster, okay, this cluster will have nodes like, this is my node A, this is my node B. If I say in my case, if I go here and say kubectl get nodes, so I have two node cluster, that is, I'll say 172. I can say one node is 172. This is, say for example, this node is 172, okay, and this node is 237. All right, these are the two, okay. And if I'm deploying the pod, if I'm say kubectl get pod -o wide, I can see that two pod are running on 172, one pod is running on 237. All right, so this is, let's say this is one pod 172, that two pods are running. So I'll say two pods are running here like this, and one pod is running here, right? This is the structure of our Kubernetes. Are you folks with me? So here there are two types of communication. First communication is like this pod is going to connect with this pod, or this pod is going to connect with this pod. But all the communication is happening within the Kubernetes cluster. The communication is not going outside this boundary, right? This type of communication, we say that Kubernetes is smart enough, it will maintain I will show you how these IP and everything is maintained. Obviously, if they're same IP, there will be conflict. But the IPs are same? No, not. IPs are different. All the pod has a different IP. If IP is same, yes. If there are so many if and buts, right? But here IPs are different, right? All the IPs are different, so there is no chance of conflict. Just focus here. All this communication is internal to Kubernetes. The traffic is not going outside this boundary. Okay, this type of communication we say internal communication. For internal communication, we have type of service that is known as cluster IP. Cluster IP is a type of service that we create for internal communication. All right, what type of communication? Internal communication. Okay. Similarly, any traffic, say for example, coming from outside to this Kubernetes, this is known as external communication. For this external communication, we have node port. This type of service is node port, and that is for external. Okay, two type of communication, two type of services. Everyone is with me so far? What are the internal communication? Any communication that doesn't cross this boundary is known as internal communication within the Kubernetes cluster itself. What type of communication that will be within Kubernetes? When you log in to pizzahut.com, after login, when you log in to pizzahut.com, okay, you are making external communication to the Kubernetes cluster or internal communication when you log in from outside? External. But when login pod is connected to the menu pod, it's a internal or external? Internal. Anything, menu connected to cart connected to payment connected to delivery, all these are internal communication. But anything that is coming outside is an external. You are getting an order confirmation. Yes, order is confirmed. It's an internal communication or external communication? External. So based upon that type of traffic, we have type of services. Now let's first focus on internal. So what we will do, let me clear my machine. Do you have anything running? HTTL get deploy. It's not fit, it's get. Let me delete this deployment. kubectl delete. The deployment got deleted. Now let me relaunch this deployment. So first of all, we are going to create a deployment. Let's say this deployment is very simple. What I will do, I will just make here, instead of 3, we'll launch 8 pod. Okay, let me apply this one. All right. See, kubectl pod. I can see I have 8 pod running, right? These are the 8 pod running. When you see this deployment, okay, this deployment.yaml. In this deployment, okay, there are a few things that you need to do. Deployment has an API version, like this is the first line. This line is basically is API version v1 specifies the API version for the deployment resource. Kind is basically indicates that what is the resource type. I mean, there are so many resource type. So one of the resource type is deployment. You are creating a deployment resource type. Okay. And then we have metadata. You can see this metadata line number 315. Metadata provide data about data. I mean, what is information about metadata is basically going to provide information about this deployment. What is the name of the deployment? What is label? Label means kind of a tagging. In AWS, we tag a resource, right? We put some app is equal to Nginx. This deployment, remember, this we are creating a deployment. Deployment in turn going to create 8 pod. 1, 2, 3. Just imagine these are the 8th. This is 8th pod. This is first, second, third, and in between 4, 5, 6, 7, and 8th. This is 8th pod. Okay. When this is 8th pod, okay, it is getting run. So first of all, this is the name of the deployment. This is the name of the deployment. Okay. This is the name of the deployment. This deployment got a tag. What is this? App is equal to Nginx, a sticker. Then it says specification, technical information about this. It says 3 pod. It is going to launch 3 pod. Okay. So don't 8, it is 3 pod. In this example, it is 3 only. So these are not 8 pod, these are just 3 pod. Okay. So let me just, I think I can erase it. Yes, if I am not. Yeah. So this is just 3 pod. Okay, now if I go ahead and kind of see like this one, this is the app is equal to Nginx is the tagging of this particular resource. Then it is going to create 3 pod. There is something known as match labels. What is this labels? I'll come to that. Labels. What is this labels? Labels are the resources, that resources it get launched. They are also getting tagged with app is equal to Nginx. All these pod that we have created, that will also have a tag. And if you want to see this, if you go here and just run kubectl get pod -- show -- labels. So this pod is going to show you these labels. App is equal to Nginx because we have created 8 pod. Can you see this? App is equal to Nginx, app is equal to Nginx. All the pods are got labeled with the same thing. Okay, all these pods are got labeled with the same, and there is something known as pod template, and all the pod template are also 54955B. Every pod has the same template. What is the meaning of this template? I will tell you in a minute. First, let's go back to this YAML. So we understood this. This is what labels and all. So metadata is basically provide information, okay, specification, and spec section. Okay, spec section, if you see, spec section is like technical information. Replica specify there are 3 replicas to be created. Selector defines how the deployment identify this pod. Okay, this is very, very important. Selector information. Now tell me, in our case, Kubernetes solve all these networking problem with very simple concept of match labels and selectors. In our case, remember I said like for each of these microservices, you are going to write Dockerfile, Docker image, Dockerfile, Docker image, Dockerfile, Docker image. Using this Docker image, you know what you are going to do? You are going to create deployment. Deployment for all these, I'm just typing deploy, okay? Small deployment spelling is quite, okay, this is deployment. You are going to create deployment for login. Okay, now you are getting it. You are going to create deployment for menu. You are going to create deployment for card. Okay, you are going to create deployment for payment, and you are going to create deployment for delivery. For each microservices, you are going to create deployment. In login microservice deployment, you will say image is equal to login, not Nginx. You'll call your own image. I will show you how to call your image also in deployment. Okay, because Nginx is a publicly available image we are using for test purpose. But in our own case, we are going to call our image, just like we have uploaded an image in Docker Hub. That image we will call here. Remember, we have uploaded an image Docker here in hub.docker.com, some node app v1. I have given you the path, right? This one somewhere I have here, right? I think you guys are getting it, whatever I'm telling you. So you have to specify your image here. Similarly, for all these microservices, you are going to specify menu image in this deployment. In this deployment, you are going to specify the cart image. In this deployment, you are going to specify the payment image. In this deployment, you are going to specify the deploy image. The point is here, when this is the case, what will happen? There will be number of pods, login pod, menu pod, and all these things. Say for example, I'm just telling you couple of example, like couple of let's take two microservices, login and menu, just to keep the diagram little cleaner. Okay, otherwise it will become little. And login and menu pod. Okay, say this is one more pod. Let me deploy it. Say for example, both has replica is equal to, this is one login pod launch here, another login pod launch here on this node. This is menu pod launch here, and this is the menu pod launch here. For this menu pod, there is a deployment.yaml for menu. Okay, this is dep.yaml for menu. Okay, underscore m for menu. Similarly, we have dep.yaml written for login. Are you folks getting it? So how deployment login will know that this is my pod or the menu pod? Login will has some mechanism to identify that this pod is created by me, and menu has some mechanism that this is my menu pod. How we do this? Via tagging, via label. Whenever we create application, what we say, match label here will say app is equal to login. Okay, app is equal to menu. So what will happen when you create a deployment of login? It will have app is equal to menu, 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 menu. App is equal to login. If you create a login deployment, it will have login, 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 login like this. So we tag them like this, just to identify. This is what it's saying. Specify, and selector is a field that will match that label. What is your container label? That will match. So you can see template is saying metadata label is equal to app. All your pod will get this label, and all these things will generate a hash. Okay, all these three things will generate some hash, hashing character that is always different from any other thing. So your pod will have two things. First, whatever the label that you are telling, that will have a label and a hash code of all. It will take all these character and generate some hash. Remember SHA-1 hash in GitHub? Plain text get converted into hash. So this is what this hash is. Okay, so this way your deployment will be different. All right, are you folks getting it? So this is the selector, defines how deployment will identify the pod via labels. Template define the pod specification, that is an hash node. This is also different for different. It's unique for one deployment because those character will be different. Okay. Then we have specification about containers. You can see in the container field there are two specifications, that is container. This is technical information about the deployment. This is inside the deployment we are going to create pod, and the pod will have a container. So container will have its own name, so that is why nginx-container is the name of the container. For container we need an image, so that is why we specify the image. And port, we know that if we want to open a port on a container we have to specify the container port. Okay, are you folks getting the each and every line from line number 16 to line number 33? Is this clear from here to here? Everything?
Just a quick info, guys. Intellipaat, in collaboration with Microsoft, offers an advanced DevOps certification course. This course is designed for both beginners and experienced professionals, featuring live instructor-led sessions along with self-paced video content to help you become a skilled DevOps engineer. You'll master modern DevOps methodologies, practical DevSecOps practices, and also the use of generative AI tools in CI/CD pipelines, automation, and infrastructure management. You'll also work on 60 plus hours of industry relevant projects and case studies, real time labs powered by AWS simulating production level environment, 15 plus in demand tools used across the industry. With 24/7 support, placement assistance, and EMI payment option, this course without a doubt can set your career to new heights. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Also, visit the course page given below in the description and take a first step towards career growth in the field of DevOps.